Hello, YouTube, Facebook, and Twitter. It is APEC March 12th. Let me know how the sound is. We are streaming.
And we had two different research librarians trying to find it. And the impression that they gave me was, again, not that it was suppressed, just that, you know, I mean, they're a big, busy subcontractor, right? And they just didn't get the value of it, so they didn't know what to do. Here, I'll paste Enemy at the Gates into chat. If I can find my chat.
That was one of the last times that Ning Li publicly presented. So there would have been historic value on that.
Alrighty.
Nice hair.
Showtime. Thank you, Lula. All right. 5, 4, 3, 2, 1. We are live with the APEC conference. I'm just going to start it up here while Tim gets ready. And our host, Tim Ventura, will announce the show shortly and announce our first guest. Welcome, everyone in the chat. We got Brian Kelly here. Mercury Interstellar LLC. All APEC invited this summer to Michigan for a build demo on gravity control and anti-gravity, the heart of the entanglement from gravity-causing spectrums. Awesome. We'll have to get you on and maybe on the open chat later at around, 6 p.m. Eastern time. If you want to jump on the show, just let me know. I can get you a link, Mercury. And good to have you here. Hello, chat. Big and Chow. Jeremy Goodjoy. Welcome, everyone. We are live, and I'll hand this over to Tim and take it from here. Awesome. Thank you, Jeremy. Okay, so let me do this. I'm going to mute everybody out. Okay. And I'm going to spotlight myself briefly because Zoom has been acting a little funny lately. So, 3, 2, 1. Welcome to APEC. It's March 12th, and I'm your moderator, Tim Ventura. First, I'd like to thank everyone for joining us on this call, along with everyone watching us on YouTube. In today's session, Ron Evans is going to discuss gravitomagnetism and its role in gravity propulsion. Riccardo Storti will provide analysis on Bob Lazar's UFO tech claims. And Todd Desiato will discuss his experimental research into Biefeld-Brown Lifters. We're also going to have Sokol Falcon Space provide detailed lab updates, the results of their latest experiments. We're going to finish off the event, as always, with an open discussion and ad hoc presentations by conference attendees. So, our reminders, you can view those conference replays, details, and speaker info on our website at altpropulsion.com. Please save your questions for the Q&A session after each presentation. You can raise your hand in Zoom using Option Y on Mac or Alt Y on Windows. You can also type your questions into chat. We will go through those after each presenter finishes. Again, it's a little easier if you raise your hand in Zoom. That is Option Y on Mac or Alt Y on Windows. Okay, so now I want to introduce you to our first guest. Ron Evans, the former head of BAE Greenglow, will begin with the importance of analogs, understanding gravitomagnetism, what is inertia, free fall, Lazar's claims, the effective mass of a photon, and Einstein's gravitational redshift. Lastly, he will speculate about how a gravity field might be generated electromagnetically. In revealing this theoretical idea briefly mentioned in his book, he's looking for experimenters in the audience to help test these ideas. So, he joins us today to discuss gravitomagnetism and its role in gravity propulsion. Let's welcome Ron to today's event. I will hand things over to him, and I will be doing the slideshow for him. Okay. Ron, can you hear me, sir? And let me ask you to unmute.
go?
Yes, and welcome, sir. Welcome.
Welcome, and thank you for inviting me. Thank you.
Okay.
So,
would you like me to share? Would you like me to share your slideshow?
yes, please.
Okay. Let me see if I can do this correctly. You guys do it all the time, but I don't do it that much. So
I can't do it at all. Right. Am I ready to go?
You know what? I may have to. You are, but where's the play button? Maybe somebody could chat me, tell me how to play. Here, you know what? Ron, give me just a second.
Oh, I'm glad it's you and not me. I'd be panicking by now.
Yeah. Let me see. Slideshow. There we go. Play from start. Perfect. Okay, we have 12 slides. Can you guys see me okay? All I can see is the slideshow.
Okay. Am I off?
And you are spotlighted.
Okay.
Yeah, so I will mute myself out.
So the first slide is the cover of my latest book, the drawing, which is very wishful thinking, flying saucer on the moon, propelled by gravity. And the drawings are all done for me by somebody called Dave Windett. I used to work with his dad when I worked for BAE Systems. So the book is in 3 parts. The first part talks about the theory of gravity from Newton up to Einstein. The second part of the book deals with the importance of analogues. And I'm a mathematician, and analogues are so important to me. The third part of the book deals with Faraday's gravity experiments and also extending the gravitational theory by using an electromagnetic analog of gravity. The last couple of slides, we may find that after I've shown them to you that they become secret. I don't know. I'm getting very frustrated. I don't know whether to tell people what I'm doing or say nothing and it all dies with me. So it's a risk. Next slide, please. So this is the analogues. This is somebody called Francis Bacon. He was a politician and he blotted his copybook. He did something he shouldn't have done, and so he got booted out, and he spent his time talking about science. He did a good job. He wrote his book, which is called, if I can find it somewhere, down there, Novum Organum Scientiarum. Anybody speak Latin? I'm afraid I don't. But the book was very influential, but only after Bacon had died. 30 years after his death, there was a group of people who had what was called an invisible college. In the United Kingdom at that time, the Civil War had been going on, and you kept your head down. You didn't make a lot of noise. And so they had an invisible college. And at the end of the Civil War, when Charles II became king again, they made something called the Royal Society of London, which is now world famous, of course. The idea is if you have some sort of mathematical model of something, and you then strip all the outside of it off, so you're just left with lots of numbers and equations, and then you look at something else, you'll find, hang on a minute, it's the same model. I've just changed one thing. One thing might be mass, another thing might be charge, and something else might be heat, and so on. You suddenly find the mathematician has suddenly got an insight into things he never realized were there before. Next slide, please. So these are 2 analogues. The one on the left, electromagnetism, was done by James Clerk Maxwell during the 1860s. He got his ideas from Faraday. Faraday, I think, also worked from analogues, but they were in his mind. He could look at something and think, oh, that's just like this, so I'll try an experiment. So there we are, the dot, if for those mathematicians amongst you Dip was called a divergence for things that spread out, and the curl at the bottom was something that Maxwell introduced. It's if you grab hold of the H as a line and you give it a twist, that's the curl. Maxwell said to himself, all right, I like analogues. I'll have a go at doing it. So he wrote out the equations that he thought might extend Newton's theory. The first one comes straight from the inverse square law, so that's true. The second one, it's true anyway, but we don't know what H is. It's a field, but what is it? No idea. Second one is true, especially if you, the G is the gravity. If gravity is not changing, then we get a static case, and we'll look at that in a moment. And the last one is very important, but we've never really realized it in operation. Next slide, please. This is a guy called Oliver Heaviside. He taught himself mathematics. He was absolutely brilliant at it. Now, in this slide, that column at the top in grey is moving with velocity v. It's a steady velocity. And around it, according to the analogue, there is a field that's in green. Outside the body itself, it's so weak, nobody has ever seen it. Inside the body, some people think it's quite large, but we don't know because we can't see inside the body. So Oliver Heaviside said to himself, the same as Maxwell and the same as others, if I look at the analogue, what is it telling me? I'll compare it with magnetism. If I've got moving charge, I get a magnetic field outside. And I'm guessing if I have a moving body with mass, I will get a gravitomagnetic field outside. Next slide, please, Tim. Now, this is the important one for me. I'll read it to you at the top. It says, the curl of gravitation. Don't forget, if I've got a gravitational line and I grab hold of it and twist it, I get a curl. So there we are. At the bottom, you can see the G at the back there. If I twist around it with the black circle, you can see I'm getting the curl of G. And it says it's equal to the change in gravitomagnetic field. So when the body moves and the velocity changes, we get acceleration. And it says that when you get acceleration, there is a change in gravitomagnetic field, which causes a curl of the gravitational field. Now, mass, that mass there, that grey cylinder of mass, only responds to gravity. So if you think about it, if you sat in the car and you accelerate forwards, you get forced backwards. Have you ever asked yourself, why am I forced backwards when my mass of my body only responds to gravity? Although you haven't realized it, there's a gravitational force pushing you back. It's an induced gravitational force, and it comes from the changing gravitomagnetic field. We can't see the gravitomagnetic field, but we can feel its effect. Next slide, please. This is a strange one, because if you now drop your mass, I've just told you that it's going to cause a gravitational field. So if the body is dropped in a gravitational field, it will accelerate. And we know that from my brain's gone. Who's the Italian who first did this? Anyway, if you drop a body, it accelerates with the acceleration due to Earth's gravity field. And from the previous slide, we know that there's an induced gravity field in the opposite direction. So we've now got two gravity fields operating on that body, and one cancels out with the other. So when you drop in a gravity field, you haven't got any inertia because it's been cancelled. So if you've got a spring balance and you try and weigh something while you're falling, you won't see anything. So it won't weigh anything. And this, apparently, was one of Einstein's happiest thoughts, which led him on to general relativity. You'll find that in my book. It's a long story. Next slide, please. Right, we're going quite fast, Tim. I hope it's okay. We might finish early. So what did Bob Lazar see? In 1998, I'll just look at my notes. I watched a film on the UK TV, and it was called Aliens Among Us. And it was produced by Tim Good. I taped it, so I've still got it, and it fascinates me. I look at it from time to time and think, no, amazing. I think the fascinating thing about it was Bob Lazar said that the technology he was working on came from aliens. Now, I used to know someone who worked at Area 51. He was actually British, or perhaps he was American. I don't know, naturalized American, I don't know. But he said they did have a place where they tested alien technology, but it wasn't extraterrestrial. It was aircraft from foreign countries. So whether Bob Lazar got mixed up there, I don't know. According to this 1998 video that I watched, there was somebody on it called Stanton Friedman. Some of you may have seen the program or seen the American version of it. And Stanton Friedman said, look, this Bob Lazar is pretty smart. He's a clever guy, but he's got no professional qualifications. So you've got to take with a pinch of salt, as we say in the UK. If he tells you that something he saw works like this, it may do or it may not do. But what did he actually see? That's the question we don't really know at the moment. The next book, that was Timothy Good's book, which I got here, and then there's the other one by, this one I quite like, it's got a bit more information, by Paul Violette, I think his name is. And in Paul's book, he gives you a little bit more information. It's all very limited. So for a long time, I've been looking in at what actually did he see? You couldn't talk to academics about it because they would say, have you been taken in? It's all a lot of rubbish. It's nuts. So I didn't talk to anybody about it. I talked to some of my colleagues, but nobody else. And over the years, I sort of thought about it. Did he see it? When these books came out, I bought them and had a look. But there's nothing there that I could really say, well, I understand it. He talks about an antimatter reactor. Well, I mean, I've looked on the web and I'll try to understand antimatter reactors. It's not a technology that's going to come very soon as far as I can see. When I looked a bit closer, both of them mentioned the idea that gravity could be channeled in a waveguide. And as Paul said, that's rubbish. If you've got gravity, it just goes through all mass. You can't stop it. So it can't be an ordinary gravitational wave if that's what he saw. Well, that bit stayed with me. It cannot be exclusively gravitational. And I've been thinking about it off and on. When I did my latest book, again, I concentrated on the second third, on trying to expand the analogues. And one of the analogues I looked at, of course, was thermodynamics. I did ideal thermodynamics mostly because I didn't want to bring friction in. I have mentioned friction, but without friction, it's a very nice analogue. And I was looking at the analogues, and that led me on to something else, which I'm going to mention in a minute. Next slide, please. Oh, I think Tim has gone for a wander. I'll just keep talking about this one for the moment. So that my next slide, let me look to see what it is the idea of wave-particle duality. Now, I'm sure most of you now are familiar with the idea of having a wave and it can be replaced with particles. That's fine. So you can have a nice beam of electromagnetic waves, and you can think of it as a stream of photons moving along. I mean, a photon is just a figment of the imagination. They're useful to scientists because it allows them to put some numbers to it, and then we can draw pictures, and it's helpful. I don't know whether anybody's actually ever seen a photon. I doubt it. But associated with the photon is it's got a frequency, it's got a wavelength. It'll have, let me just look at my notes while Tim is not there. Oh, hello, Tim. Can we have the next slide, please? Yes, so it's frequency, it's got a wavelength, it's got an energy. This is Einstein's E equals mc squared, of course. And from Planck, we got E equals hf. H is Planck's constant. It's tiny, but he didn't know what H was. He didn't believe it to begin with. We now know that H is a fundamental thing in physics, but he didn't know. It's interesting to me that H is an angular momentum, and it relates to the gravitomagnetic field. Now, go back one, please, Tim. And so the photon will have an effective mass. If you tell academics a photon's got mass, they'll tell you you're balmy. So I'm having to call it effective mass. So there it is. It equals hf over c squared. If it's got effective mass, you can guess that light or photons, if they go near a very massive body with a big gravitational field, they'll get attracted. So that's on the right, that picture there. A photon from a star will get attracted towards the sun. This was something Einstein first suggested. And another bit that I put on is that a photon has an effective temperature too. Again, from Planck's work on doing black body radiation, you can look at all the curves that they came up with, and there's what I've called Wien's forgotten the name of his Wien's equation. He shows that for the maximum energy of a photon, the wavelength for the maximum energy times the temperature is equal to a constant. So we've got temperature and wavelength. So temperature and wavelength are going to be related. Next slide now, please, Tim. So this is something called Einstein's gravitational redcliffe. He was a clever man, came up with it back in 1905, I think. It was tested by Pound and Rebka back in 1960. They used gamma rays. Unfortunately, by then Einstein died 5 years earlier. They used something called a Mossbauer effect. It was I described it in my earlier book, which some of you may have seen, which is that one. So I've described how the Pound and Rebka did the experiment. So they showed it works, but it's for gamma rays. No one's ever seen it for light rays, as far as I know, although with satellites, they are trying to do it, or I think they may have done it with microwaves. The only thing about satellites is it's not a straightforward gravitational redshift because the satellite's moving, so you've got Doppler effect coming into it as well. Anyway, just by assuming the photon has an effective mass, and we're all familiar with the idea of the gravitational field, and you can move things up and you can drop them, and if you lift something up in the gravitational field, it gets more energy, so that when you let go, it drops down again and loses energy and turns into kinetic energy, and so on. Just by using the fact that photon has mass, we can work out as it moves up, it changes energy. But we've already seen that the photon has energy hf. So if you move the photon up in the gravitational field, it changes energy, but its energy is hf. So if it's changed energy, can't change h. That's a fundamental physical constant. It means that the frequency's changed. And Einstein came up with this formula, which you can do yourself. It's fairly easy to do. no one ever tells you what's actually going on. If you just extend it a bit more and do the rate of change of frequency, you can work out the force on the photon. It's the change of momentum. And it turns out that what's happening is that the total change of momentum is zero. So there's no force on the photon. What the photon has done in changing frequency is created a gravitational field, just like I showed you for inertia. It's created a gravitational field which cancels with the Earth's field. So that photon beam going up doesn't experience the gravitational field at all, just carries on moving at the speed of light, c. Now, that's okay. If we look at it with the gravitomagnetic view, you can actually see it. There's our photon at the bottom. It's moving up in the gravitational field. Because it's moving up, it's changing its gravitomagnetic field. Outside, you might just be able to see it. It's so weak you can't see it. But inside the photon, we're assuming it's large, and it's changing because it's changing frequency, it's changing effective mass. As it changes, if you go back to my curl G equation at the beginning, you see it creates a gravitational field. That's the one that cancels with the Earth's field. So that photon there is moving up with no force on it. Next slide, please. I put this in because before I talk about the next step, this is something that somebody, when I work, sent me this book and said, you're interested in UFOs, read this. And the one page that I really like is page 110, if you've got it. I've got it somewhere. Oops, up here. I quite like it. You may have seen it. What I want to bring out from it is the fact that the three main things that are associated with a UFO coming into land, the second kind, rather. So you're not actually, I think it's extraterrestrials is the third kind. So this is the second kind. UFO very near. People say there's an electrical interference effect. Car radios sometimes play up. Some people say there's a feeling of heat. And there's also a gravitational effect. I feel lighter. In fact, I think somebody claimed that their car tried to lift up slightly. So those are the three effects. If it actually lands, then there's more. It causes damage to things. Next slide, please. So this is my analog now. These are my last two slides. As I said, once I've shown them to you, you might find that people say, no, we can't tell other people about this. Right, so we start off, when we do the analog, let's assume on my left-hand side now, we've got a waveguide which is filled with something that allows photons to move through it. So it could be a dielectric if I've got a photon source which is beaming in microwaves or millimeter waves. What I do with the insert, whatever's in that waveguide, the dielectric, is I create a temperature gradient across it. Don't ask me what temperature gradient. This is a suck it and see experiment. We'll have to look at it again in a moment. But now, right, what I should have said was, can we go back 2 slides, Tim, just for a moment? That one, yes. What I didn't mention was it cancelled out the gravity field. But you've now, those photons going up there are changing frequency. Each photon and its frequency is associated with a temperature. So what we've got going up there is a change of temperature as well. That's not cancelled out. You've got a cold shift. So back to the slide we were on, please. So now when we're going up, we're going to come up with a very similar formula to Einstein, only now we're assuming that the photon, as well as having an effective mass, is also an effective heat source, which changes as it goes up the temperature gradient. So when we change, as it changes there, creates a change of gravitational, a change of frequency, So what it does, as in the previous case, the analog says, oh, as that photon moves up the temperature gradient, it creates a change and in frequency and gravitomagnetic field, and in doing so, it cancels out the thermal field T. So it just carries on moving at the speed of light. Speed of light in that material, of course, not the same as the speed of light in air or in space. But just a minute, we've said it cancels out the thermal field, but in exactly the same way, this time it's created a gravitational field as well. This time the gravitational field hasn't been cancelled. So in doing this one, we've created a gravitational field in a waveguide. So this made me think, hang on a minute, Paul Violette was saying what Lazar saw was an was a gravitational effect, which he said could be put in a waveguide. But Paul Violette said, no, it couldn't, because you couldn't control a gravitational field inside a waveguide. But in this way, you can, because you are creating it within the photons. So photon density is going to be important. So where you channel the photons is where the gravitational field goes and where the electromagnetic wave goes. So it may be very weak, it might not be, I don't know. We would like to know how to amplify the field. Now, just as an aside, on the right-hand side, I put a picture of Roger Schroyer's electromagnetic drive. There's a few people's guesses at how it works. A lot of people don't agree with Roger's quantum theory view. There are other ideas. So I'll put this in as well. What happens, I mean, I used to work on stealth, of course, and one of the things about stealth is the intakes. They show up quite a lot, and one of the ways of stopping them showing up is to make them smaller so the waves can't get in and get reflected back out like cat's eyes on the road. So what happens here, as that wave goes up towards the red end, that the waves are getting, they can't, you've got to have a complete wavelength as it moves up. If you can't have a wavelength, then the wave doesn't exist. If the wave doesn't exist, the energy's there, got to go somewhere. So the energy goes to the cavity. So by having that conical cavity and shining the microwaves in it, you're going to find that you get a temperature gradient. Now, if the model I've suggested from my analog on the left-hand side is right, this might say, well, in that case, what we are doing is getting exactly the same effect, and we're going to get a thrust on that cavity. So maybe this is another way of having a look at Roger Schroyer's drive. Maybe we should try putting a heating collar around one end, see whether changing the temperature gradient makes any difference. Right, on to the last slide. This is a very suck it and see slide. So there you are, as my drawing. I'm very frustrated. I'm not an experimentalist. I've looked around to people and said, you know, who can do this for me? So any of the people in the audience that think they can do it, I'd be delighted. I can't work with microwaves, but I can work with light. So what I thought was, well, I'll start off with, I'll have a go at doing it myself. I'll get a piece of glass tubing, which I got, and I've got a laser pointer, and I thought, well, I'll point the laser in the glass tubing and try to get it to go down there. By the way, the first person to do something like this was Faraday back in the 40s. He was the one that really started shining light down things like this. And this is where the Faraday effect came from, because with his analog in his mind, he came up with what was called the Faraday effect and the magnetic field around things like that. Anyway, getting back to this experiment, I shone the laser along the glass tube. Wow, what it was rubbish. I just couldn't get the laser to go in. It just reflected off the front face of the glass tube. If you're a fiber optic experiment, if there are any of you fiber optic experimentalists in the audience, you will say to me, what you need to know is this. You do something, and then the light will shine in the tube. I mean, we know it works because of all our telephone systems use fiber optics now. It's all based on light shining through them. So it must work. Maybe we need a bigger laser. I don't know how to do it. So I'm looking to you experimentalists to tell me. So we could start off. I want to create a temperature gradient across it. So you can see the shading. That's supposed to be lagging, keeping it so it doesn't emit heat radially. So I can create a temperature gradient. So I'll start off. Let's supposing I could make it work for the moment. And I measure the weight, and I then suspend it from a string horizontally. So I have to check everything out, make sure it's balanced. Then I have to shine the laser in. And what I don't want to happen is for it to get an effect just from the laser, because, I mean, that could be a photon rocket. So I have to be careful. So with the source on, and then I heat one end, again, I don't want it moving. So all that's got to be checked out. Once I'm happy with that, I can then go. I put the source on, I can heat one end, I get it. Does the string move? It's a suck it and see experiment. I don't know. You guys are good experimentalists. Michael Faraday, he would have done it for me. Unfortunately, he's not around. Perhaps one of you can do it for me. Thank you, Tim. That's it. Thank you. Now, do I take questions now, Tim, or?
Yes, absolutely. Sorry about that. I am just, Ron, let me do this. I am going to remove your spotlight. Okay, there we go. And before we do anything, let me put this thing on gallery view. Okay, and everyone please give Mr. Ron Evans an enormous applause.
And for the audience.
Ron, thank you, sir. Thank you. And my apologies for some of the confusion. I don't do a lot of screen shares. And so, yeah, the first thing I was like, okay, how do I do this again? You know, but then the other part, I'm sure everybody's presented has seen this, is it hides some of the zoom controls, and some of the controls display a little differently, right? So like I couldn't see what time it was, and I couldn't see, you know, like who was in the room. It just kept doing these notifications, this person entered. So I was just like, okay, yeah, I'll make it through. But yeah, well, so let's go to Q&A session. I'm going to allow participants to unmute themselves. And we're ahead of schedule. You are ahead of schedule, and that's totally cool. So we can go to discussion now. So again, let me go to here. You can raise your hand in Zoom using Option Y on Mac or Alt Y on Windows. If anybody has questions for Ron about this presentation, about his thoughts on Bob Lazar's story, or about BAE Greenglow, or any of the many things that he's presented. Riccardo, welcome, sir.
G'day, Tim. Thanks for letting me come on the show a bit later on. But Ron, I've got a question for you now. Regarding it's relevant to me with respect to Bob Lazar, because I'll be talking about that next, and I'll be focusing on this particular thing quite a bit. The figure of 7.46 hertz that Bob Lazar stated, and it was actually back in 1989, so it was over 30 years ago. Where do you think that came from? And is that relevant to what you were talking about previously?
I have no idea. I mean, it was obviously a microwave frequency, so it does make me think that whatever it was Bob Lazar saw, it's to do with microwaves. So I couldn't tell you. I have no idea. I have worked as an analyst on millimeter wave systems, and I also worked for several years on stealth, but I never actually I'm not hands-on to the microwaves.
It was actually 7.46 hertz. That's not a microwave frequency, is it? No,
I think it was 7. Was it 7 points? You're right.
7.46 hertz, yeah.
Hertz, yes. I was thinking of gigahertz. Right. It's hertz, is it? Right, I don't remember that. Right, okay, I didn't know. I shall have to look at that myself. Do you want me to quickly look in this book?
Well, look, if that helps you answer the question, yeah.
Well, it won't help you answer the question. It just means I've been mistaken for quite a while because I was sort of thinking it was 7.6 gigahertz.
No, 7.46. Yeah, that's it. Yeah.
I can't find it quickly, so I can't answer your question. But you've now put a question into my mind, and I will need to follow it up.
Okay, well, you might actually be interested in when I get to my piece, because that's actually what I address very, very closely.
Right. I shall keep looking while you're talking.
I'm done. Yeah, that's it.
Oh, okay. Well, Riccardo, thank you. So before I go to Avi, I had a question for Ron briefly. Ron, in terms of Area 51, and I know probably none of us know the scope. In fact, somebody posted this in chat. None of us know the scope of what may or may not be going on there. I know two pilots who have flown out of Area 51 in the Air Force. Both of them had all the proper classifications and all that for what they did, and both of them, I mean, obviously no one can talk about exactly what goes on, but both of them strongly insinuated that it was experimental aircraft and drones, right? Stuff that you wouldn't blink an eye at, and neither one of them indicated that there was any kind of alien craft or anything like that there. Now, again, who knows? Maybe they're hiding them in the basement, or God only knows. But that's the scope of my knowledge there. You'd mentioned, I think, during the conference, your colleague had kind of suggested something similar.
Yes, exactly the same.
Okay.
Alien aircraft, not extraterrestrial aircraft. Yes.
Sorry, sorry about this. I didn't mean to butt in, but I feel it's important. Bob Lazar actually never claimed to work at Area 51. Specifically, it's an area called S4.
Yeah.
So there is an important distinction, because even Bob Lazar mentioned, I believe in video footage that I've seen, that there were no extraterrestrial activities at Area 51. It occurred at S4. So it's an important distinction that we need to make clear. Sorry about that.
Yeah. Well, and for my part, again, I know lots of Air Force pilots and several Air Force officers, lots of military folks who believe in UAPs. They all have their own opinions about Lazar. I won't go one way or the other about that. But yeah, as far as Area 51, these gentlemen didn't see anything. That would surprise anyone. So, but yeah, what you're saying, S4, I've seen that on maps. S4 is geographically located in a different place, and odds are, if you're testing fighter jets, you probably don't have a need to see UFOs if any exist. So yeah, just my anecdote. I'm not making yay or nay there, but let me go to Avi next, sir.
Yes, hello.
Hi, and can you turn your camera on, Avi?
It's quite late here.
Okay.
So I'm in bed.
Yeah, no, that's okay.
Anyway.
Well, go ahead with your question, sir.
So basically, my question is a few things. I see a few problems basically coming from the thermal thrust that should be initiated by the thermal gradient in your experiment proposal. For example, thermal thrust is a major issue in satellites. Pioneer, for example, has this Pioneer anomaly, if you heard about it. Okay, so you can maybe calculate those kind of things, expectations from Pioneer trajectories.
Thoughts that occur
And it's coming back.
thermal gravitational kind of alignment. That's perfectly in accord with entropic theories of gravity as well that are coming on the horizon. Particularly for me, a big one is entanglement entropic gravity. There's a particularly illuminating derivation kind of the Einstein field equation from that viewpoint, that in an attempt to unify the quantum and general relativity theories of the universe. And so along that line of unification, there's a great book, to your point of analogies, on quantum classical analogs. I believe it's by someone called Dragoman. And there have been some successful experiments that have been done in that field. So Lagrange-like points have been found in the quantum electrodynamic field. And this gets right back to the main topic, gravitomagnetism. The duality between the electric and magnetic field has a beautiful mathematical relationship, I'm sure you're aware of harmonic conjugacy. So it could be that what's needed here is a complex analysis, but perhaps on an octonian or just kind of higher dimensional complex number, to speak loosely. There's some interesting results in this regard from people like Cole Fury and her references back in the 70s. I don't see too much though there's some pretty big problems, people say, kind of the big gravity people. We might be able to keep it real and complex rather than going to any larger fields. I don't know what your guys' thoughts might be on that type of stuff. It's intriguing though. As far as I've looked into it, Cole Fury's theory, I think a lot of people have dropped that name in here, looks very intriguing. So sorry, just a couple thoughts that occurred. But I really want to thank you and congratulations. It looks like a great book. I got to get a hold of that as soon as I can. And I think there was a Professor Ronald Evans here at UCSD. Is that in San Diego, where I'm located now? Is that that's probably a coincidence?
Yes.
Yeah, I think that's a coincidence, John. Because Ron he's out in what, you're in London, right? Near London.
Near London, yes.
Okay.
Relatively speaking.
Yeah.
In the UK.
Apparently, we're all within 7.46 of a light second.
Very good.
Yeah, if I could ask, and this would be the audience to ask, didn't Tesla have a quote-unquote magic resonance frequency that was right around 8 hertz? Wasn't that a Tesla thing? I remember reading something about that.
I think it could be right.
Yeah.
There's a big noise hump if you just turn on a spectrum analyzer right around 7 hertz. I think they do say it has to do with the ground, being the Earth and its size. But it always seemed to me that it should have the resonance kind of the wavelength of the Earth's diameter. So I had to check that calculation, but it looks like it's closer to the Earth's circumference, the wavelength implied by the 7.46 or 8 or so, right around there.
Yeah, that range. Yeah, and again, I don't want to jump in too much because I'm supposed to be moderating. I read a book, this was years ago at the library, and it was a book on lightning resonance frequencies, and they were talking about the Earth as a capacitive circuit, right? And
Okay.
That's how I see it in my mind.
Yeah, okay, that would look like in the presence of, we're saying, in a body with gravity, when you produce a gravitomagnetic field, because it will be pushing against the other gravity, basically, it will create a propulsion system, basically that will run away, overcome the gravity of the other, of the body attracting the body that is producing the gravitomagnetic field. Is that how I summarize your answer? Would that be correct?
I think my answer would work in free space, where there is no or very little gravity field.
Oh, okay, okay, all right. So I appreciate it. Thank you. I'm going to review it in your YouTube and things places because I missed part of your presentation and I regret it. But thank you. It looked like, from what I saw, you did a good job. Excellent. Thank you.
Wonderful. Harold, thank you, sir. Okay, so we've got about 5 minutes until the top of the hour. And again, if you want to ask questions, it's Option Y on Mac or Alt Y on Windows. So Ron, you are ahead of schedule. We have an hour. What we could do is we could go at the top of the hour. We could go to Riccardo Storti, who was going to be presenter number 2, but he is here early. Or alternatively, if you want to talk more about BA systems and green glow and things like that, we could do that as well. It's up to you, sir.
Well, I mean, green glow started when I was at what was in those days was called British Aerospace, and originally I joined the aerodynamics office, and I worked there on the propulsion section, and then in 1979, the publicity department where I worked at Walton in Lancashire, near London, about 350 miles north of London, they got a picture from what was called the Yorkshire UFO Society. And it was a black thing that had been seen flying very low over the North York moors. The UFO Society from Yorkshire didn't know what it was. They sent it to British Aerospace and said, "Is this one of yours?" And we said, "No, don't know what it is." We found out the following year it was an F-117 flying over the North York moors. We found out because the chief aerodynamicist was asked to go down to Farnborough, which used in those days to be the Ministry of Defence Research for Aerodynamics site, and an American Air Force general, I think he was, gave a presentation on the F-117. When the chief aerodynamicist came back, he said, "Right, I want someone to get our act together. We want to start a proper stealth program to make sure we can know what's going on." And I was tasked with that job. One of the first things I realized, which I hadn't realized before, was in the late 40s and early 50s, the United Kingdom, some of it based on German technology, was one of the leading countries on stealth. All the aeroplanes, the Vulcans and things like that, had all been stealthed. So we'd had a lapse of probably 30 years where we hadn't really, at British Aerospace, we hadn't expected the wave systems, and they had a millimeter wave program. The idea was that they could detect Russian tanks, in fact. So I got moved as a mathematician to go and help them with their analysis. And from there, when that work sort of finished, the boss said to me, "Well, what do you want to do?" And I said, "Well, I rather fancied looking at gravity, because as an anti-stealth measure, it could be, make all the stealth rubbish. All our stealth effort that we're putting into it, if we just come up with a thing that picks up on mass, we can do it." So he said, "All right, go ahead." So that led on to looking at mass and gravity, and then thinking of, well, how do we understand gravity? And then that led on to the Green Glow program.
Okay. Well, so Ron, we're just about at the top of the hour. It looks like we don't have any more questions. So why don't I do this? Riccardo, would you be open to going?
I have a question.
Okay, go ahead, Lulu.
Hi. Two questions, actually. One for space and one for humans. For space, could that possibly, if we use that, like the gravitomagnetic, to clean up the space? Like, you know, if gravity, you know, we beam the same gravity to attract junk, things like that, to clean it up. So this is for space. And then for what you were talking about, like in history and, you know, all the different experiments that you guys, you know, led back then, and you don't have the feedback. Our human genetics somehow were experimented on detecting, like ESP, you know, an extrasensory perception. I don't know how exactly how to explain it, but just knowing without, you know, using your five senses. And then when checking, it validates itself. So were there like experiments for humans to detect these objects? You know, like they just kind of feel that there's an object there. And then, you know, just these kind of questions. And, you know, I know you said some of these things you don't want to talk about because, you know, it could lead to things, but no, like existing on a different field than what everybody else is, because you're raising the frequency, the shift. So if you create these, you know, atomic structures on higher redshift, higher level, and their existence is always like that, wouldn't that change the knowledge it would relativity theory? Because, you know.
Oh, okay.
You know what I mean?
Lulu, you're breaking up a little bit, but I think we have your questions. So Ron, she was asking, I think there were two parts. One of them was could you use gravitomagnetism to help clean up space junk? That was number one. And then number two was I think she was talking about something similar to remote viewing, detecting these objects without necessarily using radar. That would go to kind of your stealth stuff. Do you have any thoughts on that, sir?
I think it's too early for me to say. On the first part of the question, can you use it to clean up space? I'm intrigued in my own mind what is going to be said about Bob Lazar bending these gravity fields. If it's possible to bend in a microwave guide, I'm always interested in end effects. There's always end effects. Does the field come outside? Is there a tractor beam? If there's a tractor beam, then yes, in the long-term future, we might be able to use it to clean up space. The second part of the question, I don't know. I need to think about it.
Okay. Well, thank you, sir. Well, again, why don't we do this then? I think. Again, we are at the top of the hour. Ron, I want to thank you so much for your presentation. I think what we should probably do now is go to Mr. Riccardo Storti. But before we do that, I want to put this. Oh, Jeremy has a question. Okay. Go ahead, sir.
Well, I just wanted to, before we moved on from that one point about like some of that remote viewing and stuff, and I'd want to pay attention, tell people to go and check out that BBC segment that was done on you, Ronald Evans, where you went into that place where they at British Defense, and where they have that hypersensitive, you know, quantum system, right? Where the slightest perturbation. So if you were to create a warp field or a gravity field, this thing would be able to detect that sort of stuff. And I'm wondering if you know, they've done any experiments with, you know, why don't they take the whole entire barracks out and see if they can mentally try to alter the state of this thing to get it to go one state or the other, and see if they can train, you know, soldiers to you know, affect these quantum fields using mental states. I think that would be a valid experiment.
Talking about that higher different frequency. You're talking about higher different frequency. You're talking about quantum in a quantum field state.
The same thing that, you know, they did at SRI with Ingo Swann. He was able to affect this hypersensitive magnetometer at like a couple floors beneath, you know, using brain waves apparently. So I just thought it would be an interesting experiment to try and worth mentioning that they have this equipment at British Aerospace, and probably they could build such similar systems at laboratories around the world. So
yeah.
But it's a quantum target for training. It's basically what I'm the idea is.
Well, Ron, did you have any thoughts on Jeremy's suggestion?
The work was done at the Ministry of Defence's Porton Down, which is the research centre. British Aerospace didn't have any input to it. It's just an idea that we had. Just with an ordinary gravitational system, you can detect a battleship at 3 miles. What we wanted to do was detect an airplane with a similar system, and we did it. And they mentioned this quantum gravity gradiometer, which is getting more sensitive year by year.
Yeah, that's super interesting. The research into that, because there's a lot of different applications. Not just in that, but I also think for validating some of this remote viewing stuff and some of the claims that I've read before but never seen. I've never done any or engaged in any personal experiments into that sort of thing, but I think it would be it would certainly be worth the effort, But
Wonderful.
To see if there's any connection between this consciousness thing that seems to be a prevailing topic and argument in a lot of these mainstream discussions of the physics behind UFOs and stuff lately. So, anyways, yeah, excellent talk and thanks for coming on again.
Thank you, Jeremy. Okay, so now we're starting to get questions. Let me go to Thomas then next. Sir?
Can you hear me?
Yeah. Okay. Welcome back.
Thanks. I was just going to say basically what Jeremy's talking about, the concentration of a group of people affecting something. That probably a good resource to start from would be to look into the PAIR program at Princeton University and the people who opened Sileron.com, which they have mined devices and basically there's no physical connection between the people and the device, yet they're able to concentrate and switch them on and off according to a lot of the data they've gathered. And they've actually gone further, showing probably a greater degree of understanding of that phenomenon by applying it to building devices that can detect buildups so that it can predict when someone's going to have a seizure too, which I have a friend who actually had one with him that had very severe seizures due to I guess it was a reaction to given so much of a drug that it should have killed him to help him get stop smoking over insurance policies and stuff like that. And he had them when he was younger, outgrew them, and then this brought it back, and they were able to basically really lay down a timeline of when all of these seizures were happening. And the ones that he was conscious for matched perfectly. So he's assuming that the ones that it detected and, while it was monitoring while he was asleep were also accurate too. So being able to basically, switch flip the script to basically use that device, not just for basically a person to be able to concentrate and control something, but to be able to use it to detect something that's going on in the human brain. It seems like there'd be a wealth of information from those, those university professors that were working on that, and all of their, protege that were also working on that same project, gathering an immense amount of data on that. So, PAIR is, I guess, acronym is the word for it, like NASA, Princeton Engineering Anomaly Research. So, if it makes it easier to find, because I know when you look for PAIR on Google, it throws a million other things at you that have nothing to do with Princeton, even if you include the Princeton University part to it for some weird reason. And I know years ago you used to get exact results back then. So, and maybe compare notes too between that and the documents that were put out for a Stargate project, like the technical remote viewing manual and stuff like that. If you're going to look down that route, they seem to all come together on that, even though they're all completely different and disparate individuals that have nothing to do with each other. So, just throwing it out there. If anybody needs links, I have the very rare and difficult to find software available on the Google Drive if anyone wants to try to take advantage of it too, where basically you use your mind to control images on a screen, called Shape Changer. So something that the PAIR Institute put together while they were researching this and investigating and whatnot. So
Yeah. You know, Thomas, thank you. And if something I interviewed Dr. Forgetting his name, I'm spacing out, but one of the principal researchers from the Noetic Society on it, and they did get results with it. That was what he'd indicated. So
I was going to say the other thing to look into is the fact of, since they had this success with this, they were building devices. Look into the mechanics and the physics of those devices, possibly for further insight too. Because I mean, most of their successful devices they were able to control with they were exhibiting control from the mind, and identical devices sitting right next to each other that are halfway around the world, able to basically affect one without affecting the other, were mostly built around a device that was detecting the massive amount of thermal energy variance that occurs from Brownian motion, injecting thermal energy into a component. So, there may be an awful lot of like a treasure trove of information that has been kind of dug up with all this research, but now they don't know what to do with it, because they had their mind on one thing, and you may be able to apply that to something else. I mean, I'm finding that with a lot of what I'm doing for developing replicator level, capabilities for 3D printers, is that I find when I get an idea of how to do something and I start doing a little digging online, I find that other people, for another completely different reason, have done an awful lot of research and development, and there's a lot of equipment already available that's just not being used for three-dimensional deposition on a level where you could print out an LED, from raw and scratch on a countertop, stuff like that. So just bringing the pieces together, it might be, we may have all the, in other words, what I'm saying is we may have nearly all of the components you need. You just got to figure out what they're being used for and, bring them all together. And then you've got a off-the-shelf solution for whatever it is you're trying to build, that once you prove the function, then you can maybe get the, the parts you need more custom tailored to your means of, production too.
Yeah. Well, so let's bring this back to Ron. Ron, what are your thoughts on that?
Oh, I'm just trying to, like you, I can't remember somebody's name. We had somebody from Cambridge, the superconducting switchman. What was his name? Professor
Brian Josephson.
Exactly. Thank you very much. Well done. While we were there with Greenlow, we had him come and talk to us, and he was very much talking about consciousness. I'm not sure whether he's still alive. Is he? I have no idea.
Yeah. He's on Jack Sarfati's list. So.
Right.
Yeah. So yes, he's quite active.
We never followed up any of his ideas. It was interesting that he was. I mean, we had lots of interesting people on Greenlow come along and talk to us about different subjects.
Oh, okay. Let me go to Morgan next, who has been patiently waiting. Sir?
Hold on, I just want to inject one real quick last
okay.
thing. There's a lot of misinterpreting and misdirection of information that just, I think is, it's not intentional. But I see, like with the double slit experiment, just as a real quick example, they're assuming that observation is causing the change between the double slit experiment, when in reality, if you look at what they're doing, they were using electromagnetic equipment that puts out an EMF field, meaning there's a vibration that basically forces all of the EM fields within the atoms in the slits to then synchronize instead of being completely randomized. So it's not the observation in that instance necessarily that causes the switch, but rather you altering physical properties of the experiment with the equipment you're using to observe, and kind of filter all of those, bad assumptions possibly out as best as possible before moving forward to dig through all the existing information too. So I just wanted to make sure what I had already laid out there as far as digging out that other information didn't end up, accidentally bringing a bunch of bad information into it too that people aren't aware of, and therefore it ends up tainting your whoever happens to be trying to do this, their end results. So I can go ahead and mute out and get out so he can talk now.
Yeah. Well, Thomas, thank you. Yeah, we should probably come back and touch on the double slit thing. Actually, I've read some interesting new models there recently, but yeah, let's go to Morgan first, though. Morgan, sir.
Okay. Yeah. Hello, everyone. Again, So Ron, I was just thinking about this experiment you were proposing with this laser inside of some tube or whatever, with heating on both ends. The first thing I came to mind were these fiber optics, and a lot of times what I've seen it with people use is that actually the laser light itself is used as a source of heat. Okay, so you might not need a light source as well as like some sort of heating source, but the laser light itself could be a source of heat as well. And then that right there just alone came to made me think of these experiments from Martin Tajmar on these, he has these fiber optic loops to test essentially a variant of the M drive. I was trying right now to go and look through his webpage to see if I can find the actual publications, but essentially a benchmark test like what you were describing may have been done with these experiments from Tajmar, and I'll see if I can find some links for those. But sound very similar to what he's been doing, and so at least it's an active area of research right now. So I'll see if I can find his links. But yeah, no, it's cool idea though. But yeah.
Wonderful, thank you. And Ron, did you have any thoughts on that, or?
No, I talked. Well, I talked. I've not met Roger, but I email him and talk to him on the phone from time to time. I don't know where he's up to at the moment. Hopefully, still successful.
Okay. Well, let me go back to Harold, sir.
Yes, Ron. One more question. An observation. I just remember your experiment. I saw part of that you're proposing. But in Gravity Probe B, they collected a lot of data, and they proved that there is a gravitomagnetic force, the force being produced by the star. I think it was Alpha Centauri, and they proved how many arcs per year it would deflect the gyroscope, producing a force. What the data in Gravity Probe B serves also as a way to verify your experiment that you have proposed, or that it will validate your idea. So would that be some data? Would that be useful to you?
It could be. I mentioned Gravity Probe B in this book that I wrote before, and it talks also about there were experiments done in New Zealand using the world's biggest ring laser gyro, which was trying to find the gravitomagnetic field of the Earth. It's too small to detect. This is the problem. Outside the body, field is too small. This is why Gravity Probe B was using the size of the Earth as well, and they were trying to look for an effect across space. And it took them, I don't know how, I think over 18 months to collect the data and manipulate it to get an answer. We're talking about a field which is tiny, but in my view, if we could control it, it makes a big difference.
Oh, okay. That's about an interesting. I hope they find. All right, thank you.
Thank you as well, Harold. I was actually doing some looking while Harold was asking his question about. So what I found was double slit experiment validating simulation theory, and I couldn't find the paper that I read about it, but I did read an interesting one, and it was a different take on the double slit experiment. What they were saying was, if any of you guys are computer guys, you know that they conserve processing in game engines, and one of the ways is by processing things differently that the eye isn't going to see, and so there was a really interesting paper that looked at the double slit experiment, and they said we are living in a simulation, and if you were writing software, this is how you would write it, and this is the double slit experiment kind of validates that. But so again, we can come back to that later. Okay, so who has more questions for Mr. Evans?
I do.
Go ahead, Alex.
Okay, Ron.
Yes, sir.
Listen, a long time ago, Tesla built a spacecraft, two-man spacecraft, warp drive, with 8 warp cores and a stator that spun around and gave an electromagnetic field. Okay, he did that in 1899. He did it in Colorado Springs at the time. And a little bit later, about 1938, the Nazis took his work and started making build crafts on it, anti-gravitational craft, which I think Tesla also built 2 doorways, like 2 doorways. Yeah, one doorway you walk in, and the other doorway you come out a half mile down the road. So, I think it's under Einstein's boson, point A to point B. Do you know what I'm saying?
I know what you're saying, but I don't understand it. It's beyond me.
Okay.
It's beyond me.
Okay, because when I was at Area 51, when I was running Area 51 back in the day, I asked the head guy, it was James Roberts, who was a colonel. I said, "Would you show me all Tesla's information and all his experiments?" And he took me into Los Alamos and a vault, and he showed me all this stuff. And I thought it was interesting, and he was explaining to me about all the different experiments he had. You know, he had 700 patents with working patents.
Wow. Okay. Well, thank you, Alex. Thank you. Okay. So let me see. We're at 1:20 now, Pacific time. Do we have more questions for Ron? Okay, well, why don't we do this then? We're not at the top of the hour, but why don't we put it on gallery view? And I think Riccardo is still with us. Riccardo, did you want to start your presentation now?
Yeah, look, I'm happy to.
Okay, well, let me do that. So before anything else, let's all give, and again, a giant applause for Ron Evans. Ron, thank you, sir. Thank you again for coming back and presenting on that. Okay, so let me see. Oops. Let me put this thing back on speaker view. So before anything else, I'm going to mute everybody out. Okay, and I want to introduce you all to, and of course I don't have his info here. Here, let me do this. Fortunately, I have that all up on the website. Okay, so now Riccardo Storti will be doing an analysis of Bob Lazar's propulsion system claims. He has written a paper on this on ResearchGate, so I'm going to paste the link to today's presentation in. There is more online there, and I'm going to paste this into chat right now, but he'll be doing a presentation as well. Basically, he's going to go through the assertions that Bob Lazar made regarding EM propulsion that he claims to observe in Area 51's S4. Right? So it's not Area 51 proper. And he's testing them against the EGM construct, I believe. So let's go to Riccardo. Sir, let me hand it right over to you, and thank you very much for presenting for us.
Okay. Look, good. I'll say good morning to everybody from my point of view. It's Sunday morning here in Melbourne, Australia. So good morning to everybody, and thanks for having me on the show, Tim. I appreciate it. I'm going to try and screen share now. So let me just see how this goes. Okay. Yeah, share. All right. So you guys are showing a couple of.
Yeah, perfect. Yep, it looks great.
Okay, great. All right, great. So I'll just pop up the presentation and just move stuff around so that I can see it myself. Here we go. All right, that's good enough. All right. So what I'm going to do here is scrutinise 3 very specific scientific claims that Bob Lazar has actually made. I'm not going to deal with any theoretical descriptions of how this stuff's supposed to work or anything like that at all. I'm focusing specifically on the scientific claims that he's made. I'm not going to talk about his story. I'm certainly aware of opponents like Stanton Friedman, who I'd actually had some conversations with prior to his passing. So I'm not going to get into that. I'm focusing purely on the scientific claims that he's made. Now, he's made 3 scientific claims that I'm aware of. You could probably break at least one of these down into a couple more, but the 3 that I've listed here is the gravity A wave pulsed at a frequency of 7.46 hertz. That's the first claim. Second claim was that the apparatus in the spacecraft, in the sports model as he described it, operated in the microwave frequency range. And the third claim is that the antimatter power supply required a very specific manufacturing process. What I've got listed there are a couple of recommended minimum viewing articles. I would suggest to people that if you haven't actually seen it, try and have a look at those 2 there. So the first one is a movie or a film that was put together by Gene Huff and Bob Lazar in 1991. So a couple of years after after everything became public in 1989, and that was that's really a pretty good one. I liked it. It's converted from videotape, so the actual size of the viewing window on screen is pretty small, but it's worth enduring it. The second one was done by Jeremy Kenyon Lockyer Corbell, and you're probably once again, I think that's good viewing. And in particular, the second video the element 115 or moscovium. And again, there are pictures available of how that was actually put together. Ken Wright is probably the best description, visual description that I've seen so far. So you can visit a page by a guy called Ken Wright. He met with Bob Lazar in 2000, I think it was. It must have spent quite some time with him, and sort of put together the page that he's got now, and told some of the more technical aspects of the Bob Lazar story. And look, I also make no claim whether Bob Lazar really worked at S4, as we've talked about. It's not Area 51, S4. Look, I don't go into that. As far as I'm concerned, the only real proof that exists, it's not even physical proof, the only real proof that exists is the proof that you can verify for yourself. So if you see someone on TV or YouTube that's got something flying around or whatever, you can't trust that. You can't believe that. It could all be doctored, could all be fake. So the only real proof is the proof that you can verify for yourself. It's not some government document that Stanton Friedman, for example, would rely on so heavily. The very first thing that Stanton Friedman, well, one of the very first things that Stanton Friedman said to me when I had contact with him was, do I have documented proof? And my reply to Stanton was, look, the only real proof is the stuff that you can actually prove for yourself. So that's really important in the presentation that you're going to see, or that you're seeing now, because it's all about proving stuff for yourself. So again, with claim 1, 2, and 3, the next obvious question is why, for example, is gravity A wave pulsed at frequency of 7.46 hertz? Why are the gravity amplifiers working in the microwave frequency range, as so claimed, and why is the antimatter power supply, why does it require a specific manufacturing process? And that's what we're going to deal with. On to the next slide. Okay, so here I've got a diagram of the physics architecture behind the answers that you'll see coming up. At the bottom here, I've got a pyramid. Bottom layer is general relativity. The next layer is polarizable vacuum, or the PV model of gravity by Puthoff. On top of that, we've got zero-point field model. Example, the Casimir effect. Along the side here, you've got it's a method. It's not a theory. It's a method called electrogravitomagnetic. So now that's something that myself and Todd have developed over many years. That leads to up here we've got particle physics. There's a whole bunch of particle physics stuff that Todd and I have derived, some of which, actually much of which has been experimentally verified or experimentally implied. For example, we have exact solutions for the radius of the proton, the neutron, etc. That's all been published, and you can look it up. Exact solutions for those, which have been experimentally verified to many significant figures. On the side here is where claim 1 begins, but I'll come back to that in a moment. Just moving on. Particle 2, you can see that claim 2 comes from the particle physics work that we've done. Claim 3 flows onto that. Over here, a critical component of that is the Moscovium. Here, particle physics leads on to cosmology again. In the cosmology space, everything that I've done in that space, Todd hasn't had a great deal to do with that, is experimentally verified. So throughout all of the work that myself and Todd have done, almost everything leads to an experimentally verified result. So we don't just whack up equations and say that's it, that's the solution. No. We actually take it to the next step, produce the numbers, and actually check those numbers against what's actually seen in the real world. Then from cosmology, it eventually passes through cosmological inflation and ends up in basically Todd Desiato's warp drive concepts. And the reason I've listed that here, and Todd can speak to this at much greater length later on, but the reason I've put that in here is because the work that I've done, my cosmology work, and again, that's all available online, is that I demonstrate that within the first 10 to the minus 23 seconds of the universe, the velocity of light during that inflationary period actually expanded to about 10 to 38 orders of magnitude above above the value of C. Again, that's all documented. You can have a look at that, but I just wanted to move through that. Going on to the next slide. Okay, claim 1. Now, the gravity A wave pulsed at a frequency of 7.46 hertz. Why? Okay, now, when you actually... okay, I'll just come back to this slide. Here you'll see to the side here, I've got claim 1, and I've got Fourier quantization. So what I've been able to do, what Todd and I have been able to do is demonstrate just using straightforward mathematics, no experimental, no physical theories are required, nothing at all. You can actually decompose the number 1 into a quantized Fourier spectrum. Now, when you do, what you end up with is that greater than 99.9% of
G is cancelled in the first 415 harmonics. So that leads to the result of 7.43 hertz. Now you need to appreciate that Bob Lazar stated that 7.46 hertz specification back in 1989, and 7.46 is not a number, at least in my view, that you can pull just pull out of the air. There's got to be some logic behind that. Well, the logic is that if you do a Fourier analysis of gravitational acceleration, as has been done, as we've done, what you end up with is an answer of 7.43 hertz as the pulse frequency. Now that to me seems just a remarkable coincidence, and I can't see that it is actually a coincidence, because you can verify that for yourself. If you don't know how Fourier series works, well, you can look it up on the net. You can even find online calculators that'll do all that for you. So that to me, as soon as I saw that, I was very impressed. Moving on. So now, Bob Lazar talks about the gravity A wave and the gravity B wave, and the gravity A wave emanates from the Moscovium, and the gravity B wave, as he calls it, these are his words, not mine. I can conceive them. The gravity B wave emanates from the Earth. Now, when we decompose the gravity B wave, so gravitational acceleration at the surface of the Earth, into a Fourier spectrum, that's what you get, 7.433 hertz. It also relates to an amplification factor there, and a power amplification factor. The definitions are down here. The amplification factor is just how much you need to increase the amplitude of the gravity A wave, and the power amplification factor deals with the overall power of what's in the resonator. Now, the results that you see there, they're just obviously copy and pasted results from the mathematical model, which Tim has probably, I think, posted the link on there for you. So you can see how that all works out. One thing I just noticed down now, and I'll just point that out, is down the bottom here it says that there's the actual harmonic limit is n equals blah 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 1028. That should read 10 to the power of 28. I don't know what's gone wrong there. I'll have to correct it. But back to so you can see here, using the same technique, you can actually calculate what the pulse frequency will be in different gravitational environments. So you'll see the moon here, the surface of the Earth at 7.43, Jupiter, that's at the cloud surface, the sun, and a supermassive black hole if you're quarter of a millimetre away from the event horizon, before the event horizon. Now, just while I'm on this page, just want to speak to a point that came up earlier about resonance 7.46 and resonance with the Earth. Yeah, look, I actually did investigate that in putting together this presentation. That's not that correlation with C and 2 pi. That's just coincidental, because when you apply the same apply that same 2 pi constraint to these other gravitational environments, you don't get C. So you don't get what was talked about before. So at least in my view, that correlation to 2 pi and that apparent resonance is purely coincidental. So I'll move on to the next slide now. All right. Pardon me. So what's significant about this value, this harmonic of 415? And again, I say you can actually verify all of this for yourself. You don't have to take my word for it. The mathematics is straightforward. It's like first-year university stuff. But anyway, I've done the hard yards for you, and these are the results. So the reason it's significant
is because if you look at I've called it anti-gravity here, but it's not. It's actually a percentage similarity of the gravitational acceleration of the environment that you're working in. And this is the same. These are the same for any gravitational environment. Again, it's just a Fourier spectrum. If you see here the difference between when n equals 415, so the 415th harmonic to the 1015th harmonic, you'll see that the improvement is it's trivial. It's 0.043% in this case, and this is an approximation, by the way. So it's not an exact solution. That's a numerical approximation. So and to get that, you would require 35 or almost 36 times the power amplification factor. So to go from just over greater than 99.9% gravitational acceleration reduction to 100%, it's not worth it. So that n equals 15, that 415th harmonic, is really denotes a point of diminishing returns. So it's really a tipping point. So it seems a remarkable coincidence to me that n equals 415 correlates to a pulse frequency of 7.43 hertz. To me, look, quite frankly, I think you've got a higher chance of winning the lottery than fluking that number, 7.46, to use Bob's figures. And you also want to consider that the highest number, so the harmonic limit in this spectrum, is 10 to the 28. So there's a huge number of modes in this spectrum, and you only need the sum of the first 415 in order to reproduce gravitational acceleration by greater than 99.9%. So that, to me at least, is a very powerful statement towards the credibility of that first scientific claim that Bob Lazar has made. Okay, now moving on to claim 2, the gravity A wave amplifiers operate in the microwave frequency range. Now, using that same Fourier technique and combined with some of the stuff that Todd and I have done, what that actually works out to be, so the moscovium atom produces a Fourier spectrum with its fundamental frequency at 11.44 gigahertz, and that means that moscovium wave, that gravity wave, let's say, extends 26.2 millimeters outside the nucleus, so basically an inch beyond the nucleus. And what's important to note is that much greater than 99.99% of all the harmonic modes generated by this moscovium atom actually don't project beyond the nucleus. So it's only a very small fraction of the lower harmonics that actually extends beyond the nucleus. Now, this also supports a claim that Lazar made of exactly that. He said that whatever gravity A wave was coming from the moscovium they actually believe was extending beyond the nucleus of the atom. He and his Kenwright fellow believe it's the strong nuclear force, so there's something special about that atom. It's a stable isotope that projects the nuclear force beyond the limits of the actual nucleus. Now, I'm not going to speak to that point. I don't know whether it's the strong nuclear force or fairies at the bottom of the garden that's actually doing it. But what I'm presenting is the mathematical evidence to support that claim. And that's exactly what we get. We get 11.44 gigahertz. It's right in the microwave frequency range. We get that frequency acting, extending its influence, an inch beyond the nucleus. So again, that to me it could be coincidence, but to me it's a remarkable coincidence at the very least. Claim 3. Now, claim 3. Some of this actually appeared for the first time in 2018. So what Bob Lazar did say in 1989, which has not changed, was this wedge element here, the cone, etc. That has not changed, especially this wedge element. What has changed in the 2018 video, Bob mentioned that the cone had to be sliced up into these dashed lines that you can see. And he, by his own confession, said there was no rhyme and reason for it. He couldn't understand why it was the case or anything like that. So that intrigued me, and I investigated, and this is what I came up with. So in 2000, when Ken Wright put together his site, and I'd encourage everybody to go have a look at that. This diagram on the bottom right-hand side is actually a direct image from the Ken Wright's site. We've got 12 discs here assembled into a cylinder. That cylinder is then machined into a right circular cone, and then from that cone, slices are taken and wedges are formed, and that's step 4 here, and that's the central wedge there. Now, what I've been able to determine is that on the right-hand side here, you have 12 discs, and neither Ken Wright nor Bob Lazar say or even mention that there are 12 discs at the most. Bob Lazar says in 2018 there were many discs. So that number 12 from the Ken Wright side is very it's dubious. It can't be trusted. It's there for illustrational purposes only. Well, what I actually did was using I showed you before, using the fundamental wavelength here. When you take a quarter of that, you end up with 6.55 millimeters. So that means a quarter wavelength. So it occurred to me that for these discs to transport them, etc., a quarter wavelength would be the optimal size, because at a quarter wavelength, the effect on the face of the disc is effectively switched off, or at the very least minimized. So I ran the numbers again. This is all available with the link that Tim should have given you. If not, you can reach out to me. I've calculated that there are in fact 16 discs, and again using that quarter wavelength, I was able to actually calculate what all these slices were, the number of slices, the angles that they had to be, etc., all based around that quarter wavelength idea. Because Bob Lazar says that there was no rhyme or reason as to why it's sliced this way. He couldn't even specify the angles, certainly in the 2018 video. If you look at it, you see when he draws it, that's exactly what he comes up with, pretty much, is what I've got there. Anyway, I've run all the numbers on that, done all the calculations, and that's what it turns out to be. And it turns out that 2/3 of the actual Moscovian material is milled away from this cylinder. So that right circular cone is about it's about 1/3, or exactly 1/3 of everything that's in that cylinder. So that means, I think, basically from 3 cylinders, you'll get 5 cones or something like that. Now down here, you'll see the primary wedge, number 1, is the thickest. But here, just to help everybody understand how this works, is these dashed lines represent the slices. So, for example, so slice 2, I've got the number 1, 2, 3, 4, 5, etc. So slice 2 here would actually mate with slice 2 prime. So you'd slice up the cone into these sections, and you would mate slice 2 and slice 2 prime, you bond them together, and that would then become that final wedge would then become a new piece of material to run the antimatter propulsion system. So if you look at the Bob Lazar videos, you'll see pretty much the design that he claims was being used, and he talks about element 115 transmuting to 116 and thermionic conversion, etc. Blah blah blah. So you guys can sort of investigate that for yourself. But if you are looking to get specific and very precise dimensions, etc., then again I refer you to the work that I've done and the link that Tim sent through. And one thing I should also point out is that the design, these wedges really try and, if possible, look for single atoms of moscovium to amplify the signal. So where possible, you want to end up with these fine points, or it might be slightly rounded. There may be a bit of practicality involved, but basically that's it. You're looking for a single atom, some kind of solution for a single atom that gives you the clearest and easiest signal to actually extract and amplify. Okay, moving on. So in summary, what we've shown is this, that Bob Lazar's first claim of 7.46 has been validated, at least to my satisfaction. Likewise with his second claim, Bob does not provide numbers around his second claim. He only states that the apparatus operates in the microwave frequency range, and claim 3 was also validated in my view, because we've come up with a full and complete description of the manufacturing process and why it needs to be the way it is. Here's the link that Tim should have passed on. There is also, and I should emphasise this, on that page with that link, you'll also see a tab. It's called, I don't know, I can't remember the name of it. It's called the link tab. Click on that. There's a spreadsheet calculator that you can actually download. So it does a whole lot of stuff. It also calculates a whole lot of I think cosmology stuff from memory as well. I included that there. The spreadsheet is right. The tabs are protected, but the spreadsheet is not locked. So you can unprotect those tabs and do whatever you like to any of the cells, look at the formulas, play around, do whatever you like. But I just wanted to point that out. So when you open it up, it'll show that each sheet is protected. But you can simply unprotect those and do whatever you like to it. And finally, information regarding the EGM methodology used to justify the Lazar's claims. Look, if you're all a bit, skeptical about theories and new people and different ideas, etc., look, as I mentioned before, Todd and I found exact solutions for the mass and size of fundamental particles. Many have either been experimentally verified or implied by the standard model of particle physics. I've also made new particle
new predictions for the Casimir effect, exact solutions for the cosmological and astronomical Hubble constants, and we can explain the tension between those, or from the one equation. Point 3 there, a complete history of the cosmos, including resolution of the Hubble tension dilemma. I just mentioned that. Now, I expect that the James Webb Telescope is going to validate our most recent cosmological prediction, and that's that the universe is in fact 14.57 gigayears of age, not 13.8. So it's the Hubble age, right? And you can read about that if you're interested in that kind of thing. In Hindawi there, there's a paper that's published on that. So the point of this last slide is that is to sort of trying to communicate to people. Well, look, if you have doubts about the numbers that we've come up with regards to Bob Lazar, what I'm communicating is the mathematical model, the method behind those Lazar numbers is the same method that's also behind this particle physics and cosmology stuff that we've done, much of which has been actually experimentally verified. So that should give you a little bit of confidence. So look, that's essentially it. I'm not sure if I've raced through that or had enough time, but yeah, look, happy to take questions. Wonderful. Well, sir, let me do this, Riccardo. Okay, you stopped your screen share, and what I want to do is I want to put this thing on gallery view. So everyone, starting out, let's give Riccardo a giant applause. Sir, thank you for the presentation. Wonderful drill down on Bob Lazar's claims. So let's go to Q&A section. Let's go to Jeremy Reese, who already has his hand up. And Jeremy, I'm not sure if your YouTube feed is on or not. I just tried to message you about that. Oops, sorry about that.
There we go. All right.
Yeah, my fault.
Yeah, I had a problem. I'm watching my son, and he must have hit the computer screen and shut the StreamYard down. For the most key part of that, it was like, started off, it was like, oh, we're going to talk about Bob Lazar, and then 10 minutes of blank screen, and then and then it was on the summary page when I got it back up. So everybody missed like watching live. I lost like 100 people watching it, and yeah, I'm sorry about that, but I will repost that when you get it up. I'll have to get the link, and I'll have to repost that presentation from Riccardo because of the technical difficulty and glitch. And I do apologize. It was totally not like intentional in any way, and I'm sorry that happened. But I wanted to have a couple questions about the presentation because I was watching it and I was paying attention, even though it wasn't on for everyone else. I just want to point out that my first question is that there was a gravity A wave and a gravity B wave. And did you mean gravity? You said gravity A wave in both cases, and did you mean gravity B wave on one of those, or?
Okay, so yeah, so look, I'm not sure where perhaps I might have miscommunicated, but I'll try and clear that up. A gravity A wave is emanating from the moscovium atom itself. The gravity B wave is emanating from, in our case, the Earth. So that's the difference between gravity A and gravity B. These are Bob Lazar's words, not mine.
And I had never heard that actual 7.24 hertz or whatever figure before. Did that come from Bob Lazar, or?
Yeah, that came from Bob Lazar actually back in 1989, so over 30 years ago. And it's the most easily and most trivially verifiable number just by using Fourier series.
That's the Schumann resonance, right?
No.
not close to that. It would look like a
Oh, it's close to it. It's close to it, but it's not it. I mean, as I understand the Schumann resonance, that's not it. It's close to it, but it's not it.
They're trying to think, like another person said, oh, it wasn't Bob Lazar's claim. He hijacked it from somewhere else. And did you do any research into the literature to find if anybody, if he could have got these claims from somewhere else and simply been repeating them, or did these claims originate with Bob Lazar?
They originated from Bob Lazar, to the best of my knowledge. I have not seen them anywhere else. In fact, the 1991 video by Gene Huffman and Bob Lazar quoted it then, I think, from memory. So I've certainly not seen it anywhere else. And look, I mean, in some sense, even if it did come from somewhere else, okay, it's relevant, but it still doesn't take it away. It doesn't take too much away from the gravitational story that's involved with that first claim. But yeah, to the best of my knowledge, he said it.
Wonderful. Jeremy, was that everything? Or
yeah, I'm gonna have to go look at the source for that and go track that one down, because I wasn't aware that he gave that kind of an exact figure anywhere. So I want to go and find that.
Okay.
I have to give a shameless self plug to let people know that it's still streaming on YouTube uninterrupted on my Crypto Alchemist channel, but me and Jeremy will be figuring out in the future better where these streams will just go to multiple channels with 0 interruptions.
Okay.
Yeah, Bernard, give me a link. I'll post it so if people want to immediately go watch it right now. They can go to your channel and go rewind 10 minutes and check that out.
Awesome. Thank you. Mark, model here. Maybe you can help me understand. Using a gravity wave, or he's using a gravity wave. How do you get from gravity wave to anti-gravity or gravity shielding and propulsion? How does the craft move using the system that Bob Lazar explained?
Yeah. Apparently, so, and I'm just repeating what Bob Lazar has described, but apparently there are 3 gravity amplifiers on board this craft. So, and they're spaced 120 degrees apart. If you can imagine a plan view, 120 degrees apart. And in the middle, there's the actual power source, and that's where the stable moscovium actually exists. A stable isotope exists. That's where the moscovium wedges go into an apparatus in the center. So, you've got 3 amplifiers at 120 degrees spaced apart. On the next layer, beneath that power generation layer, the next layer underneath the spacecraft, you've actually got 3 conduits that are able to move in.
Sorry about the choppiness, guys. I'll have that fixed in one moment. It's because I'm loading the link. Things will be fixed and not buffering BS right away for everyone. My apologies. Anyone willing to make donations gladly needed in regards to being able to upgrade my computer equipment to give you guys better educational quality going forward. Anywho, we're learning, we're working, we're adapting with what we got. 30 more seconds, guys, and much better quality coming for you.
And his 1991 video, he actually does walking space, I'll say. Short distance between 2 points is the way that he describes it. So that's what he claims the way it actually works.
So he creates a gravity field underneath the ship.
That's correct. Excellent.
Gravity is attraction. So how does creating a gravitational field underneath the ship make the ship float upwards or propel it?
By the gravity A wave that he claims is produced by the Moscovium is then phase shifted 180 degrees. So when it's aimed at the Earth's gravity B wave, it's cancelled out. It's reduced by not greater than 99.9% is what I calculate. So that's how he claims it works.
Thanks. Awesome. And thank you, Mark. Let me see. Why? Sorry. There we go. Okay. Zoom wasn't showing. Oh, because it has the hands up first. Okay. Let me go to Sean Logan. Sean?
Go for it, Sean.
Yeah, and Sean, you're going to have to unmute yourself. There we go. I'll do ask to unmute. And I've got that unchecked, so you guys can unmute yourselves, but please only do so to ask questions.
You gave a frequency of 11.44 gigahertz coming out of the nucleus of an atom. Is that frequency an electromagnetic wave, or was that a wave of strong force or something else? And if it was electromagnetic, what's that?
Well, no, good question, right? Good question. And look, all I can say, well, the answer is I don't know, right? What I do know is the frequency. So it's around that. The question is the effect that's coming out of this Moscovium atom. The question is it purely EM or is it something else? Lazar claims it to be something else. Lazar claims it to be gravity. So gravity to me is gravitational acceleration. So he's claiming that gravitational acceleration is projected like an EM wave, and it can be manipulated like an EM wave. These are his claims. So that's the only way I can answer the question.
But it's a different kind of substance that's vibrating. It's not. You're saying the mathematics is similar to E&M, but it's physically.
Yeah, correct. Exactly. That's exactly right. So the mathematics behind what I've done makes no distinction whether it's EM or something else. It's just a wave, right? Bob Lazar claims that that wave is something else. It behaves like EM. It can be amplified like EM. So, yeah, that's the only way I can answer the question.
Okay.
Look, I mean, I don't think anybody really knows.
All right.
Awesome. Okay.
Isn't the element dictates the wave, like the frequency? That's how we categorize elements. Like it's in that frequency range, so we put it in that kind of, it's the frequency of the element that dictates what element it is, right?
No, it's actually the number of protons in the nucleus. So, hydrogen has one proton, 115 is 115 protons. So that's what makes it. And
the hydrogen frequency is.
Sorry,
but it's the iterations of that particle.
Yeah, I mean, Lulu, it would have to answer your question. It would have, based on the element, it would have its own resonant frequency. And then you can
its own ups and downs, and that's what they're measuring. The 400 and let's say 12, frequencies, and the equation is, as you stated before, like you divide that by a half, and then it would equal to know that this is element 115.
Yeah. So let me go to Jared next, though. I think you there's definitely something to what you're saying about frequencies. Let me jump to Jared real quick, sir.
Hey, yeah. Thanks. I had a question. I was following Jeremy's feed right as it cut out good stuff, so I apologize if you already went over it. But on the gravity A wave, you said that Lazar originally got it at 7.46 hertz, and then you guys calculated it at 7.43. Close, but not very many, decimal points after that. How did you go about calculating it, and what was any reason for being close but not quite?
Yeah, so, so the way to calculate is just using a Fourier series. So if you take the number 1, you can actually break it down into a spectrum of Fourier harmonics. When you add the first 415 harmonics together, what you end up with is 0.99107 or something like this. What that means is that the first 415 harmonics of the number 1 adds up to 0.99, so greater than 99.9% of the value of the number 1, right? So that's it's what I call the unit harmonic operator. And you can multiply that unit harmonic operator by the magnitude of any gravitational field, right? So that's how you relate. So that's how the figure of 7.43 hertz is obtained. Now, why it's not exactly 7.46 as Lazar stated, could be for a variety of practical engineering reasons. Yeah, I don't know.
Cool. Thank you.
Yeah. Okay, let me go to, and thank you, Jared. Let me go to Mark next. Mark, welcome back, sir. Mark has been here for a while.
Yes.
Today, been lurking.
Thank you very much for the presentation. About Bob Lazar, there's a distinction that needs to be made. He is telling us how he was told these objects work. He's not saying that this is how it works. He's saying that this is how I was told it works. So even if you take him at his word that he's 100% honest, he's not telling you that this is how it works. He's telling you that this is how he was told it works. So he might have seen something real and been fed a BS explanation as to how it works, because that's the secret. And that's the best way to keep these things secret, is to, spread disinformation. One key fact that is indisputable that proves that something is off in the explanation is element 115 transmuting to element 116, which is antimatter. You can't have a atom suddenly become antimatter. You need antiprotons, antineutrons, or anti-electrons on the outside, which you call positrons, in order to make antimatter. So making a larger mass of matter doesn't make it antimatter. That's one of the key things. Also, the microwave waveguides that he saw, and he commented that they actually look like microwave waveguides, would be explained by several other experiments that we're looking at, such as the Alzafarm experiment that uses microwave waveguides for inertial mass cancellation. Have you considered that possibility?
Look, no is the short answer, because this was about just purely trying to validate his claims against what I know. So this is about discovering evidence for yourself. I mentioned early in the presentation that the only real evidence for anything is that which you can verify for yourself. Doesn't matter if you see it in videos, government documents, it means nothing. It's only what you can verify for yourself. So everything that I've put forward, anybody can verify for themselves, because it's straightforward mathematics.
Okay, what about element 115 magically turning into antimatter?
That's not what actually happens. So Bob Lazar doesn't claim that element 115 turns into antimatter. What he claims is it transmutes to 116, and in the process, antimatter particles are produced, collected, and then I think I'm going from memory here, the antimatter particles are channeled to some gas, but then the antimatter particles annihilate, and then there's a thermionic conversion.
Exactly, 100% thermal electric converter. But the element 116 is the antimatter. You're adding a proton to 115, making it 116, and element 116 is antimatter. Which then
the element 116 is.
Well, if I could add some confusion to this as well, I'd like to confuse things even more. I had read, and I could be completely mistaken, that element 115, which was super briefly synthesized in a lab, a few years ago. There may be different versions of that, because what Lazar was talking about is 115 may have been an isotope of a different element. Is that?
No, he said 115 was the stable form is an isotope of 115, the 115 element. So what was produced, and hence the name moscovium, is simply one isotope that's known to be unstable or not long-lived. And just on the point of 116 being antimatter, I'm not sure I understand what that means, because 116, it has 116 protons and many neutrons.
Yeah, what I recall reading, and again, I could be completely mistaken, to go to Mark, was the antimatter was supposedly given off when it decays. I remember, he had and it was a 2 or 3 step process, right? It's 115 to 116, and then it was 116 to like 114 or something like that, and then back to.
I didn't hear about 114. I heard
maybe not, but
we should listen to it again. But my recollection was that it was 116 became antimatter, which then converted with the gas in a 100% thermoelectric conversion process.
116, it decays. It's at the, so if you look at the reactor, it has a proton beam shooting into the tip. It does a beta decay, which it emits. And it emits a matter, a proton and an electron, right, or an anti-proton in there. It does an antimatter decay, which I'm sorry I'm flustered, but it's not that the whole target turns into element, goes all the way up to 116. You're at the very tip of it that you're playing in the reactor. Yeah, that's right. And you're shooting a single proton into it. It goes up. It's unstable. It bounces up. Bob Grenier found a really good useful website.
It decays to what?
So it's up at element 116 briefly, and then that extra energy decays into matter and so an electron and a positron, which
Does
is
it go back to element 115?
The target, the triangle target stays, the majority of it stays at element 115. Nuclear reactions are site specific. So you have to think that there's
the atom that got hit went to 116. Does it go back to 15?
As it decays, it emits, the proton that was put into it, shot into the tip of it, it decays into a matter-antimatter reaction. So it's a specific type of decay. We can look up on Wikipedia. But
so you're saying that the proton that you're hitting it with became an antiproton?
As it decays, there's beta decay. There's you have alpha, beta, and gamma decay. And then
so in that case, the fuel is never used up, because the fuel is coming from the particle accelerator, not from the element 115, and that's not
right. Possibly.
That's not what he said. He said that the fuel will last a long time, but it does get used up.
Well, who knows? Maybe it erodes. Yeah. Maybe it erodes because you're hitting it with a proton beam, right? So,
well, if it erodes, it'll still be there in the chamber somewhere. It'll just break apart, become a powder.
And then Paul Potter also in this book, he goes into the stacking of it, of the fuel element. So that's another resource. So I think that the stacking of that material has been out in his canon, in Lazar's canon for a while, so I don't know if that's exactly new info, but it's.
One interesting thing is on the periodic table, right above moscovium is bismuth, which is the strongest diamagnetic material. Maybe there's something going there.
Well, Mark, let me bring this back to Riccardo, because this is his Q&A session, sir. So, Riccardo, what are your thoughts on this?
Look, to be honest, I don't have any thoughts in this space. I focus simply and purely on the claims, those 3 specific scientific claims by Lazar. It seems to me that I think Aidan is certainly on to something. I mean, what Aidan talked about is consistent with my understanding. I don't have a very deep understanding in that space. I haven't focused on it because it's outside my purview. So, and it's very much an open area, open question. There's not a lot of detail around it, and it's complicated by the fact that we haven't been able to reproduce the stable form of that element on Earth. So there are just too many questions about it, I think, to have any degree of certainty. I'm only certain about what I did.
Wonderful. Okay, so let me go to Harold next then. Harold, sir?
Yes, a very interesting aspect what you presented. My question is, what Mark said and Adam Schaefer said, bringing that to what you said, Bob Lazar, the description that is given, makes me think, that there might be a resemblance that when all that energy of 115 is being used, the antimatter given off, that somehow there is an evolution in the process in which it acts as if it were a propellant, and that the energy released from that effect acts as a propellant, and that creates a super force that creates a very large proportion force. Is there any probability that that is basically what happened in what Bob Lazar described, or what other researchers have investigated, trying to understand how it's happening?
Okay, so Bob Lazar was pretty specific in saying that it is not, there's no Newtonian type reaction occurring. So there's no propellant being emitted out of this. It is I'll call it electromagnetic, but I only call that I'm only using that as a description. So no, I don't think that it acts as a propellant in any way. Yeah, that's not my understanding.
I'm making an analogy. How propellant produces a force. I know it's not Newtonian, but it's the process itself act as if it were propellant and create a force. I mean, there's no ejection, but there's in the matter antimatter creation, there's an energy release, and the energy release itself, that because the energy, to conserve momentum, something has to give in. You have to put in energy, but the energy itself, just like a propellant creates a force, the energy itself in the process create a tremendous, a high proportion force. Is that more like I'm making an analogy, similarity. I'm not saying that it is a propellant, but somehow an operation of that nature. Would that be what he's describing? Something like that.
Yeah, look, no, I wouldn't. I certainly don't consider it to be a force. If anything, I would probably describe it as bending space-time locally the other way in order for it to just float, right? Bob Lazar does describe the entire craft as being a waveguide. Now, Todd Desiato can pick up on this point if he wants to in greater detail a bit later on. But as Todd has certainly demonstrated to me, and I think probably to other people in the forum as well, the entire craft does in fact need to be a waveguide, because all of space-time in that waveguide needs to be, I'll use the description as bent backwards. So no, there's no force per se that is projected. No, I wouldn't describe it like that, to be honest, at least to my understanding.
Hey, thank you. Thank you. Great presentation. Thank you.
Thank you as well, Harold. Okay, let me go to Gordon next, sir. Oh, Gordon, you're muted. There we go.
Yep. Okay, yeah. Thanks for the presentation. Absolutely superb. Hadn't heard some of that stuff before. I first came across Lazar via BBC, actually, on a program that was on BBC Radio here in UK, way back at the late 80s, where some of the claims were made. And then it resurfaced then with the guy that was on that radio show in this book, Alien Liaison, written by Timothy Good, who was a well-known UFO researcher. But Good actually met Lazar along with John Lear. And one of the things that I think was it Mark, I think, was talking about earlier was this reaction of element 115 to become 116. And it's actually in a little section in this book on page 157. He actually describes what happens. And it says, his words, on bombardment with protons, it kicks up to element 116, then releases antimatter, and that's reactive with matter, which is then called an annihilation reaction. And it appears they have something like 100% efficient thermocouple of sorts that produces power and some sort of gravitational standing wave that propagates up through the waveguide that you talked about. And they then use that excessive power to do whatever they need. And that was his description of what was going on with it there.
And that's certainly consistent with my understanding. You know, that's certainly consistent with my understanding as well. But again, I don't delve into that antimatter aspect. I've just focused specifically on the three scientific claims that Bob's made. And as far as I can tell, those three claims are accurate. Yeah, they're bang on. And the thing is, why I believe what I've done is important is because one can verify for themselves. So I've put all the work out there, and Tim, I think, has already sent the links. But certainly the 7.46 hertz claim, it's just straightforward first year engineering, you know, Fourier harmonics, and it requires no theory at all. You don't need anybody's theory for it. And in fact, if anybody has a theory connected to it, well and good, but it's superfluous. You don't need it. It can be explained totally mathematically. You know, which I think is a remarkable coincidence, because if Bob Lazar knew anything about this, he would have given that as the answer in 1989. I mean, you can't just pluck a number, 7.46, out of the air and then calculate for yourself 7.43. You know, it's just, anyway, so, yeah. And look, a point that I think Mark made before, which is relevant, I think it's an important point, is that much of this information that Bob Lazar has passed on was given to him in briefing rooms, right? And much of it, or some of it, not much of it, some of it may in fact have been misinformation, in order, you know, as a security measure and stuff like that. And I believe in the 1991 video that Gene Huff and Bob Lazar did together, so only 2 years after he came out with his story, I remember watching it live on TV back in 1989, just to show you my age. If you watch that 1991 video, I think it's about 39 minutes long or something like that. towards the end, I think he calls it section 2 or something. Towards the end of the video, the last few minutes, he talks about aliens and how many times they've possibly interacted, or controlled the destiny of our species. I think all of that is just utter rubbish. I think that is the misinformation, right? But certainly the technical aspects, I have verified to my personal satisfaction, absolutely, and everybody else can check. You can plug the numbers in yourself. I've created a spreadsheet calculator to make it really easy for everybody. You can play around with the numbers, change the formulas, do whatever you like. Yeah.
Okay. Thank you, Gordon. Okay, so let's go to Morgan next, sir.
Okay, so just I guess a couple comments on this. The idea that you're using this this heavy element, this 115, as I forget who had mentioned this, that if you're bombarding this thing with some proton beam or some particle beam, that whatever's supplying that particle beam is essentially the fuel. And what Bob was saying, or Bob Lazar was saying, is that it's the element 115 that's itself the fuel. And to me, that sounds almost like it's some sort of kind of like a nuclear reactor of some sort, whatever, cold fusion or something like this. But whatever process is going on, that's the thing that's generating the energy. And that's going around somewhere and powering the systems and things like that. And it seems like that power source is powering some other thing that might be generating a gravitational field or some sort of anti-gravity field, whatever. If it's this Gershenstein mechanism or some other kind of crazy thing. But it seems like that it's the actual the element that's itself. So whatever process is going on with this 7.4 hertz hitting this element, that seems to me like it's more of a power source. And then there's some other thing happening that's creating the gravitational field. I don't see how a heavy element can create a gravitation. We talk about this gravity field A as if it's somehow leaking out of the nucleus or something like this. The only thing that seems at least somewhat plausible is if it's some sort of near field effect. You get these really intense near fields in electricity and magnetism. If you have like say a plasmon or some particle confined to some surface, you get this exponential tail, which is really strong, which might be what's happening here. But I don't know if you can confine a particle to get a gravitational field like that. But I don't know, just a couple of comments. Go ahead.
According to Bob, so I'm using his own ideas. I'm just repeating them. He believes that the strong nuclear force within the nucleus of 115 actually is an isolated case of where the strong nuclear force actually, to use your words, leaks out of the nucleus to such a point where we are able to grab it and amplify it, right? The strong nuclear force. This is what Bob Lazar believes. It's not what I believe, it's what Bob Lazar believes. So that, look, I can't speak to the point whether that's actually happening or not. All I can do is say that I've run the numbers for myself on what Bob's talked about, and it seems impossible to me that he can just guess 7.46 hertz tied to a microwave frequency range amplification system, tied to an element that requires a very specific process that can all be explained. It can all be explained by the 11.44 gigahertz frequency. So the microwave frequency range value that I've come up with, that's not a Bob Lazar value, that's my value. His value was 7.46, he came up with that. So to me, these things have convinced me that those three claims are accurate.
What was your number, the 7.43, you were doing this Fourier decomposition with this 400 and some odd harmonics, with some gravity field. What exactly was that? Well, what was it? Your Fourier transform something, or what is this?
Yeah. So if you take just the number one, right? And you actually break it down using a Fourier series analysis. So you can actually break it down to a number to harmonics, right? So when you sum the first 415 harmonics, when you sum all those harmonics together, and I show it on the slide, and you can see it on the ResearchGate paper as well. When you sum them all together, what you end up with is basically greater than 99.9% of the value of one, right? That actually relates to a frequency value, so you can transform that into a frequency value of 7.43 hertz, right? So Bob said that the three horns under the spacecraft pulsed at a frequency of 7.43 hertz. So they would pulse at a frequency of 7.46 hertz. Pardon me. They pulse at a frequency of 7.46 hertz. But from each one of those horns came a burst of microwave frequency range energy, and I've calculated that to be 11.44 gigahertz. So yeah, that's basically it. I think there are some animations available in various spots around the web that can show you that. But essentially, from the moscovium element comes a signal that extends outside the nucleus. That signal is grabbed and amplified. I'm saying amplified to 11.44 gigahertz, and that's in the microwave frequency range, which is what his claim is, not the 11.44 gigahertz. That is then burst released through horns at a frequency of 7.46 hertz is his claim. And by the way, I've run a number of scenarios around element 115, whether it was element 116. So whether the number of protons, etc., change, or even the number of neutrons change very much, it doesn't. So I've experimented. I've done some what ifs, and in all situations, I've found that the frequency for amplification coming out of that is always somewhere between 10 and 12 gigahertz. So if this effect, if this phenomena that Bob describes is genuine and some of his numbers are a little bit off, right, it doesn't really matter, is what I'm saying, because it's always going to be somewhere between 10 and 12 gigahertz, something like this.
There was, I guess, just a final comment. I forget the details of this one, but someone had mentioned that about how gravity B is a strong nuclear force. There's some people have been working on these things where I guess you could, if you look at a quantum field theory of gravity, you can essentially, I don't know exactly how this works, but it can decompose into two copies of QCD. There's some decomposition that you can do with that, where you can, you could write a gravitational general relativity theory as two copies of QCD, which that might have to do something. At least in that case, you have some strong nuclear force being attached to gravity in some way. So maybe that has something to do with it as well. But, okay, yeah, cool. All right, thank you.
Yeah. Just
wonderful. Okay, so let's go to Robert next. Robert, who has been patiently waiting. Sir?
Yes, I'm still trying to get my head around element 115 being stable. Right. These heavy elements are typically have very short half-lives. Now, does anyone know the number of neutrons that would give you the isotope of 115? That, you know, the protons plus the neutrons would be related to the atomic weight. And you could figure that out. You could measure it by putting this isotope of 115 through a mass spectrometer, so it's knowable at least.
Okay, look, that's a really good point. The answer is nobody has the answer. There is theoretically an island of stability, and I think from memory, the number of neutrons, I think it's around, from the diagram, and the diagram's actually on one of the slides that I've presented, I think it's around 180 or something like this. roughly, but no one's actually got the answer as far as to my knowledge. Yeah.
Okay.
If it's possible at all. Yeah.
Well, I mean, it should be knowable. I mean, if they did experiments on this, they should have put it through a mass spectrometer, and then they would know the atomic weight.
Yeah, yeah. So the thing is, the element 115 or the moscovium that Bob claims he had, well, I mean, that's just a claim. In terms of our human discovery of 115, I think 650 milliseconds. I think was its life, something like this. Its half-life, something like this. So there's certainly been no chance for us to put it through a mass spectrometer. But look here, you would think that someone on the Bob Lazar end would have done that, and that may very well have been done, but not information that was revealed to Bob. Possibly.
I don't see how you could use it unless it's stable somehow. So you need an.
That's right. Yeah. Yeah, that's right. So Bob Lazar claims that the US government was supplied with about, I think, 223 kilos or something like this of element 115 by the Martians, by the space aliens, right? So this is his claim that the US government has that kind of material in reserve, and you would think that someone would have done some kind of analysis to determine the number of neutrons for the stable isotope. Someone probably has. Right, it seems inconceivable that wouldn't be done, but that information probably was not provided to Bob Lazar, because why would he need to know it? Right? If you're an engineer playing around with it, right, why would you need to know that?
I don't know. Right? It could be critical to why it works.
Well, it could be. But at least to my way of thinking, if you're trying to minimise the escape of this information for whatever reason, it's look. It was not remarkable to me. I mean, the media on the internet has often made the claim of Bob Lazar predicted 115 before we'd actually discovered, etc. That was not an amazing claim to me at all. Right? It's just obvious. It's bound to happen. Right? It would seem to me that someone who's trying to keep that information from the public, right, would realise that a critical piece of information would be the number of neutrons. So you wouldn't need to pass that on, because if you know what the stable number of isotopes is, right, when we eventually discover it and we find that it's unstable the way we discover it, well, then that kind of puts a hole in Bob Lazar's claims, doesn't it? But if you release the number of neutrons, Bob can say, "Oh, well, yeah, that's obviously not, because it's we haven't made the same stuff." So yeah. I can see reasons why it wouldn't be made known to him.
That and the fact that I mean, this is our government. Not well. This is the American government, right? So yeah. I will not use the word incompetent at all. I refuse to use that as a descriptive term. But well, okay. So let me go to Michael Boyd, who has something levitating, which may be element 115 right there. Michael, I've done the build up. I have done the build up. Oh yeah. Can you unmute yourself, sir?
Oh, you'll need to unmute.
Oh, Michael, you're still muted. Okay. There we go. Is that 115 right there?
My nuclear reactor was down, so I couldn't work on that. But I do have here. So basically, gravitomagnetism is what my background's in, and basically my thoughts on anti-gravity is that it's a combination of both gravitomagnetism and acoustic properties. And what we have here is what's called an acoustic levitator. And what that little object is there, in the middle of my neck that's spinning around, is a piece of styrofoam. And so basically it's a combination of vibrational energy, which is basically where the protons are moving, and a type of magnetism called gravitomagnetism.
But is it special styrofoam made out of element 115?
Here, it's a piece of a peanut, like you get of styrofoam that you put in your packaging.
Oh my God, the aliens use packing peanuts? I had no idea. No wonder they're trying to keep it secret. Everybody could use this.
Oh, you're going to have to cut this from there.
I'm sorry, I'm kidding you. Well, Michael, what was your question for Riccardo?
Well, what's his thoughts about it being something a lot simpler than what Mr. Lazar is describing?
Look, I tell you what, if you can turn that horizontally, is that styrofoam going to drop to the ground?
I don't know. It's a good question, probably.
Oh, wait, moment of suspense.
Oh, yep, it falls out.
Okay, there you go. If you can make that stay where it was horizontally, then you've got Bob Lazar's. You've got an answer for Bob Lazar, because it's not the same thing. What you're talking about, what you've demonstrated, is absolutely not the same thing at all as what Bob Lazar was talking about. No disrespect. It's just.
No, that's okay. I don't take any disrespect.
Michael, I will never trust styrofoam again. I feel like I've been betrayed. It seems so innocuous until you realize that it's all just a lie. So.
Well, that's the thing about Bob Lazar is, I have compassion for him, but I want evidence. I can show you evidence of styrofoam levitating. You saw it. The stuff that we're talking about with
it's not the same thing.
Lazar is what's the evidence?
Yeah, I mean, no, Riccardo, your analysis is different than, or maybe it's not. Is it different than your personal opinion, or?
No, it is. Look, so my whole point is that, and Michael's touching a really good point here, right? It's about showing me the evidence. Well, my point is, I've given you the evidence. You can check it out for yourself, right?
Well, would you be more specific, please? I don't understand. I can see the evidence. Is there a website or something like that?
Yeah, sure.
Okay, would you put it in the chat so that we could check it out?
Yeah, and I think
Tim's done that.
Oh, sorry. Yeah. Actually, I do. On the conference page, at the bottom of the page, I have a link to the ResearchGate paper. But
okay.
So Riccardo, if I could maybe rephrase, I guess, what you're saying, and I might be incorrect. Mm-hmm. What you're kind of saying is like, okay, if someone says, aliens told me there's a buried treasure on this island in the Pacific, right? And so you go to that island and you find the buried treasure, and maybe it's not exactly the spot, but it's pretty darn close. Then that adds some evidence. Is that?
Yeah, that's right. That's right. So what I'm to be very precise about it, Bob Lazar makes one very, very specific claim, right? That until now has been inexplicable, to my knowledge. If someone else can show me how a value of 7.46 or something close to it comes up in the description of gravity, I'd be happy to see it. But what I've demonstrated is that 7.46 answer is no fluke, and you can get it using basic first year engineering Fourier analysis. And that's it. And everybody can reproduce it for themselves, provided you understand a little bit about mathematics. Right? So there is no better evidence
Right, that's better than video evidence that you might see, which can all be doctored. Right, evidence that you can check for yourself. That's the only kind of evidence. So
I agree. I'll check it out. Thanks for answering my question.
Yeah, sure.
Well, and thank you as well, Michael. Let me go back to Jared. Jared, sir?
There we go. Yeah, I had a follow-up question on the 115. On the paper, it looks like you are ignoring the electrons in a lot of places.
Yeah,
sure. A lot of reasons to do it. I was curious though, if you're hitting the very tip of this piece with protons and stuff, and we're dealing with resonances all over the place, wouldn't the lattice structure of the sample be important? Wouldn't the number of electrons and their binding be important for all these calculations?
Look, possibly, right? The short answer, I believe, is no, because if it were, I don't think I would get the results confirming what Lazar has claimed, or if the only claim that it may have an effect on is possibly his second claim. So I've come up with a result of 11.44 gigahertz, and I did that ignoring electrons. Absolutely, that was just to simplify it. It could make a difference, but my personal view is I can't imagine that it would make much of a difference, personally, because the effect, the anti-gravitational effect, and I hate using that word anti-gravitational, but the anti-gravitational effect is coming from the nucleus, not from the electrons.
Right? Well, especially if there's like positron decay, right? And that's definitely going to be slamming into all those balances, right? You're going to have all sorts of weird interactions going on when you're getting decay.
Possibly. Look, it seems to me impossible to do a deep and exact analysis, engineering analysis of anything, because there simply isn't enough information, right? So, look, I did my best with what was available, basically.
Excellent.
You could be right.
Yeah. Well, and yeah, I mean, I think, yeah, Riccardo, I don't think anyone could criticize you for, incomplete information. I mean, that's something that we all work with, right? It's, it's bits and pieces that we get here and there, and God knows what we're missing, and, so, yeah, let me go to Bernie, who is, I can see
thank you, sir.
his face. He's eager.
So a common theme I'm noticing with the Bob Lazar topic is that he seems to come up with these over elaborate necessities and complexities to his designs. For instance, his hydrogen powered car that needs and requires a particle accelerator in his backyard to make an aspect of it. Yet it's like, I'm making this same HHO Brown's gas out of salt water and 5 volts in my backyard that anybody can turn salt water with a small amount of electricity into these gases like Stanley Meyer was, where you don't need these insane things. So it's that, sure, Bob stumbled upon what would be like the Star Trek sort of scenario where it seems like he discovered or claimed these things before they came out, but it's just an inevitability in some of these far-reached sci-fi sort of ideas it seems he's come up with, but there's zero actual evidence of anything that he's claimed come forward with showing the actual technologies.
Look, just on the point of the particle accelerator, at least to my understanding, and look, I've probably seen no more than what you have, right, on the net with regards to what was my interpretation was that he didn't claim that he needed a particle accelerator for anything. He just happened, he's a guy who's
no, sorry to interject. It was a key part that it was to create some part of this oxidization crystallization in the hydrogen container of the storage for it to be run on these hydrogens. Maybe it was graphene or something like that had to be made in his particle accelerator to store it, where it's like just that complexity is just so ridiculous, because literally all you need to do before your fuel injector is have that H2O with a little salt in it, get a little shock of voltage, and it will turn into those gases before combusting. Like, you don't need to store that hydrogen to begin with, yet alone create the graphene to have to then make it, sort of thing. And I'm just saying it seems like it's the same with this element 115 and all of that, that it's like just over complexity, but where's the actual evidence of it all?
Yeah, you're describing kind of a Rube Goldberg thing, right? That would be your concern. I mean, sorry, Riccardo.
Certainly, to my eyes, pardon me, in the element 15 and the propulsion space, and specifically the claims that he's made, I don't see complexity at all. In fact, I see absolute simplicity. I don't think there's anything difficult at all about it or complex. It's horrendously simple. If it's actually real, it's just...
Riccardo, have you seen, it was Moon, he was the nuclear chemist of Americas in the 1980s. He's actually got work that does support what you're saying in regards to how you're deciphering what Bob was saying with that. And in no way am I trying to attack your work. Your work is absolutely excellent in that it's all, there's truths in everything, and it's figuring out each piece of this scientific puzzle, and that we have to test it, come up with it, and that is the scientific method.
Yeah, well, and I look at Riccardo's work in the same spirit as Paul Potter, right? Where he's looking at it and saying, okay, how could this work, and how many pieces match up, and if there's smoke, is there fire, and I think none of us are ever going to find definitive evidence of that from the story that's been told, but it sounds like he's finding, well, there's smoke here, and so that this is probably worth more consideration.
Yeah, that's a good way to describe it, Tim. Absolutely. So, look, I don't know whether Bob Lazar's telling the truth or not. I believe he is personally, right? But like everybody, I want evidence. But evidence that I can actually verify for myself, not what's told to me by someone else. And that's what I tried to do.
Yeah. Well, Riccardo, thank you so much. And we have about 4 minutes left, I think, in our Q&A session. I'm not sure if anybody.
Michael's got a question.
Oh, Michael does. Okay. Michael will close us out, I think. Go ahead, sir.
Cool. Yeah, I just had to jump on because it seemed people were unaware of. So it's not just isotopes. That's the thing. It's possible to have nuclear isomers. So you have a number of neutrons and protons, but you also have a nuclear excitation, which may stabilize the nucleus. So you could for example, you can have tantalum 180-M, which tantalum 180 is actually unstable on its own, but when you add a gamma ray of the proper frequency, it actually stabilizes the tantalum 180. So the isomer is stable, even though the isotope is not. So it's possible there are undiscovered nuclear isomers of element 115. I mean, probably impossibly difficult to prove, but it's just the search space is bigger than just isotopes. That's
a really good point, Michael, and I'm glad you brought it up. It's a really good point. I'm glad you brought it up.
Yeah, there's this hafnium 178-M and 180, tantalum 188-M, and it's quite possible there are others that are yet to be discovered that are most nuclear isomers are less stable, where there's like high nuclear spins. There's an with
Sorry, guys. It's because I'm trying to load a reference picture here. Sound will get better shortly.
Should have a decent amount of nuclear spin, some isotopes of them at least. So anyway, that's just a thought.
No, thanks for that, Michael. It's actually a really good point about the isomers. I'm glad you mentioned that.
Yeah, there's a lot here. Well, Riccardo, we're just about at the top of the hour. So, sir, I want to thank you personally for taking the time to present. And let me put this on speaker view, and I want to have everybody here clap and give Riccardo Storti a giant applause. Sir, thank you. That was a good depth, a good overview of the work. You've done a ton of research, and you've tried to kind of put method to madness, I think, where you've taken this.
Gosh, T2.
Thank you very much.
Relax.
Just in closing out, the research article that you should look at, there is literally
T2, quiet.
Literally 30 years. It's taken that long to produce those answers. And a lot of that journey was with Todd. So he can take credit for it as well.
Well, yeah. No, I can't, sir. I cannot thank you enough for presenting for us. And we'd love to have you back as well. But so for right now, without any further ado, it's 3 p.m. Let me go to Todd, who I just saw. Todd, are you with us?
I'm here.
Okay. And we are about an hour ahead of schedule, but and let me see. So today, Todd is going to be discussing ideas related to lifters and ion propulsion. He is trying to verify multiple discus nickel being charged held ion cloud below it and ion cloud above it. And I understand you can put 40 AWB SS wire. I've actually worked with 50 gauge. I know what you're working with. That's pretty fine gauge stuff. Yeah, it's like spider unique stuff with it. And you also look.
Sorry, I've gotten lost trying to find the relevant freaking documents to their conversation in my photos that is just killing my stream. So sorry, we'll stop that and get back to loading Zoom. Oh my god, what's going on here?
I'll see my screen. Okay. Let me know if you can't hear me. So before I start,
yes,
we got a new information from Alexei Chekurkov regarding the Graviflyer.
Nice.
And
this should be Charlie's.
So he said, he told Charlie that
nice.
He got the questions and basically I'm saying you can't. Direction of the Tesla coil windings doesn't matter. From the batteries directly, not from the ultrasonic generator, so there's no adjustment on the motor spin rate of the motors that turn the discs. There should be an independent power supply so as not to affect the operation of the circuit, because the ultrasonic oscillator circuit depends on the voltage. That's how you set the frequency. So if the fans are loading the power supply, changing the voltage, it'll change the frequency. So they are supposed to be independent. The wire from the Tesla coil is connected differently inside the coil if indoors. But if I run the device in the field and use the long wires, then I connect the wire with the end to the output of the secondary coil itself. So in the videos, we've seen Alexei just stick the wire down the Tesla coil tube, capacitively coupling it. But he was saying that when he's outside and he's got the really long wires, he's actually physically making a connection there, which is something I've been saying for a while, that, you need power. You're not going to get that kind of power through a capacitively coupled wire through the insulation. It's just not realistic. So then he gave his procedure, which is first I turn on the high voltage unit, then I start the motors, then the Tesla coil. I start adjusting the parameters of the torsion field. Again, that's kind of vague. Then the ultrasound. I begin to build up the electromagnetic field, driving it into resonance with gravitational waves. That's debatable. With the right tuning, an electromagnetic cocoon is formed that deflects gravity. There is a noticeable pink glow around the Graviflyer frame that lasts for some time. And then contradictory to what we thought he said last time is I did not hear strange sounds during tuning. So last time I thought we translated it to say he, listened for it's not true.
Sorry guys, I'm gonna stop messing around and the sound and stream will be good and
touch the ground as I
solid to come here.
Launch the Graviflyer in the field without insulating the legs. The graphic image shows how different types of fields are located, and perhaps this will help to understand the principle, the structure of the field of the Graviflyer. It will seem strange, but I have no other way to understand it. There are no instruments to measure the frequencies and resonance of the gravitational field, and I can only measure the field boundaries with my gravitometer, which is that invention that he came up with, which is basically an LED between two metal plates. And it seems I've answered all the questions. So this was the new information that we got from Alexei this week. This came just Wednesday. So Charlie asked me to share this, and I'm happy to. Okay, so here's what I've been working on, and this is what Tim was referring to. And this is it's one of these discs that Mark made for me. It's 9-inch diameter. And then I made this little cup washer on the top. I drilled out the holes is what I did. And it's on top of a piece of polycarbonate tube where I ran the wire, the high voltage wire, all the way up the tube to get it to come out in the middle. Just in case the thing flies, I wanted the balance, So it did not fly. But I sharpened the tip to a point, and you can barely see it in these pictures, but there's this 3 mil wire wrapped like a circus tent all the way around the top between these holes and these standoffs. The standoffs are nylon, they're insulated, and then below it, also there is the same type of 3 mil wire. It just makes like a hexagon between these standoffs below it, and it's physically closer to the disc, and these standoffs on the bottom are aluminum, so it's physically in electrical contact with the disc. So the wire on top is isolated, the disc and the wire below it are electrically the same. And then I tested this with high voltage. Now, the first time I tested it, I had used nitinol wire, which, as you're familiar, this wire, when you apply current to it, it stretches or it shrinks. And this first arc I saw, it just melted. The first arc I saw, it just melted. So then I rewound everything using stainless steel 3 mil wire, and it didn't. It works fine. And I want you to see a few minutes of this video here, because the sound these wires make, and basically I have positive connected to the top and negative connected to the bottom. And before I move forward, the objective here is that the wire creates a very strong electric field, just like a lifter, which radiates ions from the air above it. So above it, I have a positive ion cloud created, and below it, for the same reason, I have a negative ion cloud created. And the disk being negative should repel the negative ions below and attract the positive ions above, giving the disk lift. I did not see any lift with this design, but I haven't really spent a lot of time with it yet. But just there, watch what I did. Listen. Sounds like bees. 25 kilovolts.
Your wire is vibrating.
Yeah.
That's the B sound.
Yeah. It's louder as I go up in voltage.
Yeah. So if you went to 50 gauge, that vibration would go away. The noise would go away.
Try ultrasonic.
The other thing that's interesting is you've got
you see these little flashes on the disc? This is what I wanted to show. This is at like 30 kilovolts. These are those little dust nodules Charlie was talking about and Alexei was talking about, is that the ions are literally hitting the disc because they're attracted to it.
Yeah.
It's 30. Interesting. That's what I wanted to show there. Now here's a test. Here's another test. 1 kilovolts. 3, 2, 1. Oh, wait a minute. No, this is the same video again. There we go. Okay. So this is the next device that I came up with. And this is because I got this Tesla coil that pulses, and it has these spikes coming out the top. And when it pulses, it shoots off like 4-inch arcs. And the 4-inch arcs are laid flat because the spike in the middle is taller. And so the electric field from the one in the middle is pushing the ions outward from the middle. Very cool thing, very noisy. It's a spark gap driven Tesla coil. But that gave me the idea of, in the same principle here, I've got these 6 spikes going around and a spike in the middle with a radiator in the middle. And the whole thing is charged. And when I use this material just to add, so it would hold some more charge rather than a smooth disc, which holds a minimal amount of charge. So these, like a golf ball and whatnot, it's supposed to increase the capacitance. Can't say that it did. But the idea here was that as the spikes are electrified, it ionizes the air above this disc, which then the disc being charged to the same potential repels those ions, pushing it down. So I expected it to gain weight. And it did. So, all right, got a new one. Model E. Badass. I got the scope calibrated. Well, 26, 30 millivolts is out. There's 20 grams. 20 grams is definitely noticeable. Now I expect from this design, sitting on the scale like this, single polarity, I expect weight gain because it's going to be pushing down on the scale. Let's see what we get. Oh, but I got weight gain. Look at that. I haven't changed anything yet. I'm at about 21 kilovolts. I just raised it up to 25 kilovolts, and it got heavier. Should be about 28 kilovolts right now. Okay, watch where it is. I just turned it off. Okay, on. Off. Okay, that's so you see it right there, it gained weight just like I expected it to. Alright, got a new one. Here's a little close up. Yeah, that looks more like it. Definitely seen some weight loss, weight gain now. We're up over 105, 110 millivolts. Negative, huh? Negative polarity. Electrons. Shit. So you see, twice there, I had weight gain demonstrated. I actually demonstrated it a third time. Here's the data. We're back. Okay, so this was that first one that looked really good. I checked everything. It was about 20 grams was 1.5 divisions. And so going by that as a calibration scale, I saw 33.3 grams of weight gain as it pushed down on the scale. So it was repelling the ion cloud above it, pushing down. I did try to turn it upside down on the scale and see if it would lose weight, but because it's in contact with the wood, I don't think there's no cloud underneath it. You know what I mean? There's a piece of wood underneath it. Okay, so then I tried hanging it, and this was just yesterday I did this. I set it up and I hung it. I put the videos posted on Warp Drive Tech. It wasn't that eventful because it killed my power supply, but the high voltage basically generates enough high voltage noise that it backfed through the isolation barrier to my 300 watt, 30 volt power supply and killed it. So that was where I left off. But I did get some data hanging it like this. And so with it, the way you saw it in the image, I saw about 6 grams of weight gain, still the same scale of about 1.5 divisions is 20 grams. So, so I saw about 6 grams of weight gain. And then I turned it upside down and hung it. And this was the only shot I got before the power supply died. And it didn't look like anything happened. So upside down, I didn't see any weight loss. It is kind of close to the floor, closer than I wanted it to be for this test. And before I got a chance to make any modifications, the power supply stopped working. I don't want to risk, I have another one, but I don't want to risk it because it's the only other one I have. And I have a new power supply that supposedly can go to 60 kilovolts coming today or tomorrow or Monday. It's supposedly out for delivery this morning. So when that gets here, I will continue. And that was it. So that's where we're at. Back to, I had some good data and good test. I have several of these new devices to test, and it's just a matter of I need more voltage.
Todd, thank you, sir, and I hope to have you back many more times to share updates with us. Same bat time, same bat channel. That just popped into my head, even though it's
really.
Yeah. Thank you.
Not a fan of Batman.
Okay, so let me put this on gallery view. Everyone, please give Todd a hand. And our undying thanks for your many presentations. Yeah, that was, Todd, that was interesting because, as you know, I did tons and tons with lifters. It's just flashback time, Yeah, the thinner wire gauge makes less noise. I ended up going to 50 gauge. And then in my case, I went to stainless steel corona wire. It turns out, this is just something that I had seen, copper, that was easier to get when I first started, interacts with the air. There's a chemical reaction that makes a heck of a lot of noise.
Yeah.
So the
stainless steel wire that was singing like that.
Yeah.
And, but yeah, I didn't see 50 gauge, or I would have got that. 40 was the smallest I could find.
The place that I used to buy that was from Information Unlimited. That was, and they may still sell it. It was like an off, I don't know what you would call it. I would just give them a call and say, hey, do you guys have any? And they didn't always have it, so I would kind of stockpile. But
what kind of improvement did you see using that?
So basically, when you go from thicker of any type, when you go from thicker to thinner wire gauge, your noise level drops, and at 50 gauge, you can hear ions coming off it, but you can't hear the wire at all. You don't hear any kind of vibration or singing or anything like that. And so instead of, you've always got that hiss, right? And so the wire noise goes away. You still hear the hiss. The hiss is more pronounced. I played around with a ton of stuff. So the temptation is you get a lot higher ion output with 50 gauge. So it's tempting to try and put a bunch of those wires near each other, right? To run them in parallel. Yeah, and the E field smooths out. And so I had problems with that because my first thought was, okay, I'm going to make a grid and it's going to do tons of ions, but the E field smooths out and it actually doesn't work as well. So
yeah, I tried to keep them far apart to just spread it out over more area. But yeah, I know that too. That's why I went to the spikes, because what it does with the Tesla coil, it shoots the arcs sideways because the one in the middle is repelling the ones around it. So that's why I did this design, because I want the arcs to go out sideways so that the disc has time to repel it.
Now, I did have one anecdotal story. We had a bunch of little stuff, but one that reminds me, your lifter reminds me of this. I built in my case, I tested a pan, I don't know what you'd call it, almost like a scalar antenna. I think that was what it was. It was basically like a donut where it had two rings. So it was, the whole thing was flat. It was actually on like a paper plate. The outside ring was, I think, my collector, and, the inside was the other charge. And then they had like an inch between them. And the idea was, I thought, well, what would happen if I could make ions flow between these? What would that do? And so I didn't really see any results. So I figured, okay, well, I'll hang this thing sideways, right? And I had it hooked up to, it was on a 50,000 volt power supply. When I turned it on, it was suspended by one of the power leads, and I think the other one was just coming off as a ground. So the interesting thing was not movement. The interesting thing was this thing was suspended by one wire, and just in the breeze of the garage, it started to turn. And as it turned, I had my hand on, I had the camera, and I had my hand on the power supply. And as it turned, this thing panned across my body, and like in the line of sight, right? Like it was producing a beam, and the beam went down one arm, and I could feel the hair
just where this beam was hitting, come up on the arm, and I was probably like 4 or 5 feet away from this thing. And then it went down to the hand that was touching the power supply, and when it hit the power supply just shorted out and went dead. So I don't know, and that's with the standard, basically just a Cockcroft-Walton, voltage multiplier.
Yeah. So, like I said, my goal in this is, and the reason I refer to it as an arrow warp spike is because in a warp drive, you think of space-time in front is contracting and space-time behind is expanding, or that the universe in front of you is pulling you forward and the universe behind of you is pushing you away. And so the objective here of having a negatively charged disk and a negative ion cloud behind it and a positive ion cloud in front of it is that same kind of principle, is that the positive ions are going to attract the disk forward while the negative ions behind it are going to push it away. So it's an air-breathing warp drive, is electromagnetic warp drive is my concept here. I don't claim it'll go faster than light. I don't even claim it's going to give me propulsion, but I'm going to try and see what it gets.
Yeah, no, sir, let me take some questions here, and I better read our question and answer thing. So it is Alt-Y and Option Y on Mac or Alt-Y on Windows. For anyone who has questions, I know you're all dying to ask them. There's Chris. Chris, sir.
Hey, Chris.
Oh, you know what? Sorry. Now you can unmute yourself.
Hey, here we go. Cheers, Tim. Yeah, no, that was a great presentation. Thanks. I've been really interested in lifters for a while, like a long time, probably sort of 2000s. I've never actually got to get one to fly yet. I think it's probably the power supply issue, like just ramping it up as I get older and maybe less wiser. High voltage. No, I just had a quick question about sort of the force readings you were getting, because there's obviously sort of the whole question around the electrokinetic field potentially that was Thomas Townsend Brown was looking at, and Jeff Menko just finished his book on causality, electromagnetic induction, and gravitation. It basically says that you should get like a force transient on switching on and off. So which is basically like when you turn it on, it's supposed to go in the reverse of the current. So it's Jeff Menko's way of explaining Lenz's law, of why when you're doing induction, the current, when it switches, it goes in the opposite direction and stuff. So I was just wondering whether you got that, because it looked like you had it hooked up to an oscilloscope, and that you would have probably.
Yeah. Well, what I learned 4 or 5 months ago was that these digital scales and load cells have a very slow sampling time. So what I did was I took the load cell out of the scale. So it's a 5 kilogram load cell, which I've extended off the edge of the bench. And then I made a differential amplifier that's very sensitive and low noise. And I hooked it to the oscilloscope where I can sample at 1 gigasample per second, so that I don't get any aliasing, fake false readings telling me I've lost, 3 grams when it's just bouncing around.
Yeah, like a high pass, low pass filter type situation.
So I made my own digital scale by connecting the load cell to the oscilloscope. And so what you're looking at on the oscilloscope is basically, if you watch the videos on my YouTube channel, Warp Drive Tech, you'll see me dialing in the 0, which is like the tear on the scale, just getting up. It's so touchy, but I get it to within a few tens of millivolts of 0. And then I put my 20 gram weight on there, and I, read what it says on the screen. And, so about 1.5 divisions. And then I that's my calibration, and it's rough. I'm not trying to measure it down to the milligram here. I just want to see the effect and know that it's either pushing down on that scale or it's lifting up from it. Here, I expected it to push down, and it did.
Did you see any sort of increase in thrust as you turned it on? Because I think you were turning it on, leaving it, and then turning it off. Did it kind of go up and then down again, or?
Yeah. In fact, yesterday, before I could go back to the other video maybe, but yesterday it's before my power supply died, it was arcing inside. You could hear it. There was something breaking down inside, going click, click, click. And each time it did that on the scope, you could see the transient where it was changing the weight because it was changing the voltage rapidly as it arced over.
Oh, I can tell you. Yeah, I can tell you what that is. It's arcing inside the CW multiplier. It's arcing from one, and that's why you get the voltage drop, because it's.
I don't have a CW multiplier.
Oh, okay.
No, this is just a 30-volt DC power supply, and I'm using a 0-voltage switch board driving a flyback transformer with a sine wave.
It's arcing inside the. It's arcing inside the coil.
No, but it's not. It's arcing in the power supply. I can hear it. It's the RF or the noise. It's not RF. It's like 40 kilohertz, 30 kilohertz, something like that.
Yeah.
That it's switching. That noise and the high voltage that the flyback is generating is giving me a DC offset. In other words, I'm getting an ion cloud inside the box. All right, which is then feeding back through because it's coupling across an isolation barrier that is, the core is completely isolated from the coil, and I have insulated wire wound on the core. It's completely isolated, but there's enough ionization in there to break over that isolation barrier and feed all the way back to my power supply, making it charged relative to Earth. And because it's got a grounded plug, it's arcing to Earth inside the power supply. And you can hear it. It's going, like I said, it's going to blow, and sure enough it did.
A big old party there. Sounds like a lot of fun.
Anyway.
Do you know what that ultrasound is for? Because I know that you guys were speaking a lot about
shaking off ions.
Oh, is it? Oh, okay.
It's resonance. You want that thing to shake and ionize the air and give you a resonance on that disc that helps to increase the amplitude and spread more ions like a speaker. All right.
Yeah, I guess you have kind of cymatics. When you've got the plate with the sort of the dust on it, and then you can create resonance patterns. I guess you could kind of then do maybe like an ion trap almost in the air.
I did it with salt on the disc at different frequencies, and when you hit resonance, the salt jumps like an inch off the disc. So imagine those are ions in the air bouncing off the disc. It'll help produce a bigger ion cloud. Plus, that ion cloud could be developed into standing waves, which would then concentrate the charge. And so the idea is to develop a standing wave below the disk, where I have a positive cloud above and a negative cloud below, where I can concentrate that charge in the air to cause lift on the center disk. So that's cool. That's my idea of this thing so far.
I thought the ultrasonics could be, because I know there's a relationship between velocity and the electrokinetic sort of vector field as well. So like it's not just charge density or current, it's also velocity as well. So if you're sort of moving stuff like that, then you're potentially, that's like the same thing as sort of switching on and off quite quickly, but using the velocity aspect of it potentially.
Yeah, the force. The force that I've come up with, the equation that I've come up with is the same as like for a lifter, and it is that the force is proportional to the current, which is proportional to the charge density times the velocity. The current density, the force density. Yeah.
Awesome. No, that's great. Cheers, man. No, thanks for answering my questions.
Well, and thank you as well, Chris. Okay, so Harold, sir, let's go to you next.
Good presentation, Todd.
Hey, Harold.
Question for you is this. Recently, I saw, I think you're on the right track about the Gravifly doing with the IU. And recently in YouTube, I saw a video from a new startup in Doral, Florida, about the ionic propulsion, in which they are selling a drone that can lift 2 pounds, and it has a flight time of 55 minutes and can go several miles. And with lifting 2 pounds, I mean, I'm going to 55 minutes, flight time. I wondered, how, if you have seen it, what is your relationship with that in relation to the Graviflyer? Because it might explain why the Graviflyer flies the way that if we're using the ionic propulsion as the main.
Yeah, from my understanding, I saw the video and it didn't say much. I didn't read up on it or do any investigation. Mark Sokol did some, and he said that it had a blower, like a ducted fan in the middle.
I saw something like that in the middle, yes, but they claim that it's all 100% ionic defined technologies, and I was wondering,
I think my understanding, or what Mark said was that the ducted fan is what's keeping it up, and they're using the ionic propulsion to steer.
Okay, and because I saw it recently, and I wondered, that might, that might explain, why the Graviflyer is floating without the fan. Maybe, the spinning disc or something like that. Or what is the contribution of the spinning disc?
It's my theory right now regarding the Graviflyer is partly what I'm just investigating now, because as you're aware, my objective is I've taken the Graviflyer apart into pieces. I think we just lost Harold.
No, I'm here.
Okay. I've taken it apart into each constructive element and testing it separately, right? So as a combination in the Graviflyer, you've got this, what I'm talking about, of creating the standing waves and a positive charge cloud above it and a negative charge cloud below it, and then it has a lift between them because the middle disk is charged. But in addition, the spinning magnets generate a magnetic field the way Alexei draws it. It's like a big donut for us. And as the ions get flung outward by the spinning disks, just like in the Aurora Borealis, those ions spiral and follow the magnetic field lines, creating a electromagnetic Kawanda effect. All right, so it generates the disks blow the air outward, but then the magnetic field grabs those ions and pulls them downward, pushing it up.
Well, that's a good metaphor to explain the whole thing. Because so you're still looking for.
I don't know. I haven't made one fly yet.
Sounds like a good metaphor for that to explain the whole thing. But I look like you're still looking for the synergy of everything to say what is it exactly.
Yeah, well, I haven't gotten any lift out of the magnets yet. Spinning magnets, charged or uncharged, hasn't given me anything. But so far, this test that I showed today with the spiky one is the first time I've seen really any significant amount of weight gain or weight of any kind. So right now I haven't seen anything on the Graviflyer give me any kind of lift. But I'm not done testing. I got a lot of work to do, and I got a day job. I sell solar power.
Okay. Well, that's good. You're making progress. And you keep it. It's interesting what you're doing. I thank you for the explanation.
You're welcome.
Good luck.
Thank you.
me see. Riccardo, sir.
Yeah. Okay, Todd, I've got a question for you. Let's assume that you get your apparatus to work. So it's flying, it's working. Now let's also assume an application as a drone, as a military drone. All right. So you've got a working military drone. My question is, in such an application, would it produce detectable RF of any description? So could it be targeted?
Oh yeah.
Yeah. Right. Okay. All right.
Oh yeah.
All right. All right.
You got to, because it's got to ionize the air. It's going to have a huge fingerprint.
That's what I was thinking. Yeah, that's what I was thinking. Yeah.
But it could be made very quiet, but not electromagnetically quiet.
Yeah.
Okay. Let me see. Do we have any more questions for Todd? There's Jared. Jared, sir?
Hey, just to follow up on that last part about if they'd be visible, it looks like because of the Tesla coil, it emits a fair amount of microwave RF. So, I mean, you'd be able to see it with radar pretty easily.
Yeah, absolutely.
Yeah, it's basically like a giant flashlight in the EM spectrum. I mean, you know, you could probably see that flyback coming a mile away.
Well, what I'm supposed to get today or tomorrow or Monday is still the same kind of design, but it's a specially made flyback transformer that's rated to 60 kilovolts, not this TV monster. It doesn't have all the extra pins sticking out that cause arcs. So we'll see. I can't wait to get it. I've been waiting a month.
Yeah. Let me see. So do we have more questions? Yeah, well, I think we're doing pretty good. So let me do this then. Let me put this on gallery view, and everyone please give Todd an applause again. A giant applause, sir. Thank you for the update. Thank you for coming back. I love it when you present.
I'll let you know when I got more to present. This one was a little tough to squeeze in because I went 2 weeks ago and I was pretty much said everything I had up to that. So I just covered what I've done in the last 2 weeks. So,
well, so now let me go to Mark Sokol and see if Mark has any lab updates.
All right, bye guys.
Thanks again, Todd. If Mark is with us. Okay, so I think Mark is stepped away. You guys want to do open discussion for a few minutes?
Yeah. Look, I've got some.
Oh, actually, is Mark back? Mark. Let me see if Mark is back. Let's do an update now.
Oh, sorry guys, we're just setting up an experiment here.
Oh yeah, Mark. I'm actually we're ahead of schedule. I'm ready for you if you want to present.
Oh yes. Okay, so my apologies. Last week I was trying to show you guys some videos, and instead of showing you the videos, you guys were all watching my OBS video program setup. So we're just going to go over those videos again. And there is one new one as well. Just bear with me a moment while I pull them up. Okay. Test data. Okay, so hold on a second. Size that. Share screen. Okay, now can you see this this experimental setup? Tim, can you see it?
Is it good?
Yes. Sorry about that. I had you on mute. Yeah. No, it looks great.
Oh, okay. So this was one of the first experiments we ran, and instead of using the large electromagnet, we wanted a gradient magnetic field. So that's a stack of 2 neodymium magnets, and on top of it was the millisaucer with bismuth in it, which is, we call it a millisaucer because it's a millimeter-sized saucer shape, and it has bismuth in the center of it, basically making like a 30-gram sample. The horn antenna dispersed the field a bit, so it was not getting a full 200 watts output, probably getting closer like 1 or 2 watts. And the scale measurement was being read via a mechanical scale over here. And I'm just going to run through it pretty fast. Zooming in on the scale, this is over the course of an hour. We're changing different frequencies. Didn't see any movement in it. The scale remained rock solid. This is what I was going in there just to readjust something. So this setup didn't produce much of a result. The next experiment was using a piece of smelted aluminum that had a little bit of iron in it. So this was the ultra pure aluminum sample that we had. Smelted it, added a little bit of iron, and ended up with a little puck. Same setup. There's a larger magnet this time. Scrolling through it over here, we're not seeing any change on the scale. We're rolling through the frequencies. We're rolling through the magnetic field strength, confirming that the RF was going in. Again, this magnetic field was getting just probably less than 1% of all the RF radiation that was coming out of there, and the skin effect would have penetrated the sample. So we didn't really see anything happen with this experiment either. Now this is a close-up experiment. This is a millisaucer. Millisaucer is like 30 millimeters across or something like that. It's shaped like a saucer. This one doesn't have anything in it, so it's extremely lightweight. As I recall, the scale was having trouble measuring something so light, and the diamagnetic effects of aluminum started to become very apparent with this setup. And it became hard to get the sample to stick within its comparable magnetic field for EPR to take effect. EPR happens at 28.025 picohertz per Tesla. So we need a correlation between magnetic field strength and RF frequency in order for that to happen. It was a very small window when you're using a single magnet like this of the gradient, of course. So here we're starting it. Again, you see we did see movement over here, but this is it just dropped in a second, and then it flew up. So it was basically giving us a hard time standing in that center area. Again, this sample is very lightweight. We're talking probably like 2 grams total. So then we zeroed it out so that it's very, very lightly touching this surface. But, if it would lift off the surface, we would see that. And with this setup, we didn't see any weight loss. Remove the. You see, actually, I do see some movement there. Yeah, there is a little movement there. It didn't lose weight, but it did move. It's always fun looking at these movies afterward, because that's when you actually notice what happened. You don't see this while the experiments actually take place. So it did move along the surface there. So there was stiction of it sitting on a surface, lightly supported by the string above it. You can see the string even has a kink in it. That's how lightly it was supported, right? And it actually did move along the surface. That's very interesting. Did not notice that before. And then we remove the
removed the plastic, the PVC, and it just fell down again, bottomed out. So you can't really get great results in that setup. But this is something that I just noticed right now. Look at it sliding across the base over there. That's pretty interesting. Okay. We'll have to redo that experiment in the near future. This next experiment is let me get the name of it again. Niobium. So this one was kind of cool. We used it was sample 24 or something like that. Stuck it inside the chamber, turned everything on. Niobium, magnesium powder inside of an epoxy. And guess what? It lost weight, but not for any good reason. So we started turning on the RF, and here's what happened. This happens pretty quickly. This is a spy camera, by the way. Up on the top left, we're looking through a fiber scope straight into the chamber. And there's a little bit of light in there as well. You're going to see exactly what happens to the sample. And don't forget it had magnesium powder in there, which is highly flammable. So there, rubber bands popped, scale bottomed out, chamber filled with smoke. Sample basically caught fire, quickly shut off the experiment. It bottomed out because the sample fell out of the sample holder, destroyed the sample holder in the process as well. So at this point, we decided we need to put a thermal temperature sensor device inside these chambers. We're pumping them with so much energy that we can cause things to go on fire. This next experiment was thick aluminum plate. It was inside a rail system so that it couldn't move from left to right, it could only move up and down, and it couldn't wobble. There was a lot of stiction in this setup, and as you can see, that there was a tiny bit of movement there, but there was a tiny bit of movement in that scale, but not much. That I think was from going inside, and we went inside to check something, so that wasn't the way it was. Okay. Next experiment was, again, we're doing the business saucer, but this time we're doing it with the large electromagnet over here. So this is a homogeneous magnetic field in the bismuth with the bismuth millisaucer setup. That weighs about an ounce, and it's really, really tiny. I have it right over here. This is that thick aluminum plate that I was talking about a second ago. On here is our temperature sensor that we installed in the chamber. We have the CNC put a special window, a germanium window, to allow for the thermal imaging to come through. That was quite a process. Get the entire thing apart and rebuild it. So at this point is when we really get the experiment started. You can see the RF isn't running. A little bit, but yeah, it's not really moving, just a tiny bit. Sample did warm up as well. We didn't see 80% weight loss, as Alzapon said, that's for sure. This is sample number 3. We were a little excited that night. Had a couple friends over on Zoom, and we were doing anti-gravity experiments with aluminum powder inside of epoxy. Now, in this setup, you can see the temperature reading over there. Those are in degrees centigrade. So we were monitoring temperature as we're going through these experiments. We had to shut down the experiment every once in a while. The temperature, as soon as it got near boiling, I started, getting concerned that we would again melt the plastic sample holder or the string that was holding it. So we had to take breaks The experiment process was about an hour long. There was a little weight loss there. Get a little bit more, and we set up a. That was the radio that we set up for listening to the static. But we're concentrating on that scale on the bottom left. There is a couple bumps over there in the beginning, but so there might have been a little bit of weight loss, but in terms of actual usability in a craft, the sample, at least this setup, it was warming up so quickly, really became very useless as a propulsion system, at least in that iteration. The force meter is ignored. That is not part of the experiment. The potential shows, I think, there's a shunt on the electromagnet, and that's the voltage across the shunt. So for monitoring the magnetic field strength, but we've since shifted to a new system where we put a Gauss meter directly on the electromagnet, so we read that to get our electromagnet readings. Actually, Tom, we got to set that up. You can grab a piece of copper tape. Got to set that up for our live experiment. Okay, so this is an experiment that we actually saw something very interesting happen. This is osmium, a little piece of pellet of osmium that was wrapped in the aluminum foil mylar blanket, which is extremely thin aluminum. Now, the sample in this did lose weight over time of significance. See that? There was also a movement in the wire in the reading. But I did notice in this experiment, I think it was around 23 minutes in or something like that, there was a movement in the sample right when the frequency of the magnetic field matched up, right when resonance should have been happening. And the sample twisted a little bit, and that we saw that on the spy cam, which is on the top left of the screen. That was pretty interesting. We're going to try replicating this experiment today, and we're going to do it using instead of a chamber, we're going to have it in open air with a waveguide pumping the RF into the entire Faraday cage behind me. So it's another variation of that experiment. And that is one of the last experiments we did. There's one more experiment, but it's going to pull it out. So we also ran one on just the other day. Okay, there we go. Yeah. So this is a sample of ruby. Now, why are we using ruby? Ruby is aluminum, silicon, and oxygen as well. And so it's basically aluminum, which is one of the stronger participants in dynamic nuclear orientation. It's a compound of it. This is also what George Hathaway used in this experiment. Now, in this setup, we did away with the scale, with the mechanical scale, because we managed to get a very sensitive digital scale that is outside of the Faraday cage. So it's literally on top of the Faraday cage. There's a hole through the Faraday cage, string drop down from the bottom of the scale. I first ran a null test with nothing on the scale just to make sure that it wasn't getting interference from RF. No interference, so we're finally able to use this mechanical scale over here, this digital scale, I mean. Here we're getting 5 feet from the scale on the right. It does, turns on in the room. You can see turns on or off. It's like over there. Yeah, I think that's what we were looking at with these numbers.
Although I did notice that there was spikes in weight loss. Not in this setup. Actually, would be the next experiment that happened. The numbers are pretty. They're just changing with the temperature in the room. I guess that changes some of the electronics on board. And so that's just the nature of these scales. Okay, so in this setup, we covered it with that same aluminum mylar sheet, which is like an emergency blanket that the Red Cross will get out. On powering it up initially, you can see it sort of gets crushed over there. That's from the RF was too powerful. We had to tone down the RF quite a bit. You see, I see negative 26 decibels. I think I dropped it to like negative 50 or negative 40 decibels. So in this setup, there was much more drastic changes. You see here changes of like 5 micrograms, or that would be 50 micrograms at a time. And it was going up and down in all directions. We did notice a correlation between the pulse lengths that we put in and sudden weight losses. It was going in all directions with the weight loss. Again, the sample is not in a perfectly homogeneous field because we couldn't get it to line up horizontally. We'd always want to go in the path of the magnetic field. But you can see here that there were much more drastic changes than what temperature itself can create with our scale system. Of course, a future step would be to isolate the scale thermally in a small chamber, but that's for a later date. Then we'll have rock solid numbers. When I pumped up the power pretty powerfully toward the end, we saw the most dramatic weight losses. That's when I took the sample off. We did see much more dramatic weight losses when I pumped power up to full. And this was with ruby and covered in aluminum. Okay, any questions yet? Yeah, I have one.
Yeah.
Sure, go ahead, Riccardo.
Yeah. So look, first of all, absolutely excellent the work that you're doing, and I've got to say, I feel like someone that's coming in cold for this conference series, I feel like I'm watching history being made. So yeah, really, really well done on what you have been doing and what you've just done now. So that's the first thing I just wanted to say. Second, my actual question is, looking at what you're doing, and I know what Todd's doing, and I've sort of already floated this question to everybody there, but I'm going to put it to you now. Would a discussion around the history of the cosmos, and there have been instances that I believe I can demonstrate where the environment for faster than light travel has occurred naturally, right? Would a discussion in that space assist you in any way, do you think, in helping you to design experiments or things that you might need to consider? Would you welcome some kind of discussion on that point?
On the origin of the cosmos?
Well, no. So let's. I'll just simplify it. So you've got the Big Bang, you've got now. Between the Big Bang and now, right? And then an example is cosmological inflation, where the cosmos inflated in the first, 10 to the minus 23 seconds, and you had an environment where space-time was literally traveling much faster than light. And if you map the history of the cosmos in terms of cosmological components and stuff like this, you can see in the history of the cosmos that there have been instances where the speed of light has been c. It's not actually c now. It was more c. It was faster than c in the past. Would a discussion covering that and looking at the conditions like what the temperature was, etc., all this kinds of stuff. Would a discussion in that space assist you in any way, do you think, in helping you designing experiments that you're doing now? Is it going to assist you? Is it going to give you any ideas, any clues? What do you think?
I don't know. I'm not really sure how the two are related.
Well, I mean, I know in Todd's case, for example, he's looking at modifying the space-time manifold through an analysis of harmonic oscillators, and much of what he's doing now is aimed towards demonstrating how space-time can be the manifold can actually be manipulated. So I'm wondering whether the work that you're doing might get some kind of insightful advantage, give you some ideas, some that you might not necessarily have thought to go in the past.
I mean, you're asking me if it's going to tell me something that I didn't know, which I can't know. That's an unknowable that I can't know until we have those conversations, so we know.
Yeah, fair enough. Okay, all right. Look, I was just like I said, I was impressed by what you've done.
Thank you.
I was just wondering whether a discussion in that area might give you some more ideas around different experiments and etc.
I mean, we have ideas for lots of experiments. We have lots of experiments that are half finished too. The issue is that ideas are a lot cheaper than action by many orders of magnitude, and there's probably for every 1,000 ideas, there's one person who actually does anything, and that person who does something has ideas of his own. There's a lot more ideas running around.
Fair enough, okay.
There's a lot more ideas running around than there are people who are doing anything with it, and we're trying to fill that gap with more people that are doing stuff about it. So these experiments surround EPR, electron paramagnetic resonance, which is the Alzafon experiment. Basically, we're trying to orient the subatomic particle spins in the core of an atom using the valence electron's spin, energizing the spin using EPR, basically get magnetic field, which makes the electrons process in a more coherent way. Depending on the strength of the magnetic field, they process faster and faster. So there's correlation between magnetic field strength and frequency of the electron's precession. And we know what that ratio is. It's 28.025 gigahertz per Tesla. And by hitting the electrons at that frequency with that correct magnetic field, you're able to pulse it and that then transfers its orientation as extra energy to the core of the atom, and the core then becomes more coherent. But we believe that when you have this coherent matter state, it will no longer connect to incoherent matter such as the Earth and the cosmos, and it will be free from the restraints of inertia and gravity, but only along its plane of axes and its plane of spin and its axes, which explains why flying saucers cannot do a barrel roll, because they're just flying along a flat plane. They do 90-degree turn at 10,000 miles an hour, but they can't go like that. So this experiment we have set up right over here that you see surrounding me is the osmium with the with the aluminum on it, and we're going to power this up in a moment and see what it does. First, I need to get the Gauss meter installed. So just give us about 2 minutes. We'll get that done, and I'll be right back. Okay.
Okay. So we're waiting for Mark here. We can do open discussion.
Yeah. So just on the point I just put forward, how would people feel about a discussion in that space? Because it seems to me that any kind of propulsion system has to interact in some way with the background field. Right? It has to. right? So even in Newtonian systems, the background field is the air, right? So even with what Mark's doing, trying to change the weight of something, that's changing the weight, which is interacting with the background field. We call it gravitational acceleration. So it seems to me, the idea, it seems to me that relevant that if the history of that background field has changed, are there any clues in that history that might help with ideas, experiments, etc., etc.? That's the question, and I just want to get what people might think about that.
What do you mean by change?
Well, for example, would you agree that the universe is different today, assuming the Big Bang model is correct, right? Would you assume?
I wouldn't assume that.
Well, let's just
it was invented by a Catholic priest. Why would you believe it?
In order to answer your question, in order to answer your opening question, right? What I'm saying is, make the assumption, because you said, is it different, right? Well, the assumption is, let's start with a Big Bang. The initial state was, let's say, some dot, which is the accepted theory in physics, standard model of cosmology. And now we don't have a dot. Now we've got a much bigger dot, right? So everything has changed, right? So what I'm suggesting is that if we understand more about that change, the question is, might that be advantageous to, physical experiments?
It wouldn't be advantageous. I think it would have the opposite effect. If you assume that it's constant, it's not changing, then that's a variable you don't have to worry about. If you have some change, unless you know the rate and you know all the properties of that change, you're just creating too many variables for you to solve the problems. If you assume it's constant.
See, I disagree with that respectfully, and I disagree with that because the rates of change and all that kind of stuff is actually knowable, and it is knowable. I've calculated it, and it agrees with experiment.
So again, it's
so
knowable.
The information, so all that rates of change, that cosmological history that I'm talking about, is knowable, and I've mapped it, and it exactly matches physical observation. So I think the idea of a static universe just does not fit the data at all. And it goes against the standard model of cosmology, which the vast majority of physics agrees with.
Do you believe in offset spatial divergence? You know what I mean?
I have no idea what it is. No.
Okay, offset. That's like if you're on Earth and you travel at 10% the speed of light for a year, and then you turn around and you come back, then the people that you knew when you were alive, they're all dead and gone because of offset spatial divergence. So basically, space depends on your frame of reference, whether you're moving or accelerating or not. Would you agree?
Well, yes, but isn't that just time dilation? So
time dilation, and it can either dilate, it can go both ways. It depends. Depends on whether you're accelerating or you're not.
I agree with you, but I've never heard, I haven't heard it expressed with those words, offset time, what do you call it? Offset
spatial divergence.
Yeah,
travel,
so
you simply put, to travel in space is to travel in time.
I agree with you. What I'm communicating is that I've never heard it actually labelled as offset spatial divergence. I've not heard it called that. I agree with what you're saying, but
well, I appreciate it's a new concept. I appreciate it's hard to wrap your mind around it because you just assume everything is constant, but when you're moving, it's not. Things are changed. You're relative. If you move in space, you move in time. And vice versa.
So I don't understand what you're communicate because
Well,
what
space
you
time
said
depends on your frame of reference. So, like for example, if you're on the sun or near the surface of the sun, your time goes a lot slower because of frame drag, gravitational frame drag. Kind of like
so
when
that's
your cell phone, when you're using your GPS satellite, the GPS satellite's time is faster than our time here on Earth because we're in a gravitational well. So
and that's just standard. That's standard GR.
So, but then you take that and you do special relativity, which is what I was talking about, where if you accelerate towards the speed of light, it changes the properties of time.
Yes. Again, to my knowledge, that's not new information. It's not discovering America. What
You need a big bang for that. That's
no,
why.
but right. Okay. All right. So what I'm saying is that if the space-time manifold has evolved over time, can we learn? And if we want to develop craft that can travel through space, and one concept is faster than light travel, right? So my question is, can we learn anything from looking at the history of the cosmos where faster than light speeds have occurred organically, naturally, and it has, right? And the simplistic example of that in the standard model of cosmology is inflation, cosmological inflation, which occurred in the very first moments of the universe. And cosmological inflation was inserted into the Big Bang model to make it work, right? Now, if faster than light conditions, faster than light kinematics has occurred naturally in the history of our cosmos, if it's a natural occurrence, that means it can in fact be reproduced, right? So what I'm suggesting is, is there any advantage to understanding, to discuss the conditions that occurred naturally? Will that, observing nature, is that going to help us invent machines? That's what I'm suggesting.
Well, that's what we're doing when we're looking in a telescope, is we're looking into the past. Because light travels at a constant. So if we look at Alpha Centauri, which is what, 2.5 light years or something away, and then it took 2.5 years for that light to get to us. So we're looking at the past 2.5 years ago. And if we look at light from a galaxy that's a million light years away, it's a million years old.
Yeah. Anyway, look, I hear what you're saying. My point stands. Is there any advantage? That's the question I'm asking the community. Is there any advantage to discussing the changes of the past to help us build machines of today? That's the question.
Well, it'd be an interesting presentation.
Hey, Riccardo and Michael, if I could just interject real quick, there is one scientist from UC Berkeley, Medina, Raymond Chow, and he was showing that tunneling, which totally natural thing, electron tunneling occurs somewhere around 1.6 C.
Definitely quantum tunneling is faster than the speed of light, but not by a lot.
But what I was going to say was the only way that you would ever be able to see this on the cosmological side of things would be with black holes. If somehow you managed to be able to measure, which I have no idea how we would because it's so small, but if you were to measure this tunneling from one side of a black hole to another, coming through it or whatever, I don't know how you'd be able to see it, that would be the only cosmological way that I could think that we'd be able to see it, because if the wavelength of the electron is stretched across the entire event horizon, right, you see it pop in one side, pop out the other side, and you know the width of that thing, it goes across it faster. But like I said, unless you have a stream of electrons, it's pretty darn big.
A good example of that is a coronal mass ejection. What happens in a coronal mass ejection is that, so like a solar flare, that precedes the CME. It has it takes about 7 minutes to reach the Earth, and if we're like we're right in the eye of the X-ray blast, it wouldn't harm us because of the atmosphere. But now coronal mass ejection, it takes 2 to 3 days to reach the Earth because it's like a big wave of proton flux heading towards the Earth because part of the corona is thrown into space, and then that takes 3 days. But they discovered that on the opposite side of the Earth from where the sun is, a day and a half before the decay rate of certain radioactive isotopes changes. A day and a half before the coronal mass ejection occurs. So essentially there was some kind of signal coming from the sun that was preceded by the actual event a day and a half before it actually occurred. So that's an example where you don't need a black hole. It's just a natural thing that happens.
Right, so anyway, back to what I was proposing. Would the audience, generally, the discussion around the history of the cosmos and the potential for faster than light conditions be of interest to the collective? That's what I'm asking.
I believe that's what we're about, actually. So, like I said, I think it would be great if you would do a presentation or something. I think we're always open to new info.
Well, if I could jump in really quick, I just want to let you guys know that Mark is still working on things. He said that his sample is still swinging.
Yeah, it's dancing around over here. If you guys look on the side, we're just going to wait for it to calm down a bit. The RF is ready, but we're just waiting for the sample to calm down. So you guys continue open discussion for the 5 minutes.
Okay.
And I just found, here's one example of it. Let me see. New system could predict solar flares, give advanced warning. I'm going to paste this into chat. Oh, and they're predicting there may be neutrinos that do it. That's what the sum of the article. That's the.
Yeah. So the article says Ishbeck and Jared Jenkins, a nuclear engineer and director of radiation laboratory in the School of Nuclear Engineering, are leading a research study the phenomenon and possibly develop a new warning system. Jenkins monitoring a detector in his lab in 2006 discovered that the decay rate of the radioactive samples changed slightly 39 hours before a large solar flare. Since then, researchers at Purdue have seen similar variations in decay rates before solar flares. Phenomena represents a possible way to predict solar flares, allowing satellites and power grid operators to take steps to minimize impacts and astronauts to take cover from potentially lethal charged particles emitted during a solar storm. Large solar flares may produce a coronal mass ejection of highly energetic particles which can interact with the Earth's magnetosphere, triggering geomagnetic storms that sometimes knock out power. Solar activity is expected to peak over the next year, and so as part of an 11-year cycle that could bring strong solar storms. Let's see what the date is. Oh, that's 2012.
I think John's got a question for the side.
John, go for it. We're keeping up discussions here. Go for it.
Hey guys, on the topics at end of observations of faster than light phenomena I would throw in that there have been some successful experiments with what are called optical and sonic black holes. Now, they're not to the point of wormholing across it, I would say, but basically, loosely interpreted, these results show kind of a wormhole across horizons. The neat thing about these phenomena is they're not gravitational black holes. So you look into this, it's pretty far out there sounding, but if I remember, these guys pulled this off where they detected Hawking radiation from what they call optical and also audio or phonic. There's some word for it.
Acoustic.
Black holes of sound and light. Right? Have you guys heard about?
Yeah, it's
I think it's acoustic black holes, the expression.
Acoustic black holes, that's the sound version, yeah. And
well, yeah, it's called acoustic levitation. Yeah. That's what I showed earlier. That's what that little was I had with the styrofoam. That's an acoustic levitator.
That might be a little
it's a
different.
Combination of both.
I'm talking about Hawking radiation, basically from a band-stop filter. You have a filter that's clean enough in the noise spectrum, you can detect the production of particles corresponding to Hawking radiation of that that situation that you're creating by stopping the wave phenomenon. So it applies not just to light in the optical black hole situation, which is more familiar, more like what Hawking talked about in the chapter "Black Holes Ain't So Black" in Brief History of Time and in the technical publications that led up to that. But it right with the wave particle duality, it turns out that they calculated this should work with sound as well, and I believe that was the calculated experiment. But I don't know what we can do with it. It's like it's easier to tunnel across the barrier.
Huh.
Well, that's what's it. I was hearing about NASA's plan of solar sail craft with a laser booster, basically, and the things about the size of the sail's huge, but the thing getting pulled by the sail is like the size of a microchip. And they're talking about 20% of light speed, and this is an official project they're trying to get funding for already. But as far as something about that. Yeah, really interesting results. As far as observing the basically cosmological constant at work and seeing the universe expand at faster than light speeds with reference to remote locations to that which is traveling. I think this kind of paid off in the Alcubierre metric and its successor. I think there's a new version of the Alcubierre metric.
Sorry, guys, the audio will be fixed.
Now, these are still monster energy fantasies where we're going to be able to basically detonate a whole star at one instant and travel concurrently to reduce the energy costs. But I have heard just trying to bring that stuff in too. But just a couple of thoughts on stuff that people are working on along the lines of what I'm hearing. But the 20th century,
sorry, guys, just loading a couple links that they've requested in the Zoom. Momentary buffering, but it will get better, I promise. Feel free to donate to the cause so I can upgrade the equipment and we can not have to deal with this, hopefully, in the future. Hey, hey.
I don't know. I don't want to say.
Hello.
What do we call it?
Oh my god, why is it taking so long to link? Oh my god, just load, you stupid Facebook link.
We see maybe some weight reduction or something. Some of us might look into kind of a related phenomena in the mainstream, let's say. And in general relativity, there's this notion of swimming. They even got an article in Science Journal, right? This overarching journal, all the big wig and if you kind of move strong in the presence of a strong gravitational field with radiance far steeper than the Earth's, it's possible to kind of move strategically, to move the mass within, say, the vehicles strategically to greatly I know we were talking about the wheel of electromagnetism earlier.
Come on.
And kind of we lumped in there.
Oh, it's so slow. Even have it plugged in directly to the Ethernet. My fastest laptop. Nope. Buffering.
Something like that. I think he's at universities somewhere in the US. Got this podcast, Physics Frontiers, and in there they got a great episode on electromagnetic propulsion and gravitomagnetism. They got a wealth of resources. This goes back to some of the earliest pioneers in applied relativity. And apparently they calculated there's a power law relationship between regular electromagnetism and gravity that can be exploited at short distances. It's just that no one has a physical material that can actually have the density of the magnetic flux required to see a huge kind of amount of power come out of it. But it turns out that plasmas can be magnetized. And this is what I would recommend people to look at, because it turns out that quite a strong density can be held in a plasma. It's kind of the inverse of the thinking of the tokamak reactor.
Just on a sort of taking a different direction for a moment, I'm just wondering what you guys or what the community might think about. Do they know of any Chinese efforts in this space of electromagnetic propulsion and stuff like that? Because I noticed on the page on ResearchGuy, I noticed the link to my work regarding Bob Lazar. It's called Analysis for Claims Regarding EM Propulsion Systems. I noticed that there's been a big jump in a Chinese audience accessing that information. So I was just wondering whether you guys have heard how seriously the Chinese Communist Party is taking this kind of thing. Anybody know?
I don't think it's a communist party per se. I think there's Chinese scientists that are looking at it. I have some friends that are. This device I got is from China. They have their own. They're working on it. Is the short answer. But is it a government-funded program? I suspect it's like our government's funding. We're here, we're doing it. I mean, there's been a lot of, there's like the Pius, Salvador Pius, like that.
government definitely has
T2.
certain individuals that they have some level of confidence in research, but there hasn't been any like Manhattan Project type budget behind any of it. It's all small scale stuff as far as I can tell. So
I was just wondering. I was just trying to relate it to you would have heard claims by various presidents in the past of stealing intellectual property and stuff like that on a large scale by the Chinese Communist Party across all different areas. I was just wondering whether
Can I throw in on the China connection, Riccardo? The Chinese government invested in a paramagnetism-based, what they're calling an anti-gravity chamber. It is, if I remember, it's too small for a human to get into, but it's much larger than the floating frog experiment with paramagnetism. And they claim this gives them a tunable gravity environment where they can simulate partial Earth gravity. Like they can actually tune they claim. Which, if you think about that, it seems like a bigger claim than just canceling the Earth's gravity with paramagnetism. But
just want to give you guys an update. The sample is still shaking, as you can see in the video. I have a call at 7:45 until 8 o'clock, so I think we'll just hold off on this, let it settle down until 8, and hopefully we'll be calm enough by then until we'll be able to get some accurate readings. So let's keep the open discussion going.
I saw Bernie has his hand up. Bernie, are you there?
Oh,
he sees the top of your head.
Hello. Sorry about that. Trying to find some YouTube links to my buddy at Faraday Research's latest videos in the meantime until he joins in. But he's got some interesting self-made
research is here, and that's Alex Frolov, right?
No, Mike from Faraday Research. He's from Toronto. Oh, there he is. There's Mike. Mike, you can unmute yourself and give a better description of who you are.
Yeah, I kind of feel out of my comfort zone here. Everybody's talking about anti-gravity. I'm more into the energy stuff. But I do think the energy and the gravity have a very important correlation with each other. I have some theories on anti-gravity, and I was listening to a lecture by Eric Dollard. I don't know if you guys know who he is. He's been pretty much studying electricity his entire life, worked for RCA, worked in Bolinas. He's got a very huge background in electrical engineering. And he had this theory that kind of goes back to Tesla, what he was talking about. If you're able to find the universal grounding point of the universe, everything like inertia, all that kind of stuff would basically go to zero. So, you could stop on a dime basically, and how can I put it in proper sense? It cancels everything out. If you're able to ground yourself to the universal grounding point, because us, like, we're on Earth right now, we're traveling through space at a huge rate of speed, and we're also in a spinning motion. So if you're able to find the universal grounding point of space-time and stop yourself in that universal space-time to zero, everything else out, all the forces of gravity, inertia, all that kind of stuff basically stops because you are in the universal grounding point. I don't know if that resonates with anybody. I'm more of the energy field, so.
Would you know if the grounding point is actually a point or is it a state?
I think it's a state.
Yeah, like an inertial state almost, hey, Mike? Right. A relevant perspective state.
Yeah, because the Earth, everybody in it, we're going through space at a speed. All right.
On around
So-
the sun, and we're going, and the sun's going around the Milky Way.
That's right.
And the Milky Way's going in the universe, and so it's like everything's in constant motion.
That's right.
So what you're suggesting is if we could find the quote ground state of the spin of the universe,
The 0 point of it, which would essentially be also your singularity to start from a neutral in a wormhole or portal, I guess, is also what Mike is essentially describing.
well, it's kind of like it's a type of fractal. It's kind of like you think about the atom, and you look at it, and it looks just like a galaxy. Okay, so it's like real tiny, and then something the same thing repeats over and over again.
Right.
So it's a
yeah. As far as I know, there was some writings that Tesla was doing, talking about this universal grounding point, because all the electrons, say you're traveling through space, any matter that is in space, like the ether, it's rubbing off you. It's like you driving in the car and you slam on the brakes and you got that screeching noise of your brakes. That's the electrons in any matter that's in ether affecting your body, but also leaving your body behind, leaving a trail. So Tesla was talking about if you could find this universal grounding point, it cancels everything out. Gravity, inertia.
Yeah, and then you could teleport to wherever you want to go.
Yeah, so
time
now
travel would be possible too, because it's all part of that.
yeah, it's all related. I think we're getting into the quantum part. It's not just
exactly.
gravity.
Something real tiny. It's not something real big.
Yeah.
It sounds to me like that.
Go ahead, hop in.
Can I suggest that this point, probably the closest in our solar system that we can find to this will be your stable Lagrange points. I didn't talk about the difference between the unstable ones also being attractors in a local gravitational field, but they're a repelling type attractor, and they don't have this property in the exact same way. In some ways, it's even probably heightened as far as their attempt to show quantum gravitational effects. Now, I can't promise teleportation or something. I would suspect those type of experiments would be easier to be more successful with less gravitational input in the local field. But my thinking is the only thing I've predicted so far about Lagrange points, I think that in a quantum field, a quantum theory of gravity, Lagrange points should have their own Lagrange points. So if you look at the equation for finding Lagrange points, you have this like radical in the denominator, you have this absolute value in the numerator, and this is like kind of a nested radical kind of system. If you iterate that again, you get another whole set of solutions of, I guess it goes like cubics, and then there's like 25th order or 10th order. I haven't looked at it in detail. I'm still trying to hash this out. But,
so gravity is a parabolic force. So that means that if you factor it, has two real factors, right? Anti-gravity, on the other hand, is a hyperbolic force. So that means it's distance cubed over time cubed, depending. So it has three factors, one real and two imaginary. But we know it's real. We know both of them are real effects. So there's part of the universe of space-time is in an imaginary realm, and part of it's in a real realm.
I'm glad you mentioned basically the complex plane.
Also, that's other term for like the multiverse, but also quantum realm. Is that correct, Boyd?
Yeah. So there's a multiverse of different. It's like there's a little tiny universe, and then there's a bigger universe, and so on and so on. It's like a fractal. Starts out with something and it repeats over and over again, and that's what we call expansion.
if we look at the Lagrange system as a template for this fractal and its branching, it has what's called a forbidden symmetry. For organized matter, you're allowed kind of crystalline symmetries, which have 4-fold, 6-fold, certain even-fold symmetries are allowed. Not the 5-fold that you get with the 5 Lagrange points. This suggests that in a proper coordinate frame, that the universe could be shown to have a quasi-crystal structure, kind of like a fractal state of matter, where that state of matter is inherent at a transition point.
Yeah, so John, kind of what I'm getting you picking up on is that there's multiple states of dimensional matter, like both higher and lower. Essentially, like crystals could maybe even be like a 6-dimensional state of solid matter, where plasma is our 4th state of matter, solid being the 3rd, and there might be an etherical that is the 5th that folds back into itself between the plasma and the crystalline or the higher dimensionals within this matrix.
So this is what makes life possible. How can you continue to have something continue to exist unless it's it's got to be better than unity to be able to grow, doesn't it?
Michael, that's a really great insight, and I'll say even further the definition, going to the definition of life. I got the honor of teaching life science this time around. I said, wait, I'm a mathematician, maybe a mathematical physicist. My principal's like, you got to teach life science. I go, awesome, okay. So I'm studying to the basics. What the hell is life? And stripping aside all the stuff we all know, that they reproduce, they eat, this stuff. You get to 2 main properties, and it's really interesting what they are. The first one is that it exhibits some kind of local order. The second one is that it exhibits a sensitivity to initial and boundary conditions. And you go, wait a minute, that second one, has no one noticed this? That is forgive me, excuse my French, that is the definition of mathematical chaos. So on one hand you have order, and on the other hand you have chaos, and the marriage of those two are to me the 2 salient defining characteristics of life. But guess what? Those are the defining characteristics of the whole universe itself. So some of us might not have that kind of animist philosophy of the universe, and it's great if this doesn't resonate with you and you can't use it. But for me, this suggests that observership, while it looks like it was written out of the quantum axioms, watch out, maybe it'll make a return, and we do need mind to suffuse the universe for it all to work. This seems to be in line with...
wouldn't that suggest that we're all the same life?
That's right. That's what that would suggest, right?
Tim, Riccardo, we're all the same life, and we're looking at ourselves subjectively when we're awake.
We are individual fractals of a higher fractal dimensional consciousness.
I like your idea, Mike. So who can I send my bills to? Who do you send your bill to?
Prime Minister Trustin Judo, I do believe.
Could say that the fractal circles are just nested vortices of time, spatial dimensions of different realities that branch off into different possibilities.
Vortices are a type of fractal. So
yeah. There's a guy named Enerban, I can't remember his last name, but he had made something on the nano brain he's currently working on. You've heard of the time crystals that they supposedly had came out since, I think it was Google or whoever, was working on these crystals that, had different effects at past the virtual photon level or something where, they're supposed to go inverse time. But, they like little space, you have your barriers in that space is things, properties act differently. So, but this guy, he's made this weird organoid type of, it's not even silicon he's using, I can't remember, but he made some type of organoid type of jelly, like little
organoid. Or
yeah,
so that's like that's the metal embedded in some kind of what is it, polycarbonate or something like that.
Yeah, some type of construction. It's biomechanical, or it's really bio, but it's like not got any synthetic parts as far as like circuit boards or silicon or carbon. It's like what kind of like what we're made out of stuff.
Kind of a filter, isn't it?
Yeah.
To clean your, it's like for EMF control or something like that, isn't it?
No, it's made of like what DNA is kind of made out of, but he made this like little, like he programmed the biomatter, but my mind is like can't remember brain farts. Like programmable, biomatter, like they say our DNA carries information that can be reprogrammed, but basically he uses that concept, and he actually made this genetic nanocomputer, basically, and it can calculate differently like DNA could, with information. And I have this whole book. It tells you how to construct the thing and everything. Wasn't cheap, like $200, but it tells you how you can make it and what.
Do you have a link to it that you could put on the chat? Well, when we're off.
Yeah, definitely.
Would you please post it on the chat so that we can all look at it?
Yeah. But you would have to. Yeah, definitely. But his fun thing was like he decided to if the Fourier analysis could not measure all the signal vibration fluctuations exactly, so he proposed using fractal math to measure the fluctuations instead, and using prime numbers as the basis for it. So to let the prime numbers map out all the fluctuations. I don't know how that works, but he called it phase prime metrics, and something about he said that it does. There are no parameters.
Yeah.
Anyways,
ciao guys. Sorry, I've got to get going. It's been really great listening to everybody. Really appreciate some great ideas here. Just wanted to say that. Sorry to cut you off. I didn't mean to. See you guys soon, I'm sure. Cheers.
Thanks.
Much love.
Thanks again. Have a great. And Riccardo, thank you again. I would love to have you present again for us, sir, in the future.
Yeah, sure. No worries. All right. Thanks a lot, guys. Ciao, ciao.
What do you got there, Birdie?
So this is some monoatomic, and can you see that there's a little bit of video wave interference coming up on my camera around this material? Yeah, I've recorded this on all of these plasmoid monoatomic structured elements that it will have that. Yes, exactly. Depending on the light that you have around it and the video equipment, it will range in wave or strength of interference. But this is a combination of monoatomic zinc, silver, and copper I've made together. It's the pure white fluffy stuff. I've been talking with Jeremiah as well as Esoteric Gold here in the past couple of days in regards to how they've made their monoatomic metals through the chemical treatment way of it. And then mine is completely different, where I'm only using a small voltage of electricity in salt water, and then the pure elements themselves as cathodes and anodes to then make and turn into this pure white single atom plasma state. And I essentially predict that it's the quantum matter because it is this single atom plasma state matter that we are making. And it's that I learned from Isaac Newton's alchemy writings that he states that all elements can be broken down into this single white, fluffy, monoatomic, what he calls mercurial white state of metals. And I've turned.
So when you say mercurial, it's liquid?
He says mercurial. I believe it's molecular. It's just old English, like language differential that he's meaning. Yeah, you got.
It's a liquid metal. That's what he's talking about.
Yeah, but he's saying it's in this single white state that they come down to.
Yeah, it's white because
It's this single atom, right? Stuff, and it's.
Metals are shiny because they have free electrons. That's what makes them shine.
So the thing that makes this stuff so special,
it's in a plasma.
So this stuff I've been able to turn copper, aluminum, iron, nickel, gold, silver, bismuth, and I believe a couple more, all into this single white particle stuff through the electrolysis process. And that as soon as they turn blue or green, that's when it's oxidizing and it's particulating and it's forming that bond with another atom, thus no longer that single monoatomic plasma state. And it's that this ionized gas, right? Your noble gases in their plasma state, it's a single atom, but it's super charged, right? It's ionized. So that's what essentially these monoatomics are, is it's the noble metal elements in their single plasma atom state. And with Keshe's research, when they rotate these metals at 4,000 or higher RPM, it starts emitting measurable and usable plasma fields that you can read and register throughout the air with the electromagnetic fields they create.
It'd be cool to X-ray that and see what the atomic structure looks like.
Yeah, so I have lots of these different samples and I can make them out of specific metals where I'm using 24 karat gold, both anode, cathode, same like 99.9 silver when making them, so that I would love to produce controlled specimens to send to the proper lab. Does Mark, do you have the equipment there to test it? Or what would I be using? Because it is this monoatomic state the David Hudson stuff talks about essentially too.
We do not have a mass spectrometer, and that's the equipment I would suggest.
I was talking to John Hutchinson about it last night, and he was saying it was some sort of microscope something that it was.
I can help you out with that, Bernard. You can use your cell phone as a mass spectrometer if you do right, like adjustments to like it's the accelerometer or accelerometer. I can't remember the name, but
accelerometer. That's like motion.
Yeah. Like if you can train that to detect the motion within the air as the vibration, pressure mediations, and I guess hold the phone close to the monoatomics, whatever, you can detect the different rate changes and all that. Maybe just going off by that, you can see if anything has been detected and all that. So like you would have to cross reference things of how mass spectrometry measure stuff with the accelerometer rate changes and how that correlates. But I'm just throwing that out there. That's what I've been experimenting with right now and reading. So how to use novel devices, not needing better methods to prepare equipment. Sorry, just want to throw that out there.
I'm just pinging Mark in the other line here. I want to see if Mark is almost ready for his experiment. Looks like his thing has quit swinging.
Sorry, I was muted there. But what I'm showing is the pure gold layer, and it's a crystallized, I believe, single atom but nano layer of crystal gold that forms in part of this electrolysis process. And it falls off as straight sheets of this single layered gold flake, and that this would be the sort of things that you'd want to layer your gravitive whatever Charlie is working on, and that was just talked about, presented on the spinning discs. There is that you'd be wanting to put these nano layers covering of the different discs, and then some of these monoatomic metals, either layering them or in the center of them rotating.
So I found a lab that could do that, what you're looking for, Bernie.
Awesome. If you post the link in the chat, I will copy and save.
It's the National Institute of Standards and Technologies. That's where you send your samples to get them. If you're going to, like, they'll sell you standards for like your atomic force microscope or your electron microscope. You know what I mean?
Gotcha. And is that applicable for me in Canada, or is that just an American thing?
It depends on what kind of money you have. I think you need US dollars for this.
Alrighty, so
the government respects money.
should probably go back to my local university first and approach them and see if I could use their equipment. I'm guessing then.
What you do is you find out what their equipment is from NIST, and then you find someone in Canada that can do it for less. So I posted the link here in the chat.
There's Mark. Mark!
And sorry, Mike, do you want to go into more, if it's still open discussion, like talking about how you've done your M machine build, your Don Smith spark gap generators, your pulse motor build?
We have like two or 3 minutes until it warms up, so go ahead. Okay. So Mark, when you take over to do your presentation, can I make you the host for open discussion after that? Okay. Yeah, sure. Okay.
I didn't put it to everyone, the link. Sorry, Bert.
No worries. And Mike, do you want to talk a little bit of your stuff?
I was sharing a link. He was
Forgetting the metals test, but Mike, if you want to talk a bit about how you're connecting your Don Smith generator into the different transistors and then into the pulse motor, and then you're making a flywheel build as well into it.
I don't know. I'm confused. That's not my project.
No, that's Faraday. I think he's muted.
Yeah, no, I'm here. I did an interesting experiment about a year ago. I made a miniature. How it works. Fishing, I guess, really. 4,000 RPM, and I noticed an interesting anomaly when I hit the shaft of the end machine with high voltage. The machine started to trail across the table. And I thought at first it was the vibration from the end machine itself, because of, it's not properly balanced. But it didn't do that. It was as soon as I shut it off. The second I hit it with the high voltage, I was hitting it with about 6 kVA at about 42 kilohertz. It started to trail across the table.
it started to vibrate, and then it started to trail across the table.
Is it jumping?
That's what I thought at first, but the second I stopped putting the voltage on it, it stopped. It just basically sat there and spun. So the second I put the high voltage to it, it started to trail across the table. I actually had to hold it back.
So if you kept it at a high voltage and you adjusted the frequency, did that change anything?
Well, I didn't actually have a frequency control with the high voltage modulator that I had. So that would be an interesting experiment to actually, I was able to actually tune
it in, and then it goes flying across the table.
Well, I literally had to hold it. It was trailing across the table. I had to hold it. And the second I shut the power off on it, it settled down and it rested firmly on the table. Now, this apparatus weighed about 20 pounds.
Was the whole apparatus vibrating?
The whole, I had everything. I had the power unit. I had everything on basically not a masonite board, MDF fiber board. And I had the whole apparatus fixed to that apparatus, to the board. And then as soon as I flipped the high voltage on, the whole thing just started trailing across the table.
That it was sitting on moved too?
Yes.
So the whole thing, the whole assembly was vibrating at the same frequency, correct?
Yeah, yes.
And so it was, and you couldn't adjust that vibration?
No, because that high voltage generator I had was a fixed frequency. I wasn't able to vary. The only way I could vary the frequency is if I start playing with the voltage input and output. That was the only way I could maybe alterate it. But the higher the voltage went, the faster it wanted to push across the table. Now, originally I thought it was vibration.
5 kV, you say?
6 kVA.
Because if you had a bipolar amplifier, you could do it.
Yeah, if I could.
You know what I mean? You could pulse it. You could pulse it and then create a on-off state at a fixed frequency.
Yeah, I just never really pursued it because I was more into the energy stuff.
But you said it stopped when you turned the power off, right?
That's right. Yeah.
So what I'm saying is, you turn it on and then you turn it off, and you have a duty cycle essentially. Create a duty cycle on off, and then you increase the duty cycle until you get a 50% duty cycle. Then it's a perfect square wave, right?
Right.
And then you can basically you can adjust the frequency.
Right. See, originally this is not what I was looking for. This was just an anomaly that popped up that I found kind of weird. Because, like I said,
don't stick on DC. AC is where your money is. Look at that's what Tesla did.
Well, exactly. It's pulsating at 43 kilohertz, so it is technically like a pulse DC, right? So, I can't explain it. It was very strange. I wasn't originally looking for that anomaly, but it just happened, basically by accident. So.
Serendipity. I think we're all familiar with that person. Serendipity.
But you see, it kind of. It was
Guys,
weird.
we're just about ready here. Okay, let's start by turning on the magnetic field.
Do we got Mark getting ready to fire this puppy up?
Yeah, it looks like he is just about there.
Oh, I got a quick question that you guys brought up. What do you guys know about plasma rectifiers from old world, like 1900 technology that they used for switching DC to AC or AC to DC in the old systems?
Are you talking like tube?
Yeah, it was plasma.
That's thermionic emission. Yeah.
Yeah, but it was just, they were everywhere. You can look at these old pictures of the electric cars from 100 years ago, and there's these giant glass tubes with these plasma mercury at the bottom, and they're called mercury rectifiers, and they state that it was used for transferring DC to AC.
Probably just outmoded by...
Oh, but they would never burn out because it would replenish itself as the mercury was in it, creating the
old black and white TVs. That's where they use that kind of stuff. The old black and white TVs. had that kind of flyback.
Okay, guys, we're rock solid with the measurement here at 32.0231 grams. So the magnetic field is turned on. Haven't seen any change in weight. We're going to turn the RF on. 3, 2, 1. All right, change the frequency limits. I think that's reflected power. Check the pulse. Not seeing any change in weight there, which is that is slowly shifting the magnetic field, raise the power over that.
You're getting change there. Increase. Oh, big, it just jumped.
There was a bit of a decrease. Oh, look at that.
Yeah, you just lost like 8 micrograms.
Oh, no, it's dropping. It's dropping more.
Yeah.
Oh, now it's coming back. The truck drove by. I don't think the truck drove by.
I can see it moving a little bit.
That would be one of the see calculator real fast.
Come on, baby, come on. Come on, baby, come on. Let's load this fucking link so I can get back to the Zoom stream so you can hear what the hell's going on. So it stops freaking buffering. And also saving Michael Boyd's link that he just sent me so I can test my monoatomic stuff.
Somewhere around here it should happen.
Let's call this speed fast.
Sometimes these experiments can be as exciting as watching grass grow. fully going through the range of frequency of magnetic field strengths. Just pull out when there's a big change. Yeah. Definitely reduce the noise by bleeding at half hour. I'm slowly shifting the strength of the magnetic field 0.1 Gauss at a time.
Okay. How are you doing, Mark? It looks like it's still decreasing.
Oh, there was a big drop there. Oh my God, yeah, it's dropping now. Go back up a bit. Yeah.
So, and you've explained in detail what you're doing, right?
I have. I mean, I explained it quite a few times on the conference.
I was going to say, well, now that you have the results running, I mean, it's probably worth running through it again, you know, because it looks like you're having some kind of a breakthrough here, man.
I don't know. These are numbers in grams, so you're looking at 4 points past the decimal point on a gram. That's a 10,000th of a gram.
Yeah, but it's still a positive result. I mean,
that's definitely moving. Yep. We had it rock solid before. We made it half an hour. It was rock solid when it started. I'll find that sweet spot where we'll lose a full gram. Then we'll get excited. Can you call out the negative positive? Maybe it's just slowly going.
okay. Well, Mark, I'd like to make you the host of the conference if you're open to it, or do you want me to wait for a couple of minutes?
Why don't you wait for a couple of minutes because I'm not next to the computer.
Okay, yeah, that's what I was waiting for.
Oh,
no, that was significant. 84 to 77. More significant.
I'm not really hearing any audio, Mark. Okay. You're just being quiet, that's all.
Yeah, being quiet and the hum of the equipment is probably drowned out or cut off. But that's it. Just turn off the magnetic field altogether. That does anything. Magnetic field is pretty much gone right now. RF off. RF field is off. I don't think we're seeing much this time around. We got the RF off right now. Magnetic field off. Just pump up the power a little bit. A little higher power level.
This is much better than grass growing. This is rivals up there on the level of like watching paint dry.
Yeah, pretty much what it is. Much easier to watch it when it's a fast forward.
Oh, absolutely. So yeah.
Sometimes you see stuff that you don't see in the live stream when you're doing it in fast forward too. Sometimes
that's true. Yeah.
I'm going to spotlight Mark because that way you guys can talk and it won't disappear.
Oh yeah, I actually have two windows open right now, one on each screen. I just put everybody in the gallery on one window and then have him focused on the other one so I can really zoom in and see what's going on. It's too bad he doesn't have more gauging that he could basically throw up on the screen too, so you can see what else is changing while these slight fluctuations in the gram rate weighting is changing. Like any frequency changes, any fluctuations in like the amount of power going in and whatnot.
Change the pulse frequency. So we have several things going on here. We have the RF, which is the pulse.
This is the bit, isn't it? That confuses me. It's like, did we choose to come here to get this sorted out, or is this just seems a little unfair, doesn't it? That we seem to be here and there's this parasite messing up our experience.
And I know in my own life, the times that I've made
See if I can pull this, give you guys a better view of what's going on here.
Yeah, it looks like you're graduated all the way down to 10 thousandths of a gram, so 2-digit movements is a thousandth of a gram.
Yeah, so this is a pulsing RF frequency. Those blue lights over there, that's the forward and reverse power. So we basically are
SWR meter. Tells us how much reflected energy we have coming in. Radiation detector, RF spectrum strength detector. This is a signal generator, RF amplifier, and this is a signal generator that is low frequency that's controlling the pulses of this signal generator. It's at 9.24 gigahertz. Down there is the magnetic, the electromagnetic power supply. We hooked up 3 extra pots. I think they're 10-turn pots to control the current. And on the wall in the back over there is a Gauss meter connected directly to the electromagnet. Right now it's at 3271.3 Gauss. So we should be right around the magnetic field strength necessary for a little more precision.
So I think I recognize that signal generator. Pretty sure I got one on my shelf to the back there.
MC model?
Oh, let me look and see, man. Yeah, it looks like it's probably on the back side of it. There you go. Got it buried underneath 2 oscilloscopes, so. I guess I don't have a model number on this thing anywhere. It just says 200 MS A dash or // 12 bit. The one I've got is something cheap, marked as a K-Moon brand. I tested it on the good oscilloscope though. It's pretty accurate on its frequency output whenever you adjust it. So.
What was that for? Oh, okay. Well, we shut everything down pretty much. You guys got a little view of what it's like to run these experiments. We normally run them for about an hour, shifting all of the parameters and all different variations. It's about as exciting as watching grass grow.
Do you have an XRF there?
That's expand RF, yeah.
No, I mean, do you have an XRF like spectrometer for poking at things to see? It basically gives you readouts of what material you've got. So if you have a table, you're not sure what all might be laying on it, you hit it with that, and it would be able to tell you what not only what's on there, but what percentages of it, like uranium and gold and all kinds of stuff like that. And if you're working with the material, you know what it is, and be able to poke at it while you're basically attacking it. You may see some potentials for using for transmutation for materials that we do need. That this would maybe open a window to. I know they're expensive. That's why I was thinking we need to see if we can't get you guys one.
That would be a great piece of equipment to have, because we need to look at this from a lot of perspectives. I also want to get some maybe slightly radioactive materials to see if we can use this technology to lower radiation levels.
It'd be pretty ridiculous if you were doing something trying to develop anti-gravity and stumbled upon the secret to really making cold fusion work.
Well, I heard so Mark, I want to make you the host now, if you're okay with that.
Go for it.
Okay, good deal.
Can't wait to bounce, cunt.
No, I gotta make dinner for the gang. So. Yeah. Okay. So let me find. Yeah, I will be back probably about an hour or so.
And okay. Next time we see you, see chunks missing from you because the zombie horde attacked you instead of the boogeyman.
Okay.
Mark, I heard Shugnite, I think it's a mineral, SHUGNITE. Like
Jeremy, can you turn on your camera? I'm just asking everyone who speaks to turn on the camera.
Oh, okay. Well, no one mentioned anything, so
we can see your hands.
Okay. Yeah, but I heard Shugnite mineral supposedly reduces excess radiation.
I think he can turn off his camera.
Well, I mean, right now I'm in a dark room because, like, it's easier on my eyes. So, you know.
No, I can't.
We can't see you either way, but
that's cool.
Shug Knight, not familiar with that.
Better to just give us a proton count on whatever it is this element is the elements it's supposed to be composed of.
So we got over here. This was based off of Aidan Schaefer's recommendation. He said I should get some magnesium orthosilicate, which is otherwise known as forresterite, powdered. So I got some of these magnesium orthosilicate samples. They came from Afghanistan, or Pakistan, or whatever. And I took one, we crushed it up, ran it through the mill, and we ended up with this powder over here, magnesium orthosilicate. Of course, this is like this is a compound similar to ruby that's made out of aluminum. This is made out of magnesium, which is also a good retainer of dynamic orientation. So we were going to try some experiments using the magnesium orthosilicate powder as well. And this is also used in cosmetics. Me and Tom got some really nasty headaches when we were making it. So I don't know. I don't know if it was from the powder or from something else.
I got a question for you.
Yeah.
I went back to something you were talking about earlier. You said you were seeing a diamagnetic response from that aluminum, but you quoted it as being the property of aluminum. Are you saying that it changed this property? Because aluminum is marked as being paramagnetic at room temperature under normal circumstances.
I may have misspoke. What I was referring to is the...
Sounds like some monoatomic aluminum.
Aluminum's capacity to retain dynamic nuclear orientation for an extended period of time. And by extended period of time, we're talking milliseconds at room temperature.
Right, yeah. On that scale, that would be basically a pretty decent amount of time compared to what think of whenever humans...
Aluminum and magnesium are supposedly from the best materials for retaining dynamic nuclear orientation at room temperature.
And we weren't talking about Death Row Records, right? Sorry, I just had to ask. Suge Knight, not Death Row Records?
I want to say you were using something that was within a magnetic field, so diamagnetic and paramagnetic would matter, since diamagnetic is a reflexive or a mirror-like effect of a magnetic field, whereas paramagnetic is more like a lens, a focusing agent. It doesn't create any of its own magnetic field, but it can focus one being affected onto it, unlike ferromagnetic material that can be oriented to generate its own magnetic field. So
basically trapping the waves so that there's no loss in signal gain, right? So you're using different crap like.
Thomas Anderson, I'm basically, I believe aluminum is both diamagnetic and paramagnetic, although the paramagnetism is much more powerful than the diamagnetism in it.
Well, it seems like almost all materials can exhibit any magnetic property. It's dependent on, different functions like temperature range. If you raise the temperature of a neodymium magnet, it'll exhibit like a loss of its paramagnetic properties, then you end up losing it. So yeah,
that's called the Curie.
And that's right. That's just one property to change. I mean, if you're changing properties using microwaves and whatnot, you may see something change from paramagnetic to diamagnetic that normally requires negative, sub 100 degrees below zero temperatures happening in room temperature. So
also, if you make materials bring them up to a high enough positive charge where you strip their electrons from them, you can have copper that is as resistant as Nikonol wire, where it just becomes resistant because it's got no electrons left. Wow. So positively charged, it's possible.
So basically, turning copper into plasma.
Well, plasma is actually very conductive, but you're
right. And plasma though is when you separate all the electrons away and push them to a different region, so you have a bunch of cores.
Well, in plasma, the electrons aren't necessarily gone, but they're not bound to any one atom. So,
right. Well, that's what I'm saying. Yeah, you push them further away from the core than would normally be able to maintain a,
Right.
an
So
orbital
many
momentum.
plasmas actually are very near superconducting.
Right. That's why I was thinking that you can get like hundreds of thousands of watts worth of power through a tiny thin little wire by simply running it through it like say 40,000 volts, because you're running next to no amperage, but you're still transmitting the work potential from one end to the other. Whereas you lose all that energy if you run at a much lower voltage, trying to jam all those amps through. I'm wondering if that isn't because the higher voltage is causing an orientation where all the atoms are lining up, so therefore when you jam electricity in on one end, it's popping out the other end instantly instead of some of the energy being lost to, disoriented atoms, the electron fields on the atoms. So
I always thought the amperage was the resistance. Is that correct? I'm kind of
no, the amperage is the quantity of electrons being jammed through, and the voltage, from what I understand, is the speed and pressure at which you're jamming those electrons through.
Okay. The voltage is the signal gain, right? Like that's the safe part you can touch. Kind of like cold. So it's like cold plasma is the voltage, right?
Cold plasma is just basically atoms that have been cooled down after you strip their electrons free.
Okay, and that would be in the electrons.
They still have a very still have a very high affinity to stripping electrons off of anything they come into contact with, so you can use them for basically cold burning through material like a plasma cutter that doesn't produce much heat, but it can still rip the atoms off of whatever it is you're blasting with, because they're sharing electrons with the atoms that you're slamming into, since they don't have any and they need them to finish balancing back out. So
yeah, I mean, because I've heard when I was reading about, I thought only like X-rays and gamma rays were strong enough to bump off electrons off like DNA to cause cancer, and they said that anything else would just be a heating up, anything below that. But it's not true. Like certain lower frequencies can be strong enough in energy to bump off electrons. So, right? If that's my assumption's correct, right?
I'm not sure. I know there's probably a lot of confusion too when people are talking about cancer and plasma, because you've got plasma state of a matter, and then you've got plasma as in like the material that blood cells are carried through. So if someone makes this simple confusion of those two while they're trying to explain something, somebody else could end up with completely the wrong idea of what they're trying to say.
Yes. Well, I study bio stuff, so like I'm getting to where I can like learn how to use a cell phone to like monitor all the body's vital signals. And I mean, I got several experiments I'm running, but I'm getting a lot of data material from like PubMed and it's NHBI or NHBL.com, whatever, .gov, whatever it is, just like, and just trying to figure out like how I can use this, the signal analysis where, like the oscilloscope waves are where, it's going up and down, and then like it would have all the other frequencies like overlap, the one of the signals. Because, you got like, your waveguides when we have like Beryllium cells, that would monitor the spherical model of, reflections, but I don't know if that's very accurate or exact enough to like measure as much as the one where it's just like an oscilloscope type layout, where the signals overlap. Like that one's more accurate than I'm talking about math now, but what I'm saying is that I'm trying to use the cell phone to do that, as regular signals analysis, because I found articles that they just now recently said that they're experimenting with stuff that's beyond the bandwidth limit of the device or whatever, like they're trying to predict how they can get all the information of signals, past that, and like predict, correctly if they got it exact or not. Like the applications of that would be just phenomenal. Like it sounds like they're doing it right, and like there's a guy that the Raymond Royal Wife scope. He supposedly had grinded the crystals to a certain length to where he would say like he'd take the reference beam and the evidence beam that hits the object, and then he would cross phase those, and the exact, like, I guess, opposite phase of the evidence beam, which is the reference beam, and they would even out, any loss in the wave interference, correctly, and then he would extend the resolution past the bandwidth limit, that he sent the evidence signal to go any further, so that's why he was able to, like, scan the actual living plasma from, we're talking bioplasma or whatever, like, the glowing part of the cell or whatever, instead of it just being dead material, when he was, like regular electron microscopes do, so they only see, like, dead material or material that's, like looking at a rock. But with his method, he was able to see stuff that was glowing. So, I'm just giving like a layman terminology. So, but that's what I'm kind of theoretically trying to do with, like, the cell phone, or, other, novel methods without using, like big atomic interferometers or mass spectrometry equipment and stuff. So, just, cost effective. And some people have been experimenting with the cell phone, as a measuring device for stuff like this. There's articles I managed to, get. So, but I'm not trying to hog the thing or anything. I'm just letting you know all the projects I've been working on. So
hey, Jeremy, there's an app that you can download to make your cell phone into a radiation detector.
Oh, that's cool. Like a Geiger counter?
It's like a Geiger counter, but it's not a Geiger counter. And then
does it measure the thermal radiation that gives off, like, the temperature, wavelengths?
No,
I think he's talking about EMF radiation.
No, I'm talking about betas. Betas, basically, it just not betas. It's gammas and beta.
Gamma and beta decay, right? Like pressure mediation.
Well, like if you had an old CRT TV, you could put your cell phone with this app up to it and measure beta radiation.
That's pretty cool. I'm thinking that's the Raman spectra, but like
no, most of the radiation that you would be detecting will be the gamma sort, which is photons.
Now that's cool. That would go hand in hand with my experiment. I've been working with the mandalas.
So now the other thing I was going to tell you is Android operating systems, unlike Apple. Apple, if you want to do an app, you got to pay $100 to get a license. But for the like Android or Samsung type stuff, it's all open source, so you can write your own apps, and there's a lot of software tools on there that are real easy. They're like visual, and so I did an app. I took a class at Cabrillo College, and I used to write software at the beginning of time. Key punch cards. That's what I learned on. But
that's where it's at, man. Like, I still think that that's viable today because of the. We'll get back on topic though, but I think.
Yeah, but what I'm saying though is that you can do your own apps, and it's not that hard. I did one where I took my actual Geiger counter, and it has an audio jack to listen for the click clicks. And I plugged it into the audio jack for my cell phone and wrote a little FFT function that like counted up all the counts, and I aced that class because I was the only one in the class that could interface my cell phone to some other measurement device, because that's how I learned to do it. It was like taking my old 286 computer and hooking it up to my oscilloscope, that kind of stuff. So, but you can do all that, and there's a lot of stuff online. Just look for the apps.
Michael, that's very fascinating and relevant info, actually, and you're reminding me kind of what Hutchinson was talking about a couple weeks back, and how they were measuring atoms' sound frequencies through reverse engineering to speakers. And what you're talking, connecting it through that app, I'm thinking would exponentially give their results and their method way more efficiency and resonant frequency measuring of atomic masses and resonant frequencies through sound frequency, as Hutchinson explained.
Sound is what I mean. When you tap on the table, it's creating sound. It's like light, but it behaves differently.
You're trying to like scale the curve gradient that's evenly through all the wave interferences that are going, basically, so it doesn't jam. But it's like, trying to fit a large wave through the small wave, and that's kind of problematic. That's how I visualize it.
Well, that's what you're doing when you're creating a harmonic, is you're fitting the small wave in the large wave.
Yeah. My experiment, well, not my experiment, but this person, like I said, Nikki Saraswati, Saraswati, that person was experimenting with mandalas to see that it had made chemical changes by the photoelectric effect on objects, as far as like ethanol or crystals, like quartz, and as far as like other objects, is I guess metals that change in oxides and stuff, and then as well as what was another one that the person did? Crap, my mind goes blank. But beverages like coffee. But the person was using a chromatograph. See the rate and change the syllables. So, and I was looking at chromatograph to what it was. This is something new I'm looking into. Stationary phase and mobile phase, and mobile phase detects the rates of change in the solubility, of the solvents, of the whatever your object you're using. So, but they detected ethanol changes in the percentage. I forget how they did it, but they were the mass. They measured the mass of it, and like it decreased by like 2.88%, and apparently that the mandala picture did affect it. So, and they're claiming that they took the oscilloscope and they were detecting gamma radiation coming off of this mandala picture. So,
that's interesting.
Yeah, I got the book, but it's in French. But I'm gonna start testing it. And they said the person took I think it was a blue topaz crystal, and they left it on one of the mandalas. Supposedly it changed color in the next hour or so, a white topaz.
Wow.
So I'm gonna check out, see further about that. That person did not supposedly want to give the information out to mainstream because of whatever deals, but I'm going to experiment with this myself. They say that these mandala pictures at the Temple of Borobudur in India have some significance with some of the structures, because they said that these things would supposedly resonate with other parts of the buildings, and all those buildings in the cells do kind of have a resonant quality to them. So there might be something to it. I know that's very out there, but
well, you got to experiment. Failure's not an option at the learning experience.
Oh yeah, definitely.
Hey Bernie, I sent you that email that I asked you for your email. I sent you an email. Pardon me.
Thank you, my friend. Appreciate it.
Yeah. Well, go ahead. Yeah, the Shugnite, I got that from Dan Winter. So, like, I'm a big...
Dan Winter.
Yeah, Dan Winter, it's exactly what he's explaining is what everyone's looking for, as far as the wave.
He shares some good info with the monoatomics and plasmoids and stuff like that.
All about that. he's a good source for that.
And then his fractal geometry is another really, really good one with the phi ratio and whatnot.
Yeah, I was trying to see if there's much relevance to it. I mean, it's buying me into it, but I want to test it. You know,
that's it. Test it. If you can't reproduce it regularly, nobody's gonna give it much credence.
No.
Is that the Shung? I think it's Shungite from Shunga in Russia, or Shunga, whatever you say. But,
Yeah, that's how I learned it in my geology class. That's why I was laughing at the Suge Knight death row. I was like, oh my goodness, LA.
It negated radiation of some sort.
Yeah, it's supposed to filter out EMF. For a while, they were selling little tiny things that you would like put in your wallet and stuff. I remember this is like way back. This is like in the 80s.
Oh yeah, definitely. I mean, shoot, but
it was like EMF stuff, and there is a real problem with electromagnetic fields. We have what's called electrosmog. If you live in cities where there's all these Wi-Fi, you got to hook up to Wi-Fi, and there's 20,000 Wi-Fis.
Yeah, I know.
It's what they call electrosmog. It's kind of smog. It's bad. It's bad for cells. I mean, it's like your microwave oven is what 2.6 gigahertz. It's it cooks water fine.
Yeah, definitely.
So long-term exposure to low levels of this kind of radiation is harmful to biological systems.
Oh,
there's some people that are very sensitive to it that get sick.
Yeah.
They have to go live where the radio telescopes are, because that's the only place that's safe for them to live. Because where the radio telescopes are, they can't have any EMF.
Yeah, it's like a calm for them, where everywhere else it's like the static is like screaming noise to them.
Oh yeah, they
crushing migraines, all sorts of stuff, right? So
to them. I know people that have actually died from this shit. So
I believe it.
Well, I got something that I could share with you, Bernard. I'm trying to look it up. This guy, like, he made gold or darn it, copper turned to silver and silver turned to gold, like the nanoparticle.
Oh yeah, that's Bernie. He's the alchemist.
I do believe that I've actually produced some of those results myself, but they transmuted back in after about 3 months of being sealed within the reactions, and that through Isaac Newton's writings and my own upcoming theory that I will release of how to do it on a more stable level, but it's cold fusion through electrolysis and emerging of ancient alchemy. And it's very advanced. Isaac Newton's descriptions, I highly recommend people give them a reading, because it's like it's the missing connection of his light, color, sound, relativity to the other aspects of it, and that this electrolysis, alchemy, electric chemistry is this missing cold fusion of nature sort of energy and technology.
There's this guy that was, like said, rubbing the silver onto the, I think it was silver onto the object, but he used to experiment with phonon resonance, and he said that he made the nano particulates of the silver turn to gold. I have this PDF. It actually explains like all the hertz, slash.
Oh, definitely. If you can post the PDF in the chat right now, I would love to take a read of it.
Yeah, you might want to check that out. I got a YouTube channel of this. I'm trying to figure this out. Hold on a second.
For sure.
I think it's kind of cool that Newton, this guy who he basically came up with calculus, which I hated. And he was an alchemist, you know?
Yeah. Well, I'm
It's like, who would ever have thought?
Right.
Like the founder of modern science.
Right, and it's like these billion words of writing and his science work just weren't released to anybody or the public for how many hundreds of years until his death, and they only came public 2 or 3 years ago where they started getting the translations finally.
Yeah, I actually have access to that. I don't remember where. It's unpublished, stuff, but I think everybody can get it. Trying to figure out how to post a PDF in this.
Just in the chat on the side there. I'm just gonna give you guys a quick little brief nonsense demo. See where like this one where it's got the gold nanoplated on the side, or where the gold is turned I can't really see it, but it's a purple in this one. Or more also gold on top and then a little purple on the bottom.
Yeah, okay, I can see that.
And then so this one where it's the blue or the green where it's oxidized, or what the red, which could be a mercury oxide, but that'd be mass transmutation if this is mercury, because it was made, this one specifically, out of copper. But it's that when any of these monoatomics go from the pure white single atom, when it's in that plasma state, that is where you're able to get the health effects from it or the superconductive effects of it. But as soon as you just add that one oxygen to it, where it's now bonded with another particle, that's where you're instantly going to start accumulating your heavy metal toxic poisoning. And it's because it's not a single little plasma element that can go through and resonate with your cells. Instead, it's now this particle solid that's tearing into, getting stuck, and then damaging. And that's why people get...
Does that mean that this is a process that you could use to, say, decontaminate sites? For example, like where there's heavy metal.
100%, Boyd. I don't know if you've looked into the Keshe Foundation's work, but over the last 10 years, they've done, and they were doing some research in Japan and had some success with Fukushima directly, where there's an offshoot company created from their research that's working on it. Yeah. And then I believe Hutchinson was also mentioning something similar about that a couple of weeks ago. Yeah. So there is a lot of it.
That's really cool. That's really cool.
So, but yeah, the main points though being, it's like, even if it's just like the solid, like single atom, but it's gold, you don't want any material matter whatsoever that is other than the straight white, because as soon as you get it oxidized or any other particle, that's where you instantly start getting negative effects instead of the positive health effects, and will very quickly, very shortly, even absorb these oxide, so the copper oxide dust or the gold oxide dust or whatnot, that's like the blue-green out of it, that's then going into your body and then accumulating in mass on that heavy metal poisoning side of it, as opposed to if it's just the pure white monoatomic, it adds up to it.
How do you oxidize gold?
So all of these elements, and I've had, and I'll show you one jar where it is just gold on gold, but it's that I'm using in the electrolysis both the same metals on the cathode and the anodes when I'm making the specific pure monoatomics of those elements, and that if you create it in a stable amount, it will always forever stay in this white pure. Or if for any reason you change like a frequency of electric or just chemical contaminated anything, then it starts to oxidize on its own, turn to the green, blue, or it'll start turning to the red, the yellow as well.
any of your samples with oxidation for gold?
Yeah, yes, I do. I've got several where the gold's directly gone from the white to the blue gold.
Wow. Well, that's cool stuff.
Actually, give me.
Thanks for sharing.
Yeah, no worries, my friend.
Bernie, on theory in transmutation, could quantum tunneling be a factor in how this works? Because if so, say in the electrolysis experiments, this would seem to be a case of a unified field theory, right? Where because quantum tunneling is about the gravitational kind of architecture of space-time, even on a small scale, versus the electromagnetic theory of electrolysis. Do you see this in your analysis?
Yeah, what you're saying definitely would make sense, and like a major part of connecting it on the higher dimensional dynamic bridge of the interworkings of it, and connecting it to the multiverse for sure. It is the gap that you get that resonant frequency of that element down to that vibrational or resonating harmonic, just energy or frequency. Then you're able from that point to do exactly what you just said. And it takes just the smallest amount of energy to shift a whole bunch of that matter. Then, for instance, when I have some of the stuff that is like in the pure monoatomic, and I'll cut off the anode side of it and cut off the red wire going into it, simultaneously all of the white monoatomic instantly turns yellow into what the alchemists say is their sulfur oxide or something like that. But it's resonating on that same, all that plasma matter or whatnot that would be neutral simultaneously with just the smallest little tiniest change of energy can have that huge effect of it. And that would be some sort of quantum tunneling like you're talking about, for sure.
It's almost like a chain reaction. You know what I mean?
Absolutely. And it's that what fascinated me is how many different times and how many different types of reactions have happened with no chemical reaction change at all. And it'll just be like the slightest either temperature or just voltage or reversal of the electrical feed or something like that, that will then have these mass effects on the overall dynamic system. I've got lots of pictures of it, but I'll put together, maybe, Micah, if we could talk sometime and you could help me go through lots of my photographic evidence of my experiments, help me put together a presentation for it.
That would be cool.
One of my other experiments I'm going to try is with using my cell phone. I found a video how to turn my camera sensor into a nano measurement size detector that can detect like brain oscillation or fluctuations, like as far as like the neurosynapse firings and stuff. And I forget the name of it, but it was like optogenetic modulation or photobiomodulation. But I can use the camera sensor to actually modulate the brain frequencies without needing an EEG cap or any connector source, and it will even, despite the temperature.
How's that do that with the RF radiation?
Yes, but like it could even detect more than just the RF radiation. Like it would detect like the light, like fiber optic cables, how the light transfers, through at that I guess at the nano measurement. So, photonics, goes at the nanometer, right? So close to it.
Protons are a million times smaller than a nanometer.
Oh, okay.
They're femtometers. Femtos 10 to the minus 15.
Attoseconds of femto.
Nano is 10 to the minus 9.
Okay.
So you can fit a whole lot of protons in a nanometer.
Okay. Well, they said that this camera sensor, that the way they did it in this video, you can use to detect all the oscillations and all the, you know, like it can do what an EEG cap can do and an MRI and everything can do, but better with just using your cell phone sensor. And he showed the lady showed it like it was a new thing they did last year. I have the video. I hope
it wasn't that lady that got busted for fraud. You probably read about that.
Oh, Making Anna on Netflix.
I probably don't know what you're referring to.
I hope you didn't invest in it, sir.
No.
Theranos, right? The scheme to diagnose most diseases from just one small blood sample.
Yeah, that's the one.
Now, this would be a dream come true for technology, and the promise may have been deliverable on the genetic analysis front. If you think about it, you could amplify a small sample of blood, but the pathogens.
Oh, John, you're so onto it, and that's actually a next level aspect that I'll be showing in my presentation, and it's that when you add a small amount of your own plasma into these electrolysis reactions when making the monoatomic gold and silver, that it simultaneously starts reproducing your own amino acids on the anode side, bubbling up. No matter where you put your hair, your skin, your blood, your mucus into the reaction, it simultaneously puts up this huge amount of bubbling up of your own amino acids DNA that it's reproducing. And that, but so, well, you only want it on your own, right? And then that's exactly it, is it's giving you these single atoms or these single nanoparticles that are your specific RNA or RNA, DNA. So that is your single nano, but that is your nanoparticle. That is your plasma resonant frequency on a single atom scale. That if you're then able to tie into these plasma metals that are then vibrating on your atomic level, that then that energy should be able to be transferred over to your cells in your body. And theoretically, how this colloidal silver, colloidal gold, monoatomic gold would work in the body's system.
Gold finger.
But there's a thing here I'm sharing now with proof of my light photomodulation thing you could do with your cell phone or even a laser. I have this document that says you can use a laser to modulate like glutamate tissue in your brain to be fired upon, and it would release it and allow like excitation of frequency to perform better in those areas in the brain. And you just use a pen laser, if you modulate the frequency, whatever mathematical modulation scheme that would do that. That was like using a 3D hologram type stuff. Like I said, I have the articles on it, so I'm just barely learning all this. But I'm sharing this right now. Using light to transform species, Dr. Dezang Kang, again, if I said that right, repeated passages of polarized light with high-frequency electromagnetic generator passed through a donor chamber with a duck to acceptor chamber with pregnant mother hen. It said the result was a hybrid chick duck with flat beaks, longer neck, webbing between toes, and large internal organs. And it said a repeat of experiment with 500 eggs, 480 chicks hatched. And it said 80% had flat bills, 90% had eyes moved to a position similar to ducks.
Jeremy, sorry, just what's the relevance of this duck breeding? I'm only interrupting because my buddy Mike with Faraday is back, and I think he's got a demo he wants to show of one of his motors.
Oh, sure, yeah. It's basically light energy being used to affect information DNA that is transmitted to future generations. So they use a green laser through salamander eggs and then redirected into frog eggs, and the result was salamanders hatched from the frog eggs. So it was using light to transform species. So and this is by Dr. Peter Gararev. So it's like photomodulation can use the DNA's encoded information, like, and you can actually literally change another entity or whatever, in real time. Transform it depending on the delay time, the phase shift. So it kind of goes back to the project and the Philadelphia experiments. This is kind of like a proof of it.
Maybe that's what happened to me.
No.
But there may be some serious bioethics issues there with animal experimentation of a relatively drastic sort. I'm not sure what theoretical analysis they had done ahead of time for the safety of these animal experiments, but it might not. Some of this stuff might be a little bit questionable on an ethical front.
Oh yeah, definitely. But this proves that everything has its information hologram code, which is the wave interactions modeled, the wave interference nodes, and that makes the hologram, and that's your information code, and you can use that to add something else to change it to similar stuff. So this is like just a proof of it, and these are the two scientists that did it. So I'm sharing all the things.
Reminds me of reminiscent of Rupert Sheldrake's work.
Oh yeah, the morphogenic field. Yeah. But I want to be quiet now because you said that Mark Faraday had something to, so.
Yeah, so I was talking earlier about the end machine. Here it is. So I 3D printed everything. I use a high definition 3D printer. I'm using ceramic seated bearings. The only thing that's conductive are the two neodymium magnets inside the shaft, and then I got the two pickup brushes on the ends here. That's where you would pick up your amperage. So when I hook up a DC motor to it and I spin it at about 4,000 RPM, I get about 25 to 30 amps. Now, the original end machine by Bruce De Palma basically was a very large version of this. This is a miniature version of what he did. So the neodymium magnets, north poles are facing out, negative to the center. So
what's the input power?
Input power is just a regular DC motor that can do about 4,000 RPM.
And what's the motor power? How much power does it take to turn the motor?
To run it at 4,000 RPMs would be about 10 watts.
So
give or take.
It's 120 volts. So I guess what I'm asking is, how much power are you getting out compared to how much power are you getting in?
Well, that's the thing. That's where Bruce De Palma kind of failed to prove the over unity of this machine, because you're getting a huge amount of current coming out of this, but very, very small voltage. Okay? So his machine was, I believe, about 800 pounds. So
I'm asking you about yours because, see, this is with all these lightweight components. You have solved a problem that he didn't have a way to solve. You've got a lighter motor, right?
Yeah, it's a
so
lot
I'm
more
asking, in this case, this experiment you're doing, just guesstimate how much power are you putting into what you're getting out?
Well,
I mean, you can figure it out. It's a 120 volt motor, right?
Well, I'm using a DC motor.
Oh, DC. What is how many volts?
12 volts at, I believe it was about 1 amp. So about 12 watts, say.
So 12 watts in, and you got...
Right. Now, this is where the problem is. Okay? You can get a huge amount of amperage out, but when it comes to the voltage potential, it's in the microvolts. That's the same problem that Bruce De Palma had. Okay, so he built a very, very large version of this where he was able to get 80 volts DC at 2,500 amps. Okay, so you would have
get up hook it up to a little power amplifier that you can buy at
Well, see, this is what I believe Peter Linderman was working on this years ago, back in the early 80s, when he was with Borderland Sciences. So what they did was they actually sectioned off the magnets. So it wouldn't be like a solid magnet all the way around. It would be sectionals, like almost like pie shape.
And would they go the opposite? Would they?
No, it was the same poles all the way around. But what they did was they turned it basically into an oscillating current, put that through a step-up transformer, and then the results changed. That was the only way they were able to get the voltage where, they had all the amps in the world to work with, but no voltage. So
they had to modulate the amperage somehow.
That's right. They had to make that magnetic field into an AC oscillating current in order to get the voltage out.
Well, it's electromagnetic field you're talking about.
Right.
It's not the magnets. It's not a permanent magnet.
That's why they had to do each magnet in a pie shape.
So could you make that with like permanent magnets?
Yeah, you could do it. You'd have to get the magnet specially cut to do what I want to do. It can be done. There's a company actually not too far from me that could probably do it.
Maybe that's the problem. You're trying to use an electromagnet, and you need a permanent magnet.
Well, these are permanent magnets, which I have in here now. They're those giant fishing magnets.
Right, but they're all the same direction.
That's right.
But you could get that cut up, couldn't you?
Yeah, I could probably go to that company and they could probably do a special order for me, and I'd have to give them a schematic what I got
together.
But what I was talking about earlier in the show was the fact that when I hit this thing with high voltage on the shaft, on the shaft I hit it with 6 kVA, the thing started to run across the table.
Oh, I see. Which direction?
Let's see. Look at it this way. It always went to the left for some reason. Always to the left. So that would be.
So the drive. So which side had the drive motor on it?
Drive motor's here.
Okay, and so when you put, and then on the other side, when you put a high voltage on the other side here.
Right.
You put 5 kV or something. Is that what you said?
5 to 6 kVA. Yeah.
Okay. On that question. Then it started to move in the direction of the point where you were applying the high voltage. Correct.
Correct.
Well, more importantly, you said it kept going the same direction.
Yes.
Can you get a level and like something that can really tell minute differences in angle and check the table and see, and make sure one side is not just slightly lower than the other? Because if you vibrate something and there's any kind of gradation, even if you can't see it, it'll slowly go and work its way down. It's what I noticed about the EM drive. They had it on a spindle, and they have this AC transformer built into the whole thing, right? Well, the AC transformer, if you've ever stood near one, they make a zzz.
Yeah, they buzz.
They're vibrating. And have you ever seen a pager that's kind of bubbled because the battery got damaged, and it swells up to make the bottom kind of rounded? And when it vibrates, it keeps spinning around in a circle.
Right.
No wonder they were getting rotational energy, because they were vibrating the whole thing. And it was just because of the angle of whatever it was that was tilted, causing it to rotate that angle.
Right. See, with my device, I did 2 tests. One with the voltage. It would vibrate a little bit, but not very much, because I got this thing pretty balanced. I've engineered it really, really good, to the point I had very, very little vibration even from the motor. But the second I added the voltage, that's where the anomaly happened.
Right. So, I was going to say, that means that basically the waveform that you're putting in that, you said kVA, right?
Yes, 5 to 6,000 volts, yeah.
So, but this is AC voltage you're pulsing into it, or pulsed DC?
It's a pulse DC.
Okay, pulses though, which means that you're generating vibration.
Now,
you're shifting all of the electrons in the atoms on a regular time scale back forward, then letting them relax, then forward, then letting them relax, then forward, then letting them relax.
It's got a hysteresis, so it's gonna take a while.
That's true.
Natural.
That depends on how much time delay between each pulse there is. Because if there's not enough, and it retains that, then it's going to reduce the amount, but you're still always going to have a diminishment on the hysteresis. Hysteresis is not 100%. Like it won't hold 100%. It immediately starts losing. So you're just looking at like smaller and smaller hills, the more hysteresis.
The frequency is about 43 kilocycles.
Okay. So it's still a frequency, and here's the thing. Your vibration rate is still higher than the diameter of your individual atoms, meaning there's more than enough energy to cause it to lift off, then drop on the next and roll down over. And if you look at atomic structures on that level, you're literally looking at millions of little tiny ball bearings jammed together. So any vibration is going to cause it to go just slide right down that thing.
Yeah, I just thought it was kind of odd.
So you measured that the platform that your apparatus was totally level?
Yeah, it was a level table, and it was a solid plane.
Even when was it level? Even when you were applying that high voltage and
same. Yep, all the whole setup was exactly the same. Yeah.
Would you put a force gauge on the opposite side of the table to measure how much pull it had on it?
Honestly, at that time, I'm working on energy devices. I wasn't working on any, gravitic devices.
Well, work is energy.
You know what I mean?
That's what you're doing. You're doing work. So if you're doing work, you got energy. So can't have work without energy.
That's right.
You're working with electromagnetic alternative energy, I'm assuming, using magnetic structures and electrical generation and electrical generation to create magnetic fields to try to create this. I already have a design for a magnet to magnet, like permanent magnet system that you can either use if it's designed for a generator. It doesn't matter how much power you're pulling out of it because it doesn't create drag the way the cogging effect does whenever you hook your wires up and your magnets are trying to go by, because the magnet and the coil are stationary. You're only shutting the magnetic field off and then releasing that magnetic field, and the flow past the magnet is not being interfered, because there's just as much attraction when it's allowed to pass through to the plate that's passing over as there is when it's blocking the field. Right. The other aspect is that if it's built in the motor configuration, it'll generate torque, but it'll never give you any electricity. So you build two of these and tie them together, you can have continuous power that's coming from literally thermal energy is where it's coming from. The thermal energy causing the minute vibrations in the material that the magnets are made out of are causing electron exchange through a crystalline structure that keeps generating an electromagnetic response on an atomic level.
Right.
So if you look at a neodymium magnet, right, on the atomic scale, every single chunk that is a magnetic field is literally 7 iron atoms in a ferromagnetic state on either side of a boron atom that creates a diamagnetic reflection into the iron to increase its magnetic field. Like you're literally taking all of its energy and forcing it back into it and back off the other ends, and then it's capped off on the ends by 2 paramagnetic magnetic lenses of 2 neodymium atoms. And then you start stacking those together. As long as the electrons can be shared through the crystal structure, you get this massive amount of power. The second you break that crystalline electromagnetic or the electron exchange, like say a nickel plating or coating it with like epoxy or something like that, now you start getting a diminishing return, because you've only got a little bit of the energy plus the energy in the next magnet that you can increase that amount of magnetic energy. You remove that material between the two and jam the two together, now you massively increase the magnetic output of the whole thing, because you're allowing those electrons to travel all the way through the entirety of the material from one side to the other.
Right. And basically from the axle out, so all the magnetic flux is being forced to the leading edge, and that's where I pick up the amps of the leading edge of the magnet. So
have you used magnetic structure, permanent magnetic structure isolation and made the mistake of looking at it like you're redirecting the magnetic field, or are you aware that it's actually absorption and either focus or diminishment spread out in order to limit the magnetic field and then increase the magnetic field? Because that's the one thing I see everybody makes. They think if you put a shield around it, you have the north facing this way or that way, and then you rotate it, that it changes the angle that it's at, and it's not. It's just diminishing the amount of the bubble that's sticking out of your magnetic shielding. Because a magnetic shield wrapped around a magnet is about like putting a corset around like a balloon and squeezing it. It causes it to pop out the ends. So you're rolling across that bubble constantly. You can reduce the amount of bubble by rotating it, but it's still a bubble, so that means you still got as much rise as you got fall, so you're not gaining any ground, right? But when you have a magnetic field entering into what's considered a magnetic shield that's very small and long, it will poke out the other end of the shield, right? So kind of like when you take a magnet and you stick it to like a paper clip and then use that paper clip to pick up another paper clip. Right. But if you have a flat plate with layers that create a reversal on each other, you can take that magnetic field that's hitting that plate and have it soak into.
Yeah, you're bang on, Thomas, and it has to. That's like the nano layers of these monoatomics when they crystalline, and then it's these single layered sheets.
Well, you're talking about materials though that are hard to make.
Well, I'm proving they're actually really easy to make.
Structure, it's really easy to just take some steel sheet and some solid bismuth and some rosin plugs and just tin the surface of it and then stack those up.
Yeah, exactly. And what I'm saying is through this electrolysis process that I'm finding is that it's actually a very cheap and easy way to make these layers to start being able to then do exactly what you're talking about and applying them to it.
Hey, the thing you're deep into, I wonder if you could do some digging and try to come up with an effective way to electroplate bismuth.
Yeah, I've got a few experiments I've done with bismuth, and it's cool.
It puts like a black powder coating on anything. And all the research I've done, you have to work with bismuth chloride, which is really hard to make.
I don't use any chemicals.
Water, it turns straight into bismuth oxychloride, which is like a mother of pearl look.
I'm going to sign off. It's been fun.
For sure, yeah. It's about time to get ending here. I'm going to have to, with Mike, Boyd, we'll talk here in the next few days, but get Faraday, Mike, and myself to do a presentation with Tim here where we can actually do some scheduled, organized revelations of what we're working with and discovering here.
Right. Yeah, I was going to say the reason I backed out of the magnetic stuff was because I found a much more effective means of that thermal harvesting through airflow static. Air is always moving at 700 miles per hour, all the gas particles. So if you have two layers of material that can collect electrons or give away electrons to air that's bouncing back and forth between them, you can have as much energy as you want. And this is the thing, it's strictly thermal energy. And we're not talking about thermal flow, we're talking about the thermal mass that's within a volume. Even if it's completely evenly thermally mated, those gas particles have to be moving at 700 miles per hour in order to create that 1 ton per square meter of pressure that you get out of a gas particle. Otherwise, it becomes a liquid. So anything that stays in that gas particle state, man, you got tons of energy that can even be pulled out of just minute amounts of thermal energy.
Yeah, could I just add something? I did the experiment. I used to test a plasma ball, and I get these plates on either side of the plasma ball, and I tap off it, and I can light up, regular light bulbs with the plasma. So I'm creating that flux field, and I'm finding the plates itself are acting like not dielectric, but as a capacitor. And that flux field is immersing itself into that metal, and I'm able to extract that. Now, here's the beauty part. I could put 15 of those plates and extract it 15 times and get the same power with the same.
Have you thought about changing the shape in order to basically concentrate? Yeah. Because the metal
structure shaped different, doesn't look the same. The shape doesn't look the same as it does with the lensing system for lighting, but you can get metal to focus a magnetic field.
Yeah, so actually, the sphere using the plasma ball in the middle.
Is Mark around? I'm trying to actually share, but it won't let me right now. Your one of your videos, Mike, of exactly what you're trying to describe that you have up on your channel.
Yeah, so what I was thinking is setting up a rig that would kind of emulate what a Dyson sphere would be. The plasma ball would be in the middle, and then I would create this fake globe around it and put the plates in strategic areas all around the plasma ball and extract all the power from there. So there would be like maybe gap between the plasma ball.
He's been working with plasma-based technology for quite a while for alternative energy purposes.
Yeah, plasma. I'm finding more and more. Yeah, I'm finding plasma is a really interesting field to be in because you know, the fact that
you get for like the nuclear explosion, they had to use sheet charges in order to create the concave pressure rather than the convex pressure.
Come on.
But the concave-based explosions, there was a weak point around the edges before it hit critical mass. And if you do the same thing with magnetic fields, you probably hit that critical mass for fusion that you're needing to maintain that.
Yeah.
Oh my god, I'm sorry guys. It'll stop buffering and shorting out momentarily.
shielded with you know, like a spray plate itself. But actually turn that plate you know, into like a capacitor, right? Store that power, not only collect it.
God, this is not the one. Holy fucking.
Electrostatic from atmospheric momentum, because
Fuck's sakes.
triboelectric generation, and then Teflon, which has an extremely high negative triboelectric state. You don't want to modify that triboelectric state with something you're covering to collect your electricity. Or pick up their electrostatic energy from the material that the carbon is coating, because it'll be like if you've got it coated.
It's like a dielectric.
Well, no,
Hey, sorry guys, just to interject quickly, I kept trying to load your video there, Mike, but because I'm running StreamYard and Zoom simultaneously, it's screwing me over. Can somebody else I posted the link of Mike's work there, specifically what you guys are talking about in the chat. If someone else can just open it on YouTube and then share it, it should work properly.
Yeah, I think the significant part of the actual experiment is the fact that you can add as many plates as you want in that field. You can multiply the power with
without any extra power input. I think that's the significance of that experiment. So you can put 15, 20, 30 plates, as long as it's picking up that field, that static field that the plasma ball's emitting, you can just keep adding light bulbs and keep adding them, because you don't have to add any extra power to the system.
The signal gain rate when the amplitudes are constructed.
You know, if you ground that plate, it kills it. So it's got to be basically totally isolated, one wire coming off. So I've been actually able to light light bulbs with one wire. I don't need a ground. But since it's been introduced ground to the circuit, the amount of amperage increases quite a bit. So it's actually taking a lot of the power from the ground as well. But I can light light bulbs with one wire.
Now I was just trying to figure out, like I'm in the signal analysis, so I'm just basically going off like a Fourier series type thing, like that one guy was saying. Remember his name? I don't remember. He was like,
Adam Troway, he was working on it. He was actually stopped by the U.S. government, and he was suppressed pretty badly.
Hey everybody, welcome back to Faraday Research.
No, that's
Thursday night.
That's not
or actually Wednesday night, sorry. Yeah, if you haven't subscribed to my channel, bottom right-hand corner, all the links are in the description for my Patreon. And
I don't know. I'm trying. So, Mike, if you can find the right one to play, it would be good.
donated to my channel and subscribed. And
you'll see the plasma ball.
Thank you very much for your help. And yeah, so it's Wednesday night.
Oh my God! Driving me crazy. Sorry.
Monster toroid transformer that my friend from the US sent us to. So yeah, first thing I had to do, I had to map out this transformer. I didn't know what was what. So I basically had to go in and test every single wire, every combination I could.
where they start. That's probably how they do it. So.
Well, I think a plasma like something that they're using in I could be wrong.
No, these are pure energy, that they're using to even broadcast, sounds through, it's not even a craft, it's like, like a hologram based thing, but it's not a hologram, it's made of pure, plasmatic electricity, bunched together or whatever,
Right.
Yeah.
I just want to show this is one of the transformers I'm working with right now. This one's a beast. This thing weighs like 25 pounds. It's like unbelievably heavy. So this one here, I was able to patch in on this wire here, and I had 3 outputs. But the thing is, I had 37 watts going out, but I only had 12 watts going in. So I didn't have to pull any more power, and I'm getting 3 times more output with this toroid. That's with the Don Smith generator.
So that's essentially through magnetic induction of the transformer that you're able to get that.
Well, it's holding the flux inside the transformer. So when I actually disconnected the power source and I started fiddling with a couple of the other wires, I got shocked. So it's holding a capacitance within the core. Now, because it's a toroidal, there's no beginning, no end. So that magnetic flux, the field of the magnetic field is trapped. Not like an open-end coil where it could go out and disappear, where in the toroid, there's no beginning, there's no end. It's trapped within itself. So that field takes longer to collapse. But that would explain why, when the power was already off, I still got shocked. because that field was still trapped in the core. Good enough to give me a good lifter, but nothing lethal. But yeah, that's just some of the stuff I'm working on right now. This thing's a beast, absolute beast. It's 6-inch diameter, and it's about.
Jeremy, did you have something to say, or you're muted there, brother? I saw your lips mute, or you're talking to your YouTube channel.
You talking to me, Bernie, or
the alien scientist there, good sir?
Oh, Jeremy.
Hey, what's up?
There you are, brother. How you doing, my friend?
How's it going?
Can't complain. Pretty good day, all in all.
Sorry, I didn't hear the question. I'm doing a bunch of other stuff. I had the volume turned down, so I'm just I got a couple of things I'm working on.
Fair enough. I'm thinking.
Did you see the in machine I was working on, Jeremy?
Yeah, I saw you holding that. That's interesting.
Yeah, so it's ceramic bearings. The only thing that's conductive on there are the 2 neodymium magnets, the shaft, and then the pickup brushes on the ends. And yeah, I was getting about 25 amps coming off this thing, but very, very little voltage, in the microvolts. But burst upon this machine was about 800 pounds, so he was getting a lot more on the output too. Plus, he was using his contacts were mercury, so he was using some toxic material to actually make like a frictionless type brush.
So since we're in open discussion now, I had a couple things I wanted to bring up earlier, but I was busy putting my kid to bed, so I wasn't available. But you guys can see my screen. Mike McCulloch, he's as you know, he's got a couple DARPA contracts going on over there in the UK, and he posted this on Twitter recently. He said, "I cannot say why here, but I'm in a happy haze period. Bad news travels fast. Good news has NDAs, smiley face." So I thought that was super interesting, because that's one of the groups that has DARPA contracts for, what we call anti-gravity research, or, alternative propulsion research. And, he's definitely one of the people we watch. So when he said that, March 10th, a couple days ago, 3 days ago now, I took notice. I took a screenshot of it. I just wanted to show it here, so we have it on record here.
So we have people watching.
I have a question about that. The one-dimensional of the nanomaterials, is that one-dimensional, even lower than, I guess you could say your computer screen is, the interface with the, is, considered the two-dimensional?
The screen is your 1D level, and then you're adding hyperdimensional fractals into displaying multiple dimensions onto that 1D.
Okay, so your computer interface would be 2D or 1D. Neat. I have an article that's experimenting with 2D dimensional stuff that's a little out there, but the guy says that he's getting energy harmonics at the gold frequency and crap. He said something ultraviolet. So I might post it and say I'm looking for it. So I'm muting right now.
Yeah, it's I kind of sitting on the sidelines because everybody's talking about the anti-gravity stuff. I'm more into the energy stuff, but there is correlation. There is kind of this mesh together with energy and anti-gravity, and so yeah, there is a relationship. I'm just kind of focused on the other end.
Right. Yeah. So as far as energy goes, there's a couple people we should maybe look into getting on here to talk about some of that stuff.
Yeah, I'm actually. Sorry to cut you off. Yeah, I'm working on another project right now where I'm working on a special battery that basically never runs out of power. So I'm sourcing out the materials for this battery, and I'll be making that soon. A few people out there have made it and have had great success with it.
Is that battery in regards to Hutchinson's crystal battery, and then something a little different?
This one's slightly different. It more stems towards Stubblefield's Earth battery.
Okay,
And,
that's cool.
Yeah, so I've been studying Stubblefield for the last couple of weeks now, and I'm finding some interesting information that actually Tesla was a witness to back in the 1800s. He actually went to Stubblefield's farm and witnessed his basically first wireless telephone. So I don't think Tesla was the first. I think Stubblefield was before Tesla, which I didn't know.
Nothing's
Tesla,
new under the
Tesla
sun,
didn't
right?
design a lot of the things that people keep attributing to him. He recognized the capability of interfacing these things and bringing them together that the individuals who created them.
Right.
So he could bring several minds. He was basically bringing several minds together to create something phenomenally beyond what either one of those minds could produce on their own.
Right, that's why he called it radiant energy. He just took what Stubblefield had and repackaged it and gave it a new name.
Well, he had an ability that a lot of those people didn't have, where he would build something in his head and let it run through a full destructive process real time in his head, and then come back and tear it apart and see what went wrong, what effects it had, how useful it was in different ways and whatnot. That these other people, they could see, a one-dimensional aspect of something they were working at, whereas he's working in full 3D simulation,
You're right.
and running it along the four-dimensional, time strain that as he lived throughout his life.
Yeah.
So that collaboration, I think, is important. That's why I said a research facility where energy, manufacture technology, and the travel technology, I'll call it that, because it could be any number of things, would really be useful to put a facility like that together where all three are working together to come to a single conclusion. So,
because
pushing all this stuff forward, get it more advanced.
Yeah, because the anti-gravity needs power, right? And then, it just goes hand in hand together. I think they're one and the same.
Well, like I said, you're going to find a lot of evidence in things that you're working on something completely different, that somebody else may go, hey, wait a minute, I've been trying to create that effect there. Yeah. The one that you're complaining about that's causing you a problem, I know how to use that. And if we it's like you're trying to get piece of the puzzle fitting together, basically. So I still think, though, that it needs to be designed entirely like the interior of some sort of starship or a starbase, and then broadcast it constantly, and monetize it. Basically pay for it. It's advancement from just the pure entertainment factor that people get on getting to peer into things and see what's going on, and they become
or giving people the opportunity to reduce their energy bills with a simple copper build.
These people watching out of entertainment, they're all witnesses now. You can't silence a million witnesses, so.
Exactly, but it's that if once we are able to figure out even just like some sort of electromagnetic, possibly plasma interaction, electric component, essentially what these free energy devices seem to have the potential of, but just like if it's reducing people's electrical load off of their house by 30% or 40% in this day and time, that's a lot of both green energy that is not going to be taken out of the ground in oil or disasters, anything like that. And at the same time,
get a little more simple. They're not concerned about taking oil out of the ground.
No, that's not what I'm talking about. I'm just talking about if there can be an electrical device that you plug into your home that reduces by 30% your electrical load that you're using each month, then it's going to take 1/3 of your power bill each month. That's huge to a lot of people in this day and age with these insane markets going up.
Going a step further, reducing it by 100%.
Yeah, but one step at a time, right? It's even if you get something that we can make that's 5% or 10% off people's bills.
And when I'm going up the stairs, I usually take 2 to 3 steps at a time when I'm in a hurry.
Don't we all? But often we then trip upon ourselves and fall down.
Green energy. They have a small section that's concerned about the toxicity, but the majority of those people are concerned about the gases that are pumped into the air that are helping trap solar energy so that it cannot escape fast enough.
I'm not talking about the idiocracy of the sheeple.
Listen, this is important. If we find a way to turn static thermal energy into electricity, you're lowering that temperature ratio and you're producing all the power.
100%.
You're totally killing two birds with one stone.
And that's what we're kind of like working on with the Don Smith aspect, the double spark gap, where it's using radiant energy through the plasma of the spark gap arcs. That is a possibility of it.
Basically, crack water to make oxyhydro power.
Yeah, you can do that too. Actually, you don't even have to do that anymore. It's what's his name? Walt Jenkins came up with a new way of coming up with the nanocrystal plasmoids that Kenneth Shoulders was working on in a device that didn't even involve electrolysis at all. As he used these, the machines that you would see that would create like the mist, those mister things, ultrasonic.
Ionized foggers, yeah, exactly.
Yeah, the foggers.
So it's an ionic mist of actual water. That's the key, is the gas plasmoid is still in its water state. It's not a hydrogen state. It's not an oxygen state.
Right.
This supposed Brown's gas is ionized mist water.
From using tuned lasers to basically blast the mist after it comes off of that. Or you're using two frequencies of laser. One targets the oxygen, the other one targets the hydrogen, making it very easy to just pull those two apart.
Well, see, his experiment, he was creating this fog, putting it through a chamber where it gets hit by high voltage. And the high voltage is what was creating the nanocluster plasmoids. And that is the gas that all these guys that are doing those hydrogen generators in their car right now, they're thinking that they're using hydrogen. Well, the real power was actually getting fused in the water. It wasn't actually getting out. So if you cavitate the water, or based on certain aspects of the design of your electrolyzer, you can get those nano clusters out and into the engine. That's where the real power is. It's not the hydrogen. So Walt Jenkins came up with a device that eliminated the electrolysis process completely. It's gone. You don't need it. He created the fog. He hit the fog with the high voltage electricity. That's what went into the engine. So he eliminated, that aspect of.
I'll say I have equipment for lipus experiments. You familiar with that?
No.
It's an acronym for low intensity pulsed ultrasound.
Okay, so basically these things kind of work on this.
Like you get a tooth, it'll activate the stem cells to go, hey, there's a tooth supposed to be here. It's not here, so we're going to turn into dentine cells, and now you have a new tooth.
Well, I got a tooth missing here. Maybe you can help me out.
I have a few. That's part of what got me started, but then I realized that this technology could probably be used if it could be introduced deep enough into the body. Right. Because what you're doing when you convert a stem cell into any other type of cell is you're starting with that baby age. Right. Telomeres and all the other components. So it basically has the 80-year lifespan within that cell, starting at ground zero. So if you're at 60 and you replace even 2% of all of your cells with stem cells, they will eventually replicate and replace all the ones as they age out. And you're now at maybe a 20 or 30-year-old age overall physically. Now, if you can get the stem cells to replicate themselves so that you've got baby stem cells always on tap, you're looking at like almost permanent life extension right there. And at that point, then you just be a little more careful, because you might actually, if you don't, screw up and get into an accident that kills you, you can live to 10, 15,000 years. And imagine the accomplishment you could have, not only reaching that age, but also always having that plasticity of mind, where you can always, work on new ideas and invest into new concepts. So
even extending your life, say, like 50 years.
Well, that's just it. If you extend your lifespan by 50 years, within 50 years, how many life extension techniques will come up?
Exactly.
If you're not dead yet, you could very well be in that ground zero of never dying of old age.
Yeah, immortality.
Pure old age.
Immortal.
So not immortal. Immortal means you can't die. Just age is a
Greatly
disease.
extended.
Well, no. Age is a disease. We cure that disease, which is much. You look at every disease we've got on the planet. The most deadly disease on planet Earth is age, because if you avoid all the other diseases, you're lucky enough to avoid all those, you're guaranteed to get hit by old age.
Right.
You know. So let's cure that one too. That way, basically, we would make it basically one of those things where you, due to lack of aging, will now have to worry about cancer, because eventually you will have to deal with it. So now we better focus on solving the cancer problem too, so that way we don't have that coming along and knocking us out, because, you know, we just don't have the aging process to age us out before we can get hit by this statistical anomaly.
Well, they did research with biophotons to where if more photons accumulate in like the tubulin of DNA, that the rest of it will cause like a chain effect to fix whatever else is needed that's missing, and basically reversing age. So that you should probably, there's tons of research documents on coherent biophotons curing all types of things, including cancer and stuff.
I'm assuming they're looking at a macroorganism scale when they're talking about reversing age, which means it may not be reversing cellular age, it's reversing the organism's age by activating something that is a younger state and bringing in new fresh cells to replace old dead cells. That's what the likeness is doing.
It's even more than that. It's like it creates the components that are not even present that are needed in the body, that generates it on its own from previous combinations to make what is next needed down the line from outside, regardless of any external source going in. Like any chemical needed, like it produces it on its own, like a self-organizing resonance.
Well, that's what the lipase is doing. You're taking something that's already in your body that has been shut down, so that it can't do the job that it was supposed to do, and busting that halting mechanism off of the genetic code, so they can now do what it's supposed to do. And as soon as it's activated, it goes, "What's missing that I need to now become?" So
it's basically a frequency resonance is what you're doing, right? You're just trying to find the right modulation,
right frequency to affect the right chemical that's affects
that's like
so it's not interfering with it anymore.
That's like using a laser with the right frequency information to say speed up brain frequency to cause excitation in some neurons, like they do with the glutamate blasting. And it doesn't require much. I'm sharing an article here that is similar to that frequency type thing, where they're talking about information batteries, where they changed like the time duty cycles of the computation itself in like circuit boards and regular computers, just by the software and not even the hardware board itself. And they actually managed to decrease actual power needed by 30% to do these mathematical computations in the circuit board. They actually reduced excess heat or power required. So it's like the frequency itself is like the energy source equivalent to like biological. So what I'm trying to say is like it's like they got I guess these information batteries are like the one-dimensional span, if you know what I'm saying. I guess if you fix the modulation phases, you get more efficiency and power. So this article right here is just proving like the concept of what I've been talking about. So anyways, go ahead. I'm just
yeah, guys, I'm gonna have to head out here. It was great to talk to all of you, and I'll pop on again soon.
Awesome, thanks, Alex. Is that your name, Alex?
No, Mike.
Mike, sorry.
Yeah.
I'm going to be going to bed here soon too, and I'm about to shut the stream down. We're at 7 hours going strong, and I'm getting tired. My kid went to bed like 2 hours ago, so he's going to be up at like 5 a.m. and I need to get that sleep in. So cheers all, and great discussion. Awesome time. A lot of cool stuff. I didn't expect that from Riccardo Storti at all with the Bob Lazar thing, and I'm gonna have to get a hold of that and repost that tomorrow for people who missed that on my little glitch that I had. So I'm gonna try and get that up for you guys as soon as possible. But yeah, thank you all and have a good night. And I'll do an update tomorrow on some stuff too.
Sounds good. Much love, brother. Thank you. And yeah, hopefully we can do a multi-stream together here sometime in the next week or so.
Definitely. All right. Thank you all and have a good night. Peace out.
Much love and respect, y'all.
All right, the stream's ended, and I'm gonna dip out. Thank you all. Have a good night.
All right. I'm still here. There's a few of you still here. I was actually, I might be doing the Cydonia Mars pyramids and the real face of Mars disclosure stream coming up right away with Austin from MetaMars. So we will see. I do have it scheduled. I got to check with him right now, and that might be coming up here in the next 20 to 30 minutes. In the meantime, I'm going to play, show some links of a couple quick videos, and be ending this in the next few minutes. Love you all. Thank you for joining. You are what makes this happen. And yeah, you don't want to miss the Cydonia Mars, real pyramids, real disclosure, United Nations face of Mars coming up right away.
This is the bit, isn't it? That confuses me. It's like, did we choose to come here to get this sorted out, or is this just seems a little unfair, doesn't it? That you know, we seem to be here and there's this parasite messing up our experience.
And you know, I know in my own life, the times that I've made major changes, it was like it became more painful not to change than to change. That was when I made big changes.
You know, it's this whole ridiculous narrative of it's an unsafe world. There's not enough for you. It's scary. Everyone's out to get you, and clearly the old civilization was completely the opposite to that. It was all about empowerment, like literally.
Cosmic resonance, I think they called that one. Or
cosmic resonance. That's a better name.
Real science. You can actually produce free electricity, and this is part of what Tesla was doing. Is the differential between the top of the spire to the ground actually creates an electrical differential that you then connect to another wire that goes into the ground, your grounding. Put that into the third phase in your circuit, and then you have a bell ringing circuit, and that actually produces plasma electricity out of the air. It's real technology. These things actually function producing electricity. It's crazy.
the movies are the truth and the news is the lies. They've completely flipped it.
You know, when you look at everything with new eyes and you come across information like she was born into a very wealthy family with elite connections, you know, it means something very different now to me than it would have even a few years ago. And it's our free will that they've really also messed with, because we've been lied to and we react based on lies. Just getting their independence and they're end up in civil wars for 20, 30 years happens a lot.
Because we keep choosing to pick up the gun and use it on ourselves instead of building and uniting and accepting that we are one people, one spirit, one harmony on one plane that together, united, can achieve anything we dream of.
So do you want to, you know, wake up, or do you want to just keep going along because the change is too difficult?
And then give them pieces of information that they will then pursue themselves and look into, and then they'll wake themselves up.
I was going to mention it's the whole red pill, blue pill of the Matrix. I mean, that of the movie. And you can consider that movie as a documentary because they're telling us something about what's happening here. So do you want to, you know, wake up, or do you want to just keep going along because the change is too difficult? Wake up.
You're awesome. And you're awesome. And all of you are awesome.
Hello, YouTube. I figured I'd just do a quick one tonight. Show off a late Christmas present that I got there. And looks like Trump himself. Dear Bernie, you're a great brother. Probably the best ever. Believe me. No one knows brother like I do. To say you are... there is a better brother is fake news. Something great, very special, something, dear Bernie. Anywho, so what was the picture that I have as the image for this video I have up now, and this is a topographical map of the Grand Canyon area. And what that is a geological survey. Each line represents a grid between a certain amount of feet, probably in the hundreds. I'm guessing American feet, not meters. Anyways, topographical map, and literally on the top of every single peak is the perfect alignments of the stars of Orion constellation. It is just crazy. And as you can see there, Isis Temple is Bellatrix. Tower of Ra is, I guess they don't have the name of the star on that one. Betelgeuse is the Tower of Set. I guess the white names is the star names. And nobody talks about this, and it's the nail in the coffin of the evidence that the Grand Canyon is intelligently aligned on one hell of a ridiculous amount of terraforming. Pyramid complex. Yeah, just it's always been extremely fascinating to me. I just go over that a little bit in the episode I did with Rex and Campbell there. I replayed that. We go into detail about that. And then also in the last video I did with Campbell, we were looking over the different golden tablets here, and this specific one, I believe they're only like an inch or something in length, but these are some of the supposed Mormon ones, and that looks like a pretty proto-Sumeric, proto-Ranga proto, almost Norse in the right one, runic language, absolutely. So that's some of the Mormon golden tablets, and once again, it's like it just, who the heck goes through the time to make something of pure gold that, and then have accurate ancient writing in it? That's, lots of them have now been starting to be deciphered, and they're clearly not forgeries. This is one of the bigger ones that is from the Father Crespi collection, and if you look at these pictographic ones, this is actually a low-res photo, not that good of them, but they are ridiculously pictographic, insane, probably pre-deluge Atlantean time frame language. So pre-cataclysm, pre-12,000 years would be my guess for these golden tablets minimum. What else should we do? So I'm also going to remove the orange-haired guy telling me that I am a great brother, because that's no lie, and I'll take praise from whoever every time. I just put that ticker on here before I forget, because we will play a couple other videos, but just to show you guys a little update of my experiment from last time. I'm sorry, just a backup channel randomly at 3 in the morning. Here is an old picture. Here's an old picture of one of my experiments. And that is just a copper coil, but it's in 3 different phases of transmutation in this, where it is white, red, or like a maroon, and a light blue. And it literally looks like those popsicles. I couldn't believe it. Or the American flag just off of a simple copper anode. And the very top is super maroon red, and in the middle you got some of that red before it goes into that light blue. And at the very top you have just the normal copper that hadn't started to transmute into those 3 separate states. How's everyone doing tonight? Today, wherever you are in this plane when you watch this. I hope everyone is doing well. All right, so gonna have to get a better light here. All right, sorry about that, guys and girls, and all you lovely souls. So what's pretty neat is in this electrolysis area down here, it's still got an exclusion zone where it's formed a monoatomic solid layer above, and then water in between the bottom there. And you can now kind of see the nanotubes that have formed there. Kind of see them better there, but it doesn't really do it justice because they're actually quite far out. Couple of them are 2 or 3 inches from the edge, and these are just straight zinc, copper, silver nanotubes that have formed, and then this web-like plasma at the bottom with the exclusion zone still. The bottom is a little bit pinky because I started it with the Himalayan pink rock salt as opposed to iodized white. But just showing the floaty cloud on top and these nanotubes and exclusion zone for one last time, because the zinc anode side here has now completely eroded away. So I have to push more zinc down for it to start working again, but this whole little ecosystem is probably going to putty, and we will see what happens to it. It's snowing plasmas and monoatomics. And instantly, as soon as I put more of the zinc anode side in, the water, the cathode side starts making the atomic hydrogen and H4 gases, again, Brown's gas, and the cloud is pretty interesting, so we will just let it. I actually don't use any acids at all. I'm only using salt water, the metals themselves, and a small amount of voltage. How is the sound, guys? You make a homunculus. I ain't no chicken plucker, Aaron. You want to pluck a chicken, you can go pluck a chicken and get your homunculus chicken guy thing, dude, thinger, majigger. Whatever that homunculus No, I am also adding in more Himalayan salt water right now, so. And this is the salt. It's the electrolysis only works with high amounts of salt within the water. You don't like fresh water isn't very good at conducting electricity, and this is why to the ancient alchemists salt was clearly so important. And we are only beginning to re-understand what they long knew. All right. Let's see now. What should we do right now? First, why not do some global breakthrough energy movement play. Here we go. So once again, this is the Global Breakthrough Energy Movement Conference YouTube channel that I'm on, and I just shared it for you all as it is an insane reference of amazing different topics, geniuses, free energy over unity, anti-gravity, and the rest. Cavitation 0 points. I do want to play a little bit more a king here. There's another good one by him. Hydro projects, or where's his plasmoids? Oh, that's the cavitating one.
Which Bernie's the real Bernie? There's two Bernies. Oh my! Oh no! Sorry, I'll shut up. But yeah, 5 minutes, Jeremiah, and I'll post the video for you with the info.
Doc Michael shared with me Marco Rodin's YouTube channel. He just posted on it for the first time in a couple of years, and he's doing a couple of interviews and presentations coming up on. That is something else I will be looking into very soon. Which one? We will try to go with finishing this one.
100,000 psi. We form a solid state of water, a macroionic water crystal. And this was the discovery of Mark Leclerc, an expert on cavitation. And he says these cause trenches, and at the tip of it is what he called a plasma bow shock wave. It's the active wave, this is 0-point energy coherence. And I says, my God, that is identical to Ken Schroeder's EVs. It was like cemented the deal. He made the same phenomena except using water. What could be simpler? And so there it is. We'll talk about it this afternoon. It manifests in self-acceleration. Ken Schroeder's observed this thing as well. If you let it keep running, it keeps accelerating, accelerating, accelerating. They see a propulsion effect going on. It's like this plasmoid is propelling itself and building up extra energy. And that's how it gets to the transmutation. He has to let it build up its energy first before it strikes the surface to cause the nuclear reaction. Here's a model. We'll talk about it that he drew. Basically, there's a linear axis of water molecules. In the solid state, the water molecule is actually 180 degrees apart. It's not as traditional because we're in a solid state form at this point. We're a water crystal. And Chris Ekman discovered a little bit of preliminary evidence of linear water with excess electrons. That's what his discovery was. And he realized that would not be stable just as a lone molecule. It would have to participate in some type of cluster to be stable. And where that type of thing happens is Rydberg matter. This is in the standard literature where a number of atoms participate together in a coherent structure where the electrons are way out at the d orbitals. So the electrons are in a high energy state. This crystal can actually form in the loops. And these loops are stable under half a micron. And so this is basically the model. The electrically expanded water, we have the electrons out at the d orbitals. The hydrogen likes to hug it. The internal structure has the linear water closing into a loop. So everybody's model is fulfilled. You have the torus form. You have the electrically expanded water. This can polarize. They've seen polarization chains. Observed because it's flexible. They've observed these bubbles, but they like to hug each other. Andrea Pirharts talks about that. A lot of people thought they were hydrogen bubbles, right? But these are actually the water cluster bubbles. And thus, when you take one of those water crystal rings, hit it with a abrupt pulse, boom, we make the plasmoid. So many inventors have cavitated the water inadvertently. They didn't mean to, they just end up doing it. Very typical is electrolysis gas in the narrow gaps. The electrodes have a rough surface. Paul Zaguris made them extremely tight gaps. This is hard to do, under a millimeter. He roughened his plates just by sandblasting. He said they're very important that 45-degree angle makes a sharp lip crater on the plates. So he was the best at making plates. Could make it well. Here's a picture of a sandblaster. And he would just pull water in from the bottom. He actually made a car to run on it, and out would come the gas. He just sucked the water in, out would come the gas from the electrolyzer. Another way to make turbulence is just blow air through it. Archie Blue did that. Didn't know why, right? But it makes the turbulence and it makes the cavitation. A mechanical vibration, as we pointed out on Massa. He intentionally cavitates by jerking paddles, making it jerk very fast. And he's able to run an engine with no air input at all. Is able to store the gas under pressure because it's not hydrogen, and he allows the storage to leak away the hydrogen. And I highly recommend this video. The white gas smoke is generated, so he sees the fog gas. Unless is the closest to having a consistent protocol to generate this gas.
東京大田区のプラントメーカー、日本テクノ。日本テクノの大政社長が開発したこの攪拌機。従来のようなプロペラが回転するものではなく、低周波の振動で攪拌する。中の水は安定して循環するという。洗剤を入れても泡が全く立たない。一体なぜか。通常電気分解すると酸素と水素が発生する。 しかし、大政社長が過去にこの攪拌機を使ってメッキをしたところ、難点とされる大きな泡や水素の爆発が発生しなかった。
振動が伝わってるために表面張力が壊れてですね、泡が形成しようとっても壊れちゃうんですね。だから泡は作りたくても作れない状態がこの現象じゃないかというふうに言われてるんですね。
これをヒントにした大政社長、水に電気を流すと白い煙のようなものが。これは酸水素ガス。普通の電気分解だと水素と酸素のガスが別々に出てくる。このガスは振動攪拌機でないと得られない。
酸素と水素のガスがですね、元素がナノマイクロバブルになって出るところが従来のですね電気分解と全く違うんですね。そしてあと安全な酸素と水素の私の考えでは結合体のガスが得られると。
水素ガスは分子が細かいため、容器などに保存しても漏れやすい。しかし、このガスは2年近く同じ圧力で保存されている。大政社長は酸素と水素、2つの分子が結合し、特殊な構造を作っているからだと考える。ガスの用途はまずバーナーの燃料だ。温度はおよそ700度で、火の中では低い方だが、鉄板を切断できるほどのエネルギーに変わるという。さらに新たな用途も生まれようとしている。東京海洋大学の伊藤教授、7月に酸水素ガスを用いてある実験を成功させた。タンクに溜めた酸水素ガスを燃料に小型エンジンを動かすことができた。空気の取り込み口は塞いでいる。ガスの中に酸素があるため、燃焼時に空気中の酸素が必要ないからだ。水からできた燃料のため、燃焼後はまた水に戻り、有害な排ガスは発生しないという。
Actually, I've got the perfect example for you, Billy.
圧力を加えても爆発しない。インフラとして整備して自由に給油で給ガスができるような状況が作れれば。
I just wanted to point out that this Japanese scientist, industrialist man is stating that this hydrogen gas is very stable even under pressure, which that's a huge aspect of what we are making here and producing. And literally the same fuel gas that this Japanese guy is or scientist is talking about is what you are seeing being made to the left of him in this simple little Tupperware experiment in my basement. Yes, Aaron, a hydrogen engine, indeed, that is the ultimate goal of what we are doing here, because apparently it's pretty easy to convert diesel motored engine into this hydrogen electrolysis, which literally we could start running half the vehicles in North America off of salt water. It's crazy. Anywho, before I get myself assassinated, let's play some more of this video. Hey Mike, sorry, I'm just outside setting this up here. But we are still live on my YouTube, so I can pause it if you want.
Yeah, just gonna go for smoke and I'll be back.
Sounds good. I'm just finishing a smoke and I'm sending Jeremiah the link, and he's gonna join us quickly too, and we will go over some nano coding and all of that lovely stuff.
All right. Cool. I'll log back. I'm gonna log out and then I'll log back in.
第二の水ができた。
Okay, my
エン
friend.
ジンとか
Okay.
発電機だとか、今、化石燃料に変わるものが水から作れてまた水に戻るというふうに、究極のね、地球を救うね、燃料ですよね。すべての燃料にしたい。
解明できていない部分が多い酸水素ガス。だが、大きな可能性を秘めている。
Oscillating fields. Exogen technology was lead engineer Stephen Barry Chambers. Stephen Barry Chambers' sister was Marilyn Chambers, who happened to be the wife of Stan Myers. So after Stan died, she took all the plans to her brother. They founded Exogen. He has 3 patents. They're all the same. And what's unusual about his patent? He did one thing unusual. He puts a toroidal coil under the water. Now, who in the right mind does that? Why would you put an electrical component under the water? But to make a long story short, an oscillating coil.
It's hard not to love this freaking presentation.
If you have charge, water.
Right? I love more ABP.
And this one in particular is just so damn good.
I couldn't agree more. I've watched it at least like 15 times for sure. Absorb something new every time.
Dude. Like, I'm gonna be honest, the Tesla Tech one totally blows.
Because that piezoelectric generates some
It's I don't know about the newest ones. Obviously, like maybe there's a better Tesla Tech new presentation, but the older VHS ones or whatever the heck it was with that, the resolution is terrible, and their videographer, I'll be honest, man, they really could have found a better guy for that. I used to do that job. It's not hard, but it was like constantly the camera was never in the right place. You know what I mean?
Bubbles and steam electricity.
But this is way better.
Oh yeah, right? And like, man, it's so hard watching some of like Tesla Tech Steve's latest uploads where he went from like the 2019 conference back to like the 08 conference, and it's just like, oh my god, it's painful, but it's still good.
Well, the problem is it's not so much the jumping around. I don't mind. I'm happy to see any new content that he puts out there. I think it's awesome that Steve is publishing that stuff, and I hope that he makes some profit. The issue is the guy they hired to do the video. Like they have I think 2 people. They got somebody on the camera, and then they got somebody on the audio and camera mixing control. So you might have like usually 2 stationary cameras. Have one just the screens that might be post processing. Like for the but the issue is like sometimes the presenter will have a laser pointer and they'll be shining on the projection screen. The quality of the camera gear is so freaking low. They'll have like the slides up, but you have no idea what he's pointing at. And they'll be talking about stuff like he'll be talking, presenter's face is up on the screen, but he's actually talking about what's on the slide. And there's like they never bother to put the slide up, so the video doesn't ever show it. And if you weren't there live, you'll never know what the fuck it is that you're supposed to be looking at. It just kills me. It's like, come on, get somebody that knows how to do media. Just get some kid that
someone that knows how to do the job that you hired them for, right?
Very narrow gap.
Now, whoever they got, just I don't think Steve's choice staffing is necessarily always been the best.
He found he had a big one. He didn't know about circulation.
But,
so
yeah, so
to get the over-unity effect.
Anyways, I don't know if you want to see a messy bench.
A very poor generator. This thing might only be 15% efficient. And they work with a very good cell.
How do I put this sucker around?
Gaskets,
I gotta go like this, don't I?
And that cell is I think the trick of why they were successful. And they rode on an elevator for about 8 minutes in a closed loop fashion.
So I've got one of these stupid little things too. Of course, everybody's got to build one of these, right? This is just the basic showpiece. But what's really special are those. Because those...
Ooh, is that them ceramics?
And there's a way to get this thing flying, and I cannot and will not mention what that is yet. But all I can say is all this, let's see, where did I put that damn plate? Oh, there it is. So everybody's using this crap, this texture stuff. And, you know, it naturally oxidizes. It forms a thin Al2O3 layer. And that ain't super bad, but they're not treating these plates correctly, and they're also not understanding exactly what the purpose of the surface treatment does and why it interacts the way it does. So all these atoms have S bands. They're outer valences, outer valence electrons. And in order to really get good motion, you need to get those connections between electrons and protons to stretch out as far as they possibly can. And you really want to snap them. Because something interesting happens when you stress an electric field and take it to its maximum and then, snap it. So what ends up happening is the ZPF has to take into account the extra energy density that's in a localized volume of space. And if you can increase the energy in that local space, the physical permittivity and permeability change. And when that happens, all charges and all matter fall into the change because there is a significant amount of energy in that volume. And so because energy is equivalent to space in terms of time for a particle to transit through a volume, imagine that you have lots of little fluctuations that are kind of, let's say they're like maybe this tall. Now imagine that you start to increase the amplitude of these fluctuations. If I were to pass a particle across these fluctuations, let's say this is an electron, I'm just going to shoot it across the vacuum of space, and we click on a fine scale for its exact position. Let's say we get rid of the uncertainty principle, for example, and just say that we are actually good scientists who understand how the universe works, and we can tell you exactly what the velocity and the exact position of a particle is. Because right now it's theorized that that's impossible. You can't know both simultaneously. Well, anyways, let's say that we're good scientists and we can actually name that. So as this particle, as this electron travels through the vacuum of space, total, evacuated completely down, it's your ambient, couple of Kelvin degrees because of the ambient radio noise, right? So this particle doesn't just go straight like this. It actually will follow the electric fields and it'll do these jagged little motions as it's traveling. And if you can increase the size of those motions by adding your own electromagnetic energy that is above the ambient background level, that particle will have to make those motions, those same motions, but it'll have to travel all your new fields that you just put into that space as well. And because it is traveling through all those extra electromagnetic fields, all that stress energy momentum that you put in there, now the electron has just gained charge. It appears to an outside frame of reference that's not being slammed with those synthetic radio fields you created, that the electron, because it's moving so much more through the same volume of space, and because this velocity must be maintained from the outside frame of reference, it seems to just gain a little bit more than 1 coulomb of charge, which is what it normally possesses. And in that process, you can extract the extra differential between what it used to be before it was in that field and what it is now once it's in that field. That's the entire thing with EVs, the clusters, is that when they start to move together, now you have a bunch of electrons that are physically in motion through space, and they're creating that electromagnetic fluctuation. Now, that's actually how we create the electromagnetic energy in that space, is that we move electrons and we accelerate them specifically. Acceleration is the key.
You that was actually huge what you just described there. Like, I was envisioning in my head as you're saying it all, and you're bang on, Jeremiah. Bang on, my friend.
I can tell you I've tested it and it works. So, but what I don't know how to do, ironically, is I can tell you how to make something fly, and I can't tell you exactly how far I've gone with that. That would get me in trouble. But what I don't know is how do you convert raw bismuth metal into the M state?
So, I've gotten. I'll come back in a moment and play a video where I'm making the monoatomic bismuth off of the anode side of the reaction that I have. And I don't know if I've actually gotten the pure monoatomic bismuth, because I think I've only gotten oxidized versions where it's the plasmoids, but it's got the slight, it always has the teal to it, where I've not been able to isolate the pure white bismuth yet. But it's just the same process of just the salt and the small amounts of cathode or 5-volt electricity I put in, and pure bismuth on the cathode side, and then pure nano-coated copper on the anode side. Or I've also done bismuth on bismuth, both anode and cathode, into the salt water. It's always 15% pure salt into distilled water ratio, and then I just use the 5-volt. But what I'm showing right here, this was a broken jar that I had, it froze, but this was the monoatomic or diatomic bismuth that was, or is, this now dried out.
That is very fascinating. And what I find interesting is that you've got quite a bluish color there. And if we take a look at nano bismuth, it's usually got quite, it's never quite that blue. It's more of a purplish. It almost never oxidizes, just stopping at the yellowish and reddish stage. It's almost always thickly oxidizes down to the deep violets. But you've got something there that's quite a bit different looking. What's the grain of that powder? I mean, can you poke at that so that we can see how heavy that stuff is?
Yeah. And it's just like a fine, like it was that.
Oh, wow. Okay, I see. So it just clumped up, but basically it just falls.
Yeah, it floats like the fluffy stuff in the rest of the jars, and it was before it dried out there. So then also just to answer a question about nano coating, this is in the process of nano coated Keshi Magrav triple solenoid copper coil, but it's in the caustic solution, and it develops the outer layer of these nano coating breakdown. But the big point is that you have to be extremely delicate with it, because as soon as you start moving it around, breaking down the shell of it, you're exponentially deteriorating its effectiveness in the monoatomic plasma interactions of the energy fields, because you're breaking down those outer nano-layered walls that are then interacting with the plasma state.
I know exactly what you're talking about, man. He's
exactly
interesting
so
with his plasma systems.
another key
The nano coatings are
aspect
super
of this,
important, but they're not efficient. I mean, I just want to mention that those nano coatings.
Yeah, so there's a few things you're bang on. The caustic is one of the most inefficient. A key thing also is when you take it out before you dry it, you have to connect it into the voltmeter and run it blank to get all the directions of the ions in that one way and neutralize it as it solidifies that final nano layering just reaction, because otherwise you're exponentially just on that small minute aspect. Even though you've nano coated it properly with the caustic, you still haven't then aligned all of that outer shell electrons into that same field, that same nano layered field, that then they're able to get that resonance or energy from. And that there's also through plasma flame, like a torch, and you take it to the metal and you get it you don't get it to the red hot or the black part, but you get it to the point where it's literally glimmering like a rainbow right before it turns hot red. And then you're not destroying the entire Ohm's law of the copper itself. So it still keeps the electrical flow in the solid of the inside of it, but on the outside, it's also then creating that nano layer. And then the third way is through the actual electrolysis process itself, that it will form on the cathode sides of the reactions and coat that way as well. Sorry, please.
I'll have to watch this video later too, and as a reference, go back through it, see exactly if I'm missing something. So what polarity on the electrodes, and what kind of power supply requirements?
So for those, I can't list it off the top of my head. I just participated in the most recent reactor group of the Keshi Foundation with Mr. Fix-It Rick on YouTube. So Rick's agreed with me that over the next couple of weeks, I'm going to go step by step all of their official ways of doing it, recording it, and then we can have a controlled test of these different systems and the nano layering, the plasma reactions, and all of that with the monoatomics from their specific blueprints and test it scientifically properly.
Yeah. There are definitely better nano coatings, and I can verify for you, if you wanted somebody to say thumbs up, the idea that nano coatings are critical for ZPF processes is right on. There are many, many great nano coatings, and if you really want to see, as you've been doing, how the best ones were made simply with common materials, just go back in time and take a look into what ancient chemists did. You'll find, if you analyze, or if you take a look at the analysis of some of the stones in the pyramid, you'll find extra materials that aren't common to stone, and they will lead you down a rabbit hole.
Bingo! The geopolymers, that nanotechnology of the megaliths and stuff, that ancient building, is the same monatomic or nanoplasma sort of alchemy that they were learning and doing. And what I'm showing right here, this was straight white monoatomic, mostly zinc, a little bit of copper, a little bit of silver, and it was a straight white layer about 2 inches deep on this. And then I disconnected it. It was all white when I brought it out. It froze right when I brought it out. It went to minus 25 Celsius. It was in Calgary. And all of a sudden, I'd never seen it before. The white monoatomic layer just instantly turned into these layers of straight crystals. And these crystals aren't ice crystals. They're these zinc silver oxide crystals that I've taken out. I'll show right now as well a live demo of it. But they literally oxidize into white powder from these crystals. And it's not like they melt like over a couple minutes. It's like they oxify into monoatomics over the period of like a day.
By the way, interesting note on the Himalayan salt. Here's a batch of that stuff. I've got, let me see if I can get the, yeah. So you can see there's just these rolling around white crystals that have kind of busted off. But it, what I was trying to do is separate out the salt from what was left over that wasn't salt. And
sure.
This
I know
did something really interesting. Okay, so this is the Himalayan.
Salt does not act like it's supposed to, right? Like it's actually these electromagnetic gravitational fields on how it crystallizes, as opposed to how we thought through old school sublimation or particulation of evaporation.
You know what I was thinking?
Okay, I've got this little packet here of aluminum foil, contains salt that I scraped off the outside of that beaker. It's a 250 milliliter beaker. And as I was evaporating out, normally when you want to crystallize out the salts and get yourself nice, large, continuous crystal structure, you'll slowly evaporate it over a very long period of time. So in this case, it took about a month. And I just left it uncapped in a place where there's almost no airflow. And what the salt ended up doing, because I had several salt batches, from everything from some weird freaking like scented salt that you're supposed to put in your tub, and it's got all kinds of herbs and stuff in it, whatever. I figured, I wonder if plants, if the process of putting those plants in salt will, help extract whatever was in them. So I let that go, and I did a bunch of different kinds of salts, but only the Himalayan pink salt did something strange. And what it did is it climbed up the sides of the flask, then it started climbing around the outside of the flask. After a while, it started forming hairs.
Kind of like this?
It was fuzzy, hairy. Oh, I mean, it was way crazier than that, dude. I'm talking fuzzy hairs that were at least 6 to 7 millimeters long, super fine.
I know what you're talking about. Like the different nanotubes and like different hair, like actual like hairs. It's almost like they're like amoebas or different like soft corals and stuff like that are forming out of these things. It's
now I can explain why, though, if you want to know why it did it. This is the really fascinating part that I think we should all pay attention to. Why did the Himalayan pink salt mixed with distilled water start to climb the side walls of the flask and then form these fuzzy little hairs. Well, there's only one real logical explanation for that, and we have to look to nature to find that logical explanation. And we can look to trees and roots. Take a look at the structure of why plants grow out and which way they grow. There's been some experiments done, very interesting ones, where an electric field in a fairly dim lit room is exposed above a plant, and we find that the plants, no matter what they are, seem to grow towards the electric field. In one example, a flyback transformer is continuously ran at very low power, 24 hours a day, 7 days a week, in a basement. Of some person's got this thing set up that they're just growing like tomato plants, they're growing like pepper plants, they're growing basic herbs and stuff. So they've got these electric field plates on the side, big aluminum plates, and they're charged with about 10 kV DC. They find all the plants curve towards these plates. And so they seem to follow the electric field. And if we think about the Earth circuit, so the ground is negatively charged to a high potential, and the sky is positively charged to a positive potential, and we have positive ions coming down from the upper atmosphere trying to find ground. Well, those positive ions have an amount of force, and they'd like to find ground much faster. So if something is sticking up out of the ground, before those positive ions touch whatever that thing is, say a plant filled with conductive water, they're going to exert a small amount of force on the structure of that plant, pulling it towards what direction the ion is coming from. So if it's above, they're going to pull that plant up towards the ion as it comes in. And over time, as the plant grows, this will create a structure telling the plant which direction to grow towards the sky. So if the pink Himalayan salt mixed with distilled water was growing these tendrils, what it indicates is that it had a charge. As it was evaporating, it was giving away some amount of its charge and generated its own electrical potential, which allowed it to try and reach out to find a ground point. And because the flask is borosilicate and insulating, it was just trying to reach out into the atmosphere to neutralize out the imbalance in the...
Oh my God, wow, you've nailed it. And it's like, it's explaining how this inanimate material is actually alive and growing because of that, like just the natural, like
it's just like any plant. It's just like everything else. You know,
you're putting
why you know, the electa of certain beetles have these tiny little hairs in the center. This
just
is
a natural feeler, right? Or it's like the little plasma balls of ball lightning feeling out before it connects down into the actual lightning strike, right? It's
exactly
just how nature operates.
Well, coming up from ground before you get the one coming down from the sky. Well, I shouldn't say before. I mean, no, you get, obviously you get the major discharge from top down, but I mean, before it ever hits the ground, yes, you have a upside down streamer shooting.
It's always the dipole.
Anybody that's on top of a mountain
right?
that has wind blowing across it up the plane, they will feel that electrostatic charge. I mean, there's some videos on YouTube, fascinating. If you haven't seen them, watch them. But people will stick their fingers into the air, and they've got their cell cameras or whatever nearby, and you'll just hear this hissing and whistling, and some people will even show a blue glow coming from their finger. There's an incredible amount of charge. Even a Russian project where these fellas took some, I think they were like 10-foot long insulators. They suspended a mesh like chicken wire with a 1-foot spacing, just steel cable in a stitched square pattern with 1 foot wide, spacing between each wire. Anyways, they were able to collect like a 5 to 7 foot long lightning bolt off that system almost once per second. With
really?
Valley, because of so much power. Just
okay, so take what you're talking about and now apply it to cathedrals and how they're always built as these dipole domes where there's one massive dome resonator up, and then there's always in the center of a park coming up from the ground another one of these like random domes with another light rod up, and it's a dipole system, and that these whatever they had underground was then connecting and using the storage and the harvesting of it, and they're literally taking atmospheric electrical energy and using it to power these ancient crazy devices.
It's a strange technology, and it doesn't work anything like what we have today. When you get charges flowing from the upper atmosphere, ions are going to have to neutralize. And in order to neutralize them, you have to have electrons flowing up from the Earth through those conductive materials. So as they're hitting the spires of these stone structures, they don't necessarily have to have conductors going back to ground because the stones are conductive. They're moist enough. But
well, and the way these megalithic buildings are built, Jeremiah, it's that it's like it's super advanced, ancient, like not micro, it's macro wave generators, and then these the crystalline blocks themselves, they're quartzite and granite and whatnot, and then they used to be covered in gold sheets in what was the one in Mexico? They're covered in that other material that keeps it in, and then the mercury inside and stuff. It's like that. These are just broken down or no longer understood ancient energy harvesting on a universal earth grid scale. That's why they're on these convergence points of these ley lines, and then what they're built off of and what they are. And what's really, really fascinating is lots of the stained glass windows. They're actually the same geometric shapes, identically as specific solfeggio, but also sound and the hydrogen atom as well, frequency in cymatics and in hydrogen wave geometry are these specific same stained glass windows that are essentially waveguide radio energy interacting technology.
The question you really need to ask yourself in terms of functional technologies is, what does the magnetic field naturally generated by electrons flowing up from the Earth towards the spires of these structures and neutralizing against the atmospheric downflow of positive ions do? How are they utilizing that, and what was its purpose? That's the question that is the most important one to ask, that I cannot say exactly, but think about it. I mean, what would you use a very large, structured, but weak magnetic field for? What kind of purpose could it have? How might waves, for example, traveling through the air in this charged atmosphere around that structure affect space around it?
And then you take in how these cathedrals are built and the different like quartzite, granite, stone columns between the resonating domes that are literally layered copper, silver, gold with mercury balls in the middle, and these giant antennas up and these iron connectors down, and we're still only starting to begin to understand the true magnetic current flow of energy through metals. And
Ever heard stories about these priests in some of these monastery structures? These buildings, exactly what we're talking about, from, you know, similar to the Tartarian Empire buildings, or some of them from. You've heard stories about these priests levitating, yeah?
100%.
Think about that magnetic field and what it might be doing. There is a quite bit of usefulness in understanding the structure of that field and how one can utilize it. And this I will say, it's not quite as much a spiritual aspect as people would think. There is a technological implementation here that matters a lot, and you are right on par with what you're doing, especially with the M-Gold stuff, but it's not the only element you need.
For sure. So right here, I got up now the actual hydrogen wave guide to photon. I believe these are actually like taken from either the Sapphire Project or some other accredited research institute. But it's like, if you look at the numbers of where these supposed hydrogen ions are in the 3 decimal dimensions, and then where the light is and the shapes of these energies that are supposedly the hydrogen atom turning from solid to wave, and you start understanding energy geometry transfer on a hyperdimensional electromagnetic gravitational form. It's something you gotta meditate on and look over many times, but it will connect you.
Indeed. Well, motion is the language of the universe, so it seems, and all of these things have motion up to the particles that we call protons and neutrons. So the motion of the constituent quarks, that's as far as we've gone down in our classical science, the subatomic scale, they're still in tremendous motion. And there's no way that we have today to measure what their actual velocity is through space-time relative to the outside environment, but I can guarantee you it is many times faster than c. So you have an integration between the polarization of those subatomic particles and their constituents and what they're doing to the ZPF around. And there's a point where the magnetic and the electric field meet and they become uniform and neutralized. And so you get a mass out of that. You get your constituent mass. Now, if you get close enough to these particles, the mass seems to disappear and you get these strange things called the strong and weak nuclear force. And they're a result of the phase imbalance between the motion of these particles through the ZPF, or through the vacuum, if you will, and where they actually neutralize out in the far field. So if you think about an antenna on the large structure, you have a near field. That's what happens right next to the antenna. And everything is real strange there. Antenna physicists will tell you that things in the near field don't work quite the same as they do everywhere else. Then you have this zone outside the near field called the Fresnel zone. And this is where the near field from the antenna travels through three-dimensional space and mixes with itself from different parts of the antenna, because the electrons, there are many electrons, and each one of them has
My phone's about to die, so just keep going. Give me a minute, and I'll be back in on my computer there. But I will feature you up there so you can keep going.
Sure. Hey, Mike. What's up, man?
Hey,
there, brother.
Question for you. You know those materials that you're working with? I would think that they would have an interesting effect making like an earth battery. If you had magnesium and copper and put it in a canister with that, those salts that you were talking about, and the charges that you're saying that you're getting with these materials.
Well, they're not my special materials. I just want to point out that this is generic, off the store shelf, pink Himalayan salt. And so anybody can buy this. Just mix it with distilled water, put it in a flask or a jar or a cup, and
because
heavy, and then just let it evaporate slowly over time in an area with no air, and see if you end up seeing these tendrils form. It's like, it requires nothing except for water and salt.
No, it would just be kind of interesting to see with the reaction if you were to put it like mix it in like a paste, and then put a magnesium rod in the center, and then have a copper container on the outside, so the magnesium would be your negative and your copper would be positive. You would probably get some voltage with those crystallization that you got in the salts. I think there would definitely be some kind of reaction there, and you would get some power out of it.
Yeah, there is power there, and we know for sure that there's a electric potential difference between that material and the outside atmosphere. So
so there you go.
Yeah, all we need to do is concentrate that thing, and remember the salt in its hydroxide form is going to be conductive. So we could effectively press that stuff into a rod, make our center rod out of salt itself, and because it's fairly low current, we don't really have to be limited to electrolytic voltages, especially if we use a catalyst dielectric between there. Say we use bismuth oxide or something like that.
Yeah, because there was one guy, I don't know if you're familiar with a guy, he goes by Laser Hacker, and he made these air batteries. So what he did was purchased a carbon graphite rod, all right? And what he would do is wrap one layer of paper towel around it, and then he would get magnesium strip and wrap it around in a spiral with about 1/8 of an inch space between the spirals, cover the entire graphite rod with it, and then at the top of the rod, he would drill a small hole and stick in a copper electrode. And he was getting 1.7 volts at, get this, 2 amps.
Damn. That I've got to see.
Yeah, it's on Laser Hacker. He goes Laser Saber or Laser Hacker. Check it out.
Yeah, what's the video called? Can you remember the name of it?
Magnesium air battery.
Ah, okay. I'll take a look at that again.
Yeah, he uses
I remember seeing that pop up in my YouTube list quite a while ago, but
yeah, he's did this a long time ago.
Thanks.
Yeah, it's pretty impressive. He did 2 of them. He was getting 1.75 volts at 2 amps, and the battery ran for over 2 years.
Damn.
And all he would do is mix up a salt solution, boil it, and then just lightly soak the rod and let it dry out. As it's drying out, the voltage increases.
Makes perfect sense.
So the other thing was he didn't actually do it, but he was also saying he studied Nathan Stubblefield, and he was making the Earth batteries. So he said you probably could take these batteries and put them in the ground with the proper moisture that's in the Earth, would sustain the battery power for quite a while. So
yeah, I think the big question that always comes up is, well, isn't this just an electrolytic chemical reaction?
Right.
And
with
that is a flat out and absolutely conclusive no. It is not an electrolytic reaction. It is a reaction to the stress energy density of that material interacting with the outside space.
So is it reacting with ether?
Everybody is caught up on Hutchinson's batteries, all these strange magnesium batteries. Everybody's stuck on this whole, it has to be a classical battery reaction. This has to be classic electrochemistry. There can't be anything else happening. And they negate the fact that these things exist in physical 3-dimensional space, and there are real effects that interact with the outside environment.
So would it be
in a closed box? And I'm trying to get physicists' minds outside this idea that everything has to be contained in parentheses.
Right. So would it be right to say that it's actually reacting with ether?
Yeah, I mean, the word ether is always one of those words that I personally love it. I love the word ether, but yeah, it would be correct to say it's interacting with the ZPF, or it's interacting with the already present radio electromagnetic energy and its various wavelengths. Whichever wavelengths are physically capable of interacting with the electrons in a significant way across band gaps within the atomic structure of these materials, you get an extra stress energy because you now get a jumping motion. They tend to and stick within a ratiometric distance from their constituent charged particles. So charged particles like to jump a certain distance from each other at a certain velocity. And when they jump gaps, they produce a huge amount of very strong...
Yeah, the dielectric, yeah.
And that changes the properties of space. When that happens, it physically changes the properties of space around it, making the permittivity and the permeability much easier for electromagnetic energy to go into that space and saturate it. And it's not a linear curve, it's hyperbolic. This was the Don Smith thing, where you get more and more energy into space, and you get to a point, just like an iron core. Think about an iron core, for example. You begin to saturate it with a magnetic field. It starts to get to a point where your curve, your curve is nice and flat at first, and then you start to get to a saturation point. All of a sudden, shoots right up.
Right.
Why does it do that? So it's a very interesting phenomena, but space-time acts very much in the same way. There's a point at which it actually breaks down and it can't take anymore, and we call that the Springer limit, where partial charges will pop out of the battery. Real.
Yeah, I think you can only saturate, say, like a metal surface so much before it has to go that way, out. So he was talking, actually, Dollard. Go ahead.
Oh, sorry, go ahead.
Dollard was talking about when he was studying the physics with the hydro lines. And, you got 2 lines side by side separated by the ether, which is actually, I wouldn't call it ether. There is something there, but we call it space. But the power lines, the power actually travels on the outside of the wire. It's not flowing inside the wire. So as it's creating the magnetic field around the wire, it's actually jumping from one wire to the other. It's merging in the middle of the ether. So what will happen in some cases, if you have enough potential going through those wires, the insulators cannot contain that electromagnetic field, and that's when you get a runoff. It has to go somewhere, and it's going to go out. And that's why you have like transformers blowing up, because before Steinmetz and all his math to control the transients inside a transformer, they were getting transient spikes of power in the transformers and causing them to simultaneously explode for unapparent reason, and people were getting killed as a result. So Steinmetz kind of worked out that mathematics to figure out and control the transient flux that's inside a core or inside a wire, and control it.
Yeah.
So it gets pretty technical.
Geometrically amplified field from a charge in motion is completely negated within the classic Maxwellian equations. And that's the big problem, is that there's this factor, a fudge factor, if you want to call it that. We call it the gauge. And it's always zero within those equations. Then you get into differential equations. Now, I'm not a mathematician. I'm not a math guy at all, in fact. But I do know enough experts in math that have told me they hate differential equations because you change one little thing anywhere and you've got to recalculate everything. So there
right. Changes all the variables.
Comparisons between one system and the other, and they're terrible on paper because they don't work out real nicely and fit into boxes and parentheses like, modern day humans like to, classically simplify and generalize everything. But the way the universe works, it does not speak in these nice little square boxes and parentheses. Everything ratios, and it's all relative. So when we change one thing, when we change the velocity of a particle that has a charge, we change the properties of that charge. We change its vector direction. We change the electric potential that shows up in the outside field around that charge. And this is totally negated. But if we include it and we stop saying that the gauge factor is zero, that there is real variability in the polarization of the vacuum, we have totally different and brand new properties of the vacuum that we can use in very useful ways for energy, for propulsion.
Yeah.
And it's like nobody's talking about it. It just blows me away. Why are we all screwing around trying to, we're screwing with NMR and geez, you name it, trying to pretend that just electric charges and ions are responsible for everything. It's all ion wind and it's all airflow and it's all classic Lorentz transform, and nobody is considering the variability of the velocity c through space because of the permittivity and permeability change due to the acceleration of a charged particle. This is I know it's a string of words, but if you think about it, it's a really simple thing. And to say it simply, all I got to do is move a charged particle this way or that way or this way or that way by exerting some kind of external electric field, and this charged particle emits a field of its own. And that freaking means something. Why are we not considering what this does to space? Space has to contain that. The energy has to be equal everywhere. Think about it this way. Energy in this volume and this volume, they always have to be equal. So if we're comparing any reference, they're considered equal. But if we put a bunch of energy into this volume that we don't put into this volume, if we consider what this volume sees, it's going to now see that there's so much more energy here. It's going to try to fill that void. There's a different potential. So if a charged particle is, say, placed between these two, if you expand this space, and this is a negative potential, say you're moving electrons in this space, this electron is going to try to entrain into this field where there's electric potential, and it's going to create a consequent motion. So we can physically expand space in a way that has realistic implications.
Yeah, see, I think that's where Einstein went wrong with his theory of relativity, the action at a distance, right? He didn't want to, in the beginning, he didn't really recognize the ether in its existence, but towards the end of his career, he was starting to realize that there is something to this ether. And he started to recognize that. That was the later part in his life. But ether is definitely something that has been totally overlooked for so long by so many, engineers and scientists and physicists. The list goes on and on. So until we actually understand what the ether is and its relationship with electricity, charged particles, whatever, but ether is not empty. It's actually full of energy. We just are unable to understand the properties of how ether works and how it functions. But people are working on it. So, there is progress being made on that.
Indeed, indeed. it's a darn good discussion.
What are we looking at, Bernie?
Hello. So we got joining Austin with us, and Austin is from the Metamartian NFT Metaverse project, and we're going to discuss Cydonia and some of the pyramids on Mars and the face of Mars. But also, before I delve into that, a major part of what Austin wants to do with his Martian Arts Metaverse project with these NFTs, this crypto multiverse, is actually engage the real anti-gravity, the real aliens, the real investigators and disclosure and research and community. And we've already talked in private on how you've also connected with Nassim Haramein and his arc crystals and the Resonance Academy and all of that and all sorts of stuff. So I will shut up and let you take it away.
Nice. Yeah. How's it going, Mike?
Good. Very good. How are you?
Good. Good to meet you. JP, good to meet you too.
Jeremiah,
Yeah,
there, brother?
likewise. Thanks, man. I can't wait to hear what you got to say.
Yeah, we made this project called Mixed Martial Arts Club. I mean, the Nassim Haramein experience that I had, it was actually a friend of mine had a cacao ceremony, which he was invited to also. And he had come, and so we drank cacao. And if you don't know what cacao is, it's I don't even know how to really properly explain it, because until that moment, I didn't even really know what cacao was, other than it was like this healthy chocolate. So it's really like it's this hot drink made from like just a bunch of plants from the Amazon, and it's to open up your heart. And so there were these singers and performers, and we listened to them sing and perform while we drank cacao, and it was like this incredible experience. So afterwards, Nassim came up. He talked about a whole lot of different really interesting things, but one of the things that he had talked about was he talked a lot about black holes. He talked a lot about like also just the control that they have over gravity, how they've been able to discover how to basically control and manipulate and do whatever they want with gravity using their technology. And I had never heard of that before. And so I thought that was really interesting. And it wasn't until I was talking to Bernie today, and he told me about the same thing that I had talked about, and with Nassim, and I hadn't heard anyone else bring it up before. So I was like, man, that's super cool. We got to like get in on these conversations. Like, it's super dope. But what I'm building with Mixed Martial Arts Club, it's called MMAC. That's what if I say MMAC, that's what I'm talking about. We're building a lot of new technology that uses NFTs, augmented reality, and in a whole lot of ways that haven't been done before. And we're using gamified processes. So people are playing games using NFTs to be able to earn money in crypto while just having a fun experience. And by having a lot of very creative partnerships.
I'm just going to pause you and interject there, Austin, just to give people examples of how these video games earn money playing. It's like, so your NFT character, like that's like your superhero that is you, that you design. And then as you're playing these games, you know, you get that sword or that chest of gold or whatnot. So it's these additions of these multi-layered smart contracts that is included into this metaverse, that is then you're building these actual assets of video, like experience and exclusivity and whatnot, but in these metaverses that then are connected to this just one original NFT. So it's not just some 32-bit pixelized like going to be worth nothing in no time trash. You've actually got something that is evolving and multi-layering asset development within this structured digital art.
If I may, I have
NFT metaverse.
a question about this whole NFT metaverse that I'm not really that familiar with. I'll be honest, I spend most of my time in the lab playing with advanced materials and doing my research. But what I would like to know is, let's say that we take the opportunity for game playing and money earning, which is a beautiful idea for people that have way too much time on their hands and need something to keep their hands and their minds busy, and instead convert this into rewards for self-educating, where as you learn more about physics, as you learn more about mathematics, as you learn more about how to actually do things that are useful, functional, and valuable to society, you get rewarded for that. I really haven't seen any program like that in the anywhere in the cryptoverse, but it would be a really wonderful thing to start rewarding people, especially young people that want to get into this new idea of cryptocurrencies and get something out of it that's tangible, and in the meantime gain a skill that's going to serve them later in life and bring great value to society.
Yeah, definitely. So the game that we're building, there's two different ones that we're building. The first game we're building right now is a lower budget cost game. It's low mid-tier development, like as far as overhead. It's going to be like there's a game called Jetpack Joyride. So it's an arcade game. If you've ever played Jetpack Joyride.
Yeah, I quite liked it. It's a fun game.
Yeah. So the first game we're going to build is that Jetpack Joyride. So you have your Martian, it's in a UFO, and you're flying across a map, and you're escaping Mars while humans are invading Mars. Now, the whole storyline behind Mixed Martial Arts Club and the whole Metamars, all of that is humans have wrecked Earth. They're coming to Mars for terraforming and finding a new planet to live on. They get to Mars, start terraforming, dropping bombs on the planet, and Martians are like, "Oh crap, we're being attacked." So they're like, "Stop!" And when they're trying to stop the humans are like, "Oh, we're being attacked by Martians. Let's fight them even harder." And that's not what the Martians wanted. So it creates this massive conflict. Fast forward, they find resolution too late, right? Martians have to throw themselves into capsules, and then later, and then fast forward even further in time, they come into capsules, and they have to rebuild their planet Mars. And so the game Metamars, which is the one that takes place on this timeline, we are the Martians going out on Mars, and we're rebuilding the planet of Mars to create societies. And so it's like, how do you learn? You have to learn through all the mistakes happened in the past to know how to start a new planet, to know how to not make the mistakes of what happened in the past. So it's got the aspect of Pokemon Go, where you go into the world, accomplish tasks, do little quests, whatever. Those digital assets you collect, you can take those, build, and then you're on your phone, like Clash of Clans, and you're building a city, and then you can battle with other cities. As you win battles with other cities, you earn money as well. Now, if you go digital assets in the world, you can sell those digital assets to people who want to build the cities if you just have more fun going out there. But if you come in with money and you want to make more money, then you can just buy and build and battle. And it creates no barrier of entry. Anyone can get in. You don't have to have money to play the game. You don't have to have an NFT to play the game. But as you come in with more money, you have the opportunity to earn more money.
I can't say I like the theme of the game, but I can say I like the idea that people will be able to get into the crypto market in a way that's going to be fun and enjoyable for them.
And get them outside.
Yeah. I'd very much like to see something that has more of a applicable purpose.
Yeah.
And I think a huge amount of potential in terms of self-fulfillment in that. when somebody does something that they get rewarded for online or in the digital world, and then they can take that thing and they also get rewarded for it in the real world, it creates a unity and a structure in the human mind where these ideas are no longer just fictional concepts of a fantasy, but they become very tangible concepts of a possible future that we've never seen or thought of. And I just wish more people would focus on the integration of the two. And you seem like you're in the perfect position to do exactly that. And you've got the right mindset and have the team to do something like that. So I know that you're well on your way with this project and wouldn't want to change anything on it. But in the future, I mean, I would beg you to consider trying the possibility of implementing an educational program that rewards people for learning.
Mm-hmm. Yeah. Actually,
just have exercise, right? That's a huge part that you're saying. It's like the adapting how Pokemon, whatever it was so successful in actually having people outside exercising, whatnot, and taking that into one part of it. And you can use that in, and then it's like another part is like, it's like to maybe get these artifacts of like these other NFTs of like what you're talking about, that Nassim has those replicas for you, but like to earn those, it's like you'd have to do like maybe some of Nassim's like delegate classes, or like do like an APEC freaking educational, you know, where you're learning, adding these video hours of content or something that then also is including education into NFTs down the road. But more in the mean term, it's interesting of building and archiving Cydonia and it into the metaverse of Mars. Did you get a chance to look at Cydonia at all, Austin, of some of the links I sent you?
I have not had the chance to get through the links. I actually just got home, but I have looked up Cydonia. Yeah. And I'm picking up a dog tomorrow. So.
Nice.
Exciting. Yeah. Part of what we've been up to. But
yeah, I'll let you talk here. I think Mike and Jeremiah are still there. They're just like having a
that's correct. Mike's on, but
I'm here.
Hands off.
Yeah, so I'll let you talk. I'm just gonna go take a few minutes, but I'm gonna load up a Cydonia video here, so it'll be ready in about 5 or 10. That is it's a official news TV from 1990s when it was NASA's official disclosure of the face of Mars and then the surrounding pyramid complex that is around that face of Mars, and how nobody's heard of it yet. It's literally a new by NASA to the United States, but you guys will see it. So anyway, I'll shut up, let you talk.
Yeah, proceed, Austin, please.
Yeah, absolutely. So with the ultimate, so when we first started getting into this, the crypto market right now, one of the biggest issues with it is that there's a lot of people taking advantage of excited new users. And so the vow I made with a couple of my partners was that we were not going to build something that, that we couldn't build and have everyone who participates in it win. Like, we wanted to make sure that, like, if we're going to do something that, like, if someone was to, spend money buying one of our NFTs or any of our NFTs or tokens, there would be an equivalent amount of value provided to that person or more, would be far exceeding, what they invest into our project. And so a big part of accomplishing that is through educational platforms. And so one of the biggest things that that I find that if you want to educate people nowadays, you're not going to do it through marketing education. For the most part, for the masses, if you want to help them, it's kind of like what Steve Jobs said. It's like most people cannot connect the dots looking forward. So if you have someone play a game, accomplish tasks, read and do things, then look backwards, connecting the dots, they can understand how they got there. They can make more sense of it.
Absolutely.
So I'm not trying to get people to look forward and try to connect the dots, because most people, you know, they don't want to go, and they don't want personal growth. They don't want to read on things. They don't want to do things most of the time because it challenges their current belief systems.
Exactly.
Yeah. And so,
the amount
or
of
what society or whatever is telling them to
mathematicians who
do.
are stuck on linear systems and refuse to accept the variable space-time is just ridiculous.
Totally. And typically it comes down to experiences, right? Like, you trust your experiences more than you trust words on paper or words spoken to you.
Right? And one hopes that that is common sense, but until some people, they're stuck in the zombie or the cog of the machine or the ant farm, and they don't actually ever get that original experience, so that they're like literally just stuck in that matrix where their paradigm can't understand that, oh, this experience that everybody's talking about, it's not a conspiracy, it's actually real, because they've never actually lived a real experience in their entire lives.
Totally. Totally. 1,000,000%. Yeah. There's it's interesting trying to think about, like, when you don't, I think what's like challenging is the concept, you know, building this project, helping people sounds so easy in theory, but in like practice and actually, like, you know, building things and doing things to help people, you realize most people don't want to be helped. Like, they want help, but they don't want to, you know, they like the idea of help.
Right. Well, everybody wants the extra opportunity to receive help, but they all want to do it their own way. And nobody wants to really accept the possibility of a different model to consider. That's the big trouble, is that they'll take your advice and run with it as long as it fits into their worldview. But if you try to step them outside of that worldview, the opposition is tremendous.
Mm-hmm. Yeah, exactly. And so, like, part of it is like helping them think that, like, well, because a lot of the time too, like when you're trying to help somebody, they have a story in their mind with the way that help will be given to them. Like, there was someone I talked to today, and they were like, I was like, you need advice? Well, I'll connect you with this person. Like, I pay them already. They will help you with this. Then they're like, no. Like, I imagined it coming from this kind of a person. I was like, this person is qualified, more than qualified. So it's like, you know, it's like, it's just funny because it's like, no, like, they got to be this, they got to meet these like criterias of like what I want. It's like, so it's just interesting, you know, to think about all the little limiting beliefs that like cause people to hold back. And so it's funny because, you know, the interesting thing about it is like getting to a point that you just get people to go about things and you know, feel like, oh, I came up with this idea, when really it was like walked through. But it's really interesting. But like, my ultimate goal is to want to help people, but I just realized, like, too, like, most people, like, you know, they'll do something because they're scared they're going to miss out on an opportunity of something else. And like,
I hear what you're saying. People are fear motivated far more strongly than they are reward motivated.
Especially if it's like they'll chase things that satisfy fear than they will for something that they know provides a delayed gratification.
Well, that's your type 1 personality. You know, if you think that there's a tiger in the grass and there's not, you're still okay. But if you think that rustle in the grass means that there is nothing there, it's just the wind, and you're wrong, you don't survive. So, right, it makes basic sense that we would be motivated more by fear than the possibility of being right. However, it seems that some get lost along that path.
Well, I think it's
funny human experience.
Well, you'll especially not be able to tell the difference if you don't get out for enough walks, right? Like,
yeah, and these last 2 years for people have not been exactly the easiest times in order to get out. And I mean, in some cases in the U.S. and Canada, at least, you guys have been fairly free to move around. Canada's had restrictions as far as curfews, but Australia, sorry for them out there, literally being arrested for curfews. I mean, come on, it's ridiculous. So
are you in Canada?
What's that?
Are you in Canada?
It's
No,
absolutely
I'm
insane.
US. Bernie's in Canada.
Yeah, I'm in Canada. Austin's in Texas. Mike's in Canada. He's in Toronto. Yeah, we're not on the Australian channel tonight. That will be upcoming in a few days. But we are also going to edit lots of parts of this that we can then turn into some short videos and then put into like the mass stream, also put onto Josh's channel and whatnot. And
yeah, that's a good idea.
On multiple channels.
Been said today and revealed today that probably should be recorded somewhere, documented somewhere.
Absolutely. Yeah, we're still live on my YouTube right now, on one of my Facebooks and on my Twitter. From we're going 8 hours and 45 minutes straight.
Yeah, man.
24 hours.
Right.
Jim would be falling asleep by now, man. He probably already is.
I'm yawning.
No, not
I hear you.
The 24-hour streams will come, but not tonight. I got to pick up the wife here in about half hour from work, or maybe an hour. But what I'm going to play right now, for if you guys have never seen this before, prepare to have your minds blown. It's a 5 or 6 minute video clip.
I'm sure I haven't seen it. So here we go.
First news one. And then there's a second one that I can also play after to end it. That's about 10 minutes. And it's Richard Hoagland and Zachariah Stitchin joint production of Cydonia Pyramids in the Face. So, and it's like this right here. This is the sort of stuff that we can literally turn metaverse into multiverse, into learning, into, you know, disclosure for all. Taking it to a whole new level. So if you weren't around before, this is one of the original NASA satellite images taken in a snapshot. And what you have to realize is that the sun, to cast these shadows from the angle for it to be a face like that, it's like capturing the Sphinx with a satellite from on Earth. And then that literally, well, I'll just let you guys see how that speaks.
And a sculpted mesa. They have a haunting quality, a face, a cluster of complex formations. Is this proof of an ancient civilization on Mars? Is the government hiding what it knows about the area known as Cydonia? For years, independent scientists have furiously battled NASA over these images, photographed by the Voyager mission 22 years ago. And now, new images of Cydonia from the Mars Global Surveyor bring excitement, disappointment, and even more controversy.
This is architecture. It's over. This is architecture.
Richard Hoagland and other independent scientists say this complex of objects contains artificial shapes, too organized in their placement to be natural formations, that they are possibly ruins of an ancient civilization. These images offer tantalizing suggestions. On the left, an aerial photograph of the Great Pyramids of Giza in Egypt. On the right, one of the formations in Cydonia.
You can actually see that if you draw the lines between here and the crossings,
Oh, yeah.
that you're looking at a pyramid.
NASA has steadfastly ridiculed the idea.
They're perfectly natural. I mean, these are just ridges and valleys, gullies.
The Space Act demands in law that NASA publish results freely from various missions.
Hoagland, perhaps NASA's loudest critic, says the agency has been far from free with its data and believes it is hiding information from the public and independent researchers. But why? The answer may be in a report done by the Brookings Institution some 30 years ago, a report with an ominous warning.
What Brookings said was that the most disturbed elements of society, if we ever encountered evidence of extraterrestrials in terms of ruins or something like that, would be the scientific community itself, because they have the most rigid views of reality.
It's the scientists that can't handle it.
Exactly.
Cydonia has clearly been of great interest to the public and to independent researchers for years. But when NASA scientists sent the global surveyor to scan the surface of Mars, they had no intention of imaging Cydonia. That infuriated Hoagland and other researchers. Then an unforeseen adjustment in a solar panel changed surveyor's orbit, and new high-resolution pictures of Cydonia became a possibility. The first one a bitter disappointment that only added to the angry questions about NASA and how they dispense their data.
I would bet dollars to Navy beans this image is crap compared to the real one.
Hoagland says the first new image of the face is, well, lousy, and that the problem is not the camera.
Where did the light streaking come from? That's the first question. It's just lousy data. Which, in contrast to the other pictures he's taken of other parts of Mars, which are really astonishing, is weird. That's disturbing.
Why the difference in quality? Hoagland says the image has been tampered with, so we can't see detail very well.
Technically looking at this, all that's been done is to throw most of the imaging data away and then enhance what's left to produce a very noisy image.
What we had to do was to go in and spread the contrast in an intermediate level so as to get this out of that.
At JPL, surveyor project scientist Dr. Arden Albee explains it in a little bit different way, but it sounds sort of similar.
And all this is going to a different exposure, if you will.
Right.
Throwing away all the dark part and lightening it up and to get this contrast out of it.
Hoagland put NASA's first new image of the face through a computer histogram program, which shows how much information is in the picture and how it is distributed. He finds that more than 60% of the data is missing. 60% of the shades of gray have been removed from the image.
The normal home PC is demonstrating what are called 256 shades of gray, from lightest to darkest.
Right.
It's 98 shades of gray.
And there are supposed to be how many?
256.
Did you have to discard information or shades of gray or anything?
No.
Because some of these folks are saying that.
So what? I mean, they can say anything they want, right?
In spite of the poor quality, Hoagland says rectified versions of the first image show a massive tetrahedron to the south of the face. It contains uniform ridges.
You can see that each of these little guys is the same width. And it's an absolutely straight line, and each one is bing, 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 bing.
From the third new image, Hoagland sees a five-sided pyramid containing a honeycomb pattern.
Then if we go down to the bottom where I've actually done a blow-up, you'll see that this structure actually has the partitions of walls and rooms without roofs. This way and this way at right angles.
Yes, you can see that.
That's all you need to see. Nature does not do this. It certainly doesn't do it in 3D.
Hoagland says these patterns in the southern part of what's known as the city are remarkable.
These are individual, again, room size, house size cavities with partitions between. And see these lines, these little white lines?
Yes.
Then look at right angles. You have linear patterns of the lines.
Linear patterns that Hoagland says do not appear in nature.
See the shadows? These are 3D structures.
It looks really honeycombish to me.
Exactly.
What else does sophisticated enhancing of the new images show? Uniform lines in an area they now call the Gila Monster. Perfectly round formations. The sun glinting off what may be geometric patterns. And an object that Hoagland says resembles a castle.
Look at the windows. Look at the regular windows. Look at the portals. Look at the straight lines. Look at the lattice work, the indentations, all stunning, regular architectural geometry of an object that's sitting on the buttress of the Giza-size pyramid in the city of Cydonia on Mars.
Of course, you can judge for yourself. NASA released the Cydonia images without comment, but this.
Sorry, that one was actually kind of shitty. But why that guy matters? He was actually the official NASA to CNN reporter, and the video I thought I was playing was the advertisement or the briefing where they did to the United Nations. But we'll do that one next one. It's much better.
Nice.
But let you guys discuss while I figure that out.
I'd actually never seen that video before. That's really interesting. I mean, it's crazy to think back in the 80s how good the photos must be now.
Right, exactly. And that there's updated ones like that he actually has done in the 2000s where he shows that NASA has intentionally degraded and like blurred out that area, never taken a higher resolution or higher definition picture of that same face that they claim is not real. They've never taken from the same angle, even though they've had like hundreds of satellites supposedly with way better equipment going over Mars constantly since that picture was taken in the 80s or 90s, right? And then it's like that they've never gone back and tried to take another image from that angle again to see if it's a real face. It's like they've intentionally avoided it, and then they landed one of the freaking rovers in this area. And if you see some of the YouTube channels that go through the actual Mars rover footage, it's like it looks like nuclear wasteland everywhere.
Wow.
And then these pictures that I'm putting up, this is the Badland Guardian. So this right here, that's a road to an oil pump derrick. And this is in the Medicine Hat, Alberta Badlands, that these several faces from satellite. And how this is like, for instance, these are different satellite from different angles at different times of the year. Yet you can still see it's there. It's real. And then the Farham Institute, this guy goes in depth. He measures megalithic lines and angles at all these ancient sites and then actually connects them to all the other crazy ancient sites. And the spot that is right by me in Alberta, Canada, Medicine Hat here, that nobody's ever seen, yet it's on par with you know, the Nazca lines and whatnot. Like you got 3-4 faces there. It's terraformed entire hill systems, and that he actually maps this out on a globe. And in these rock structures in Alberta, it's literally gives you the exact mathematics left over in giant stones that will place you in Cairo, Egypt, or in Bosnian pyramids, or the Yanaguni pyramid that's under 400 feet of water, or all these other crazy ancient sites. And it's just, it's nuts what, you know, we've been missing. And just to have this in context, and then what you'll see at the end of the video, the last video we'll play, that is the Martian face, and then where it zooms out and there's literally 30 pyramids surrounded right next to this face in this area called Cydonia. And you think, you know, that like they'd teach this in school, that hey, that face in Mars we discovered in the 90s actually has 30 pyramids built right around it, and maybe we should investigate it or something.
So that is actually from the surface of Mars, for sure. That picture.
100%. Oh, the second video will go way more in depth. It'll be the actual UN picture or UN presentation, and every single picture he's using from the official NASA satellite photos, because at this point he was the go-between between NASA and CNN and Walter Cronkite, I believe it was.
This I gotta see.
Guys, I gotta head out for the night. I'm falling asleep here.
10-4. Thanks for stopping by.
All right, guys.
Yeah, I'm not much of a late night person. but I'm pushing it.
I'll stick around to watch this at least, this last video.
Yeah,
okay,
I'm
take care, guys.
This.
All right, man, lay it on.
I love that artwork.
Wonder if that's his original stuff there. Probably.
Do you think Bert made that?
Oh, he does quite a bit of art.
Hmm.
Don't know where he finds the time for it.
We're looking for artists. But artists have to be able to draw in 8-bit.
Yeah, I guess that is his. Showing it right.
That's bad.
Pretty good. It's pretty dang good. I could easily see that being an NFT.
Yep. Yep. Yeah, I want to get like we've got some pretty solid community. That's cool. That's really cool. We have some good, really good community. So I want to start getting like more alien talks. Have like a call a week.
Thank you for this last video, Bernie, and then let's head on out.
But yeah, I want to get on Twitter Spaces and whatnot, and just start like having more conversations, diving more into like what's going on with aliens, where we at, like.
I'm on the right computer here. Sorry.
There you go. Yeah, I want to see where this evidence is really presented and backed up. I'm pretty interested in that because I mean those are damning images if they are from the surface of Mars. I've never seen them. I mean, honestly, I probably should be more familiar with what's going on there, but I just haven't had the time.
Human race is not alone, that there is someone else out there. The problem is when you begin to present specific information or specific. There, staring back at him, was this strange visage. Now, the normal response, which was his and many, many others, was immediately, well, it's an interesting little trick of lighting. Let's move on. That was the normal response. However, when you apply a modicum of computer image processing, which NASA at that time did not do, planetary science community touched not this subject, that fell to two gentlemen named Pietro Molinar, who were imaging experts at the Goddard Space Flight Center, working under a subcontract to Lockheed to work on Landsat imagery. When those two gentlemen did the image work with the original digital data tapes, this is what they saw. This funny kind of blobby thing turned out to have rather interesting beginning symmetry and proportion. Now, subsequent work, which has been part of the efforts that I have been privileged to lead at places like SRI and the University of California, Berkeley, and the Analytical Sciences Corporation in Reading, Mass, and others, has resulted in further improvements on the data. Now you begin to see that this guy not only has symmetry, but there are details, such as teeth in the mouth, the suggestions of true symmetry, bilateral symmetry, which of course facial constructs, natural wind-eroded mountains here on Earth like the Great Stone Face in New Hampshire, simply do not have. They are profiles, and this object is a frontal view. Well, the big question, of course, in everyone's mind who brushed up against this in the late 70s, early 80s, when Pietro and Molinar were doing their work and being resoundingly ignored by certain people in the planetary science community, was, is there any other data? If we only had this shot, no matter what the tricks of algorithms could do to bring out what was there, you would literally never know and never be able to resolve the question, and I probably would not be standing here this afternoon. Fortunately, DiPietro and Molinar did what any good science should do in this situation. They went looking for corroborating data. They scanned through the entire Viking database, tens of thousands of frames, and found that, in fact, contrary to Jerry Soffin's statement that there was no image of a face when Viking re-imaged this area a few hours later, that the thing had gone away, they found that there existed a frame taken not a few hours later, but 35 days later on not orbit 35, but orbit number 70. And that photo, when you blow up to the same scale, the face at a higher sun angle, some 20 degrees higher, this is what you see. This is now the high sun angle view, and the right-hand side, which had been missing in shadow, turns out to be there, albeit it's a little worse for wear. There is one rather interesting asymmetry, but in fact, there are two eye sockets, the mouth goes through, and the so-called hairline goes around. Well, this was data that one could actually begin to do something with. For instance, this bench, to use a geological term, matches this bench in terms of a central symmetry axis. It is exactly as far away as this edge from the natural symmetry axis of the object itself. That was the beginning of the suspicion that maybe, just maybe, this was not just your average run-of-the-mill trick of light and shadow. This now is a computer-enhanced high sun angle frame done with a very subtle algorithm by Dr. Mark Carlotto at Analytic Sciences in Reading, which I believe also was part of his paper that he eventually published on the subject in the May issue of 88 Journal of Applied Optics. And what you see here very clearly is that whatever this object is, it is much more intriguing than a trick of lighting. It has symmetry, it has proportion, and it looks eerily suggestive. That is where the case lay until about 83, when DiPietro and Molinar chanced, through some machinations that are described in my book, so I won't go into them now, to give me a set of their pictures, their prints. One of the things that they had not done was to ask what I thought was a very important anthropological question, which is simply, if this was real, who in the world would have done it and why? So what we did was to set up a series of investigations, beginning with the independent Mars investigation team and moving on to the others. And we brought in what I felt needed to be brought in to solve that kind of problem. Namely, if it's real, if somebody did this, then there was a purpose, there was a goal, and an appropriately crafted investigation, including experts in a range of disciplines, might be able to approach serious, rational solutions to those questions. Namely, is it real, and what was its purpose? And one of the experts that we brought in, named Jim Shannon, who was a background in anthropology and art, did this analysis, which is a basic analysis of the object lying on this mesa, a mile long, and we now know 1,500 feet high. And he found some remarkable symmetries and proportions and elegances in terms of its placement that, to his qualitative trained eye, he felt were pushing chance that this in fact was not chance, that maybe in fact there was intention. This now is a more sophisticated kind of analysis. This is the three-dimensional wireform diagrams of Dr. Mark Carlotto's three-dimensional analysis, namely a shape from shading technique, which is single photo stereo. It's called photoplanimetry in some circles, and it has allowed us to recreate in 3 dimensions this structure. This is raw data from Viking, low sun angle, 10-degree sun, this photo, high sun angle, 30-degree sun, this photo, and the matching computer reconstruct lit in the computer at the same lighting based on the 3-dimensional reconstruction of the underlying topography. And what's interesting to note is that even subtle features, although the resolution is degraded because of the transform steps somewhat, even subtle features of the original data are reproduced in the reconstruction, giving one confidence that in fact we do have a handle now on the 3-dimensional underlying topography. Mark also was able to project the low sun angle frame onto its wire form diagram and then rotate in the computer the result so that we can, in essence, fly around in a helicopter, although you can't have a helicopter on Mars, this object at a reasonable altitude to try to gain a view in terms of its perspective from multiple azimuth directions. And it demonstrates one important thing, and that is that not only is the object bilaterally symmetric in 2 dimensions, but also in 3. Look at the so-called chin. Look at where it peaks and where the flat part of the headdress or whatever it is and the eyebrow ridge peak right down the axis symmetry. So we're dealing with a symmetry not just in 2 dimensions, but in 3. Now, these are all analysis that were brought to this data not inside the planetary science community, but outside. And I must say at some cost and sacrifice by investigators who were not funded and did this on their own time and after hours, and it seems to be continuing, midnight. Point is that the problem was non-trivial. The stakes, if we in fact have stumbled across extraterrestrial artifacts right next door, accessible to our technology, accessible to men and women going there someday, those implications are off scale. The amount of resources applied to this problem have been absolutely minuscule, almost non-existent by any normal science standard today. There is a disparity there, and it is a disparity which hopefully is now in the process of being corrected, not the least of which will happen when those new images come in, and those of us who need to see the hieroglyphs, if such things exist, will see some pretty stunning things if the model is confirmed. This is the context of what we're talking about. This is the Cydonia region. Now, there have been efforts to dismiss the whole idea of looking seriously at the data simply because in this northern desert region you can see a lot of terrain that looks kind of similar and knobby. And in fact, Carl Sagan has said, well, what are the chances that one random little mesa on Mars might suggestively look like a humanoid face out of tens of thousands of similar mesas, et cetera, et cetera, et cetera? That is the key question in my mind when I got involved in '83, because as part of that anthropological reasoning, it seemed to me that if this was real, if someone had done this, then there might be other things nearby that would be discoverable on the same Viking frames. And it was with that idea in mind that I began to look in the immediate vicinity of this space. This is now a processed shot in the computer, orthographically rectified by us as part of our subsequent work. And here's the face. If it does have an axis of symmetry, then at right angles to it, I reason one might find something interesting if one of the purposes of this construct, if it was a construct, was to be viewed not from space or from high altitude, but perhaps from the ground. So I hypothetically put myself on the surface and I looked here and I looked here, and I noticed immediately that there were an interesting series of other rather important and unique morphologies, forms, that were located in just about the right position to get a very nice view of this thing as a profile. Well, that was essentially the breakthrough that led in subsequent years to a series of discoveries and mathematical confirmations that have taken us now almost light years beyond the initial naive questions, is it real or is it Memorex? This is a set of maps, set of relationships that I discovered that connect this set of objects, which we term the city or the collection of pyramids, with the face, with another object over on the ejecta blanket of this ancient crater, with a rather interesting circular formation we call the tholus, and then with this structure, which is perhaps the most interesting single object, the face notwithstanding, that we have found. A five-sided pyramidal structure that we call the D&M, because it was actually Di Pietro Molinar who found it on the second set of frames taken in Cydonia, and we thought that they should be remembered for having done that important beyond the envelope kind of looking, which in fact has brought us to where we are now. Okay, these are the objects labeled. This is the set of maps. And what I'm going to do is to take each of these objects in turn and describe to you why it's interesting and how we now think it relates to the overall context of the complex. This is the so-called pyramidal complex. This is the so-called city. One of the things I noticed was that in the center, and it turned out to be the exact lateral center defined by this edge and by this edge, all right, there was a collection of 4 little guys located exactly at 90 degrees to the axis of symmetry of the so-called face. They too were orthogonally, that is at right angles, arrayed. If we look in close-up, we can see them here. This is some of DiPietro Molinar's best processing. There's a 5th one located in the center. Now, some geologists would look at that and say, you're looking at an eroded crater. The problem is there are problems with that analysis. For instance, crater slumping gives you radial structures, not structures that are arrayed at right angles and arrayed at, 2 on the opposite sides are at right angles to the radial line of 2 at right angles to those. So as we began to look at the details, it became more and more apparent that simple answers, simple geological answers, were not sufficient to resolve many, many interesting anomalies and paradoxes about this very tiny piece of real estate. This exemplifies what I'm talking about, the orthogonal relationship of these. All right, if we look really close, all right, you can see that if we had resolution 50 times sharper from Mars Observer, there is little doubt that we would be in a very different level of discussion than we are right now. But we will have to be patient. Fortunately, now we are going to get that imagery, so it is only a matter of being patient and nothing more. This is what I discovered that began to really intrigue the heck out of me, because if you stand in that point and look across the face, the first thing I noticed was that the upper sight line and the lower sight line, defined as across the eyes and by the so-called chin, bounded an interesting formation located on the rim of this crater, but arrayed at 90 degrees to that sight line. That object, this is a little better close-up, all right. That object really intrigued me because it looked as if it did not belong in its geological context. If you go back one, which we can, you'll see that this is your conventional splash pattern crater. The theory is that in a primordial condition on Mars, circa 2-3 billion years ago, impact of an asteroidal meteoritic type object, and a waterlogged surface is splashed out and then refreezes to form this characteristic 2-lobe splash pattern array. Problem is, this structure is at 90 degrees to the flow. If it had been there when the impact occurred, the splash should have flowed over it, in which case it would be obscured, or it would have dammed it up, in which case there should not be this lobe extending beyond it, which leads to our reasoning that in fact it has to be younger than the crater and not connected at all with its formation. Well, this kind of reasoning, trying to bring the plausible geology together with the implausible morphologies that we were finding, and the fact that it seemed to know, in terms of its optical width, to be as wide as 2 very key points on the so-called face from one point on the landscape, led to the very close examination of the object itself. It turns out to have a very straight top, at least 3 levels. There's an excavated area behind it whose volume is roughly equivalent, as near as we can tell, to the amount of material here, leading to the not implausible idea that maybe something was excavated and piled up to make it. Again, in the model that, in fact, any of this was made, and that, in turn, is a testable model, as you shall see. This is now the best enhancement that Carlotto has been able to do, and you can see that this object not only is intrinsically interesting, it is unique. There is nothing else like it on several hundred photographs that we've examined scattered around Mars of similar so-called rampart craters. It stands all by itself, except it doesn't. It stands on the rim, and it is the exact optical width of the face in terms of 2 key positions, and it seems to have a relationship with another very unusual object. So that was the beginning of our entry into this, which is there were some improbabilities, compounding improbabilities, all nestled in this one tiny piece of real estate on Mars, which made the piece of real estate become increasingly intriguing. Okay, back to the map. So we looked at the cliff. The next object that I want to look at is the city, is the face as seen from the city, all right? Because here's the cliff in the background. Here is the face as constructed by one of our artists in Berkeley, Cynthia Lin, a painstaking clay model created from the two sets of imagery, high and low sun, and then lit with the simulated Martian dawn that one would see on the current environment of Mars, namely the red scattered dust generating all kinds of interesting optical effects. My hypothesis that this was intentional was further amplified by the realization that the entire alignment of this complex was northeast-southwest. And in fact, if you look at the later recreation of the face in the computer, this is Mark Carlotto's three-dimensional shape from shading technique, you'll find that there is a stunning correlation between Cynthia's work some years ago and Mark's work of about a year ago in terms of individual features, the relative heights, the view. This thing looks like a face even if you stand on the surface, as shown to us by two totally different techniques, which brings me back to the solstice sunrise, all right? If you stand here and look across that sight line at this as a profile across the cliff beyond, it turned out that the last time you could have seen a sunrise that was the specific solstice sunrise was about 500,000 years ago, which brings us back to what this character looks like. Because qualitatively, and we have tested this now on all kinds of unsuspecting people that we have nabbed in the middle of the night and shown them the photograph and said, what does this look like? And they say it looks like a monkey face. Now that's interesting, because if we were dealing with a human psychological projection, you'd more reasonably expect maybe Marilyn Monroe or Paul Newman, but a monkey face? In fact, we believe, based on more quantitative measures, that what we're looking at is a pretty good match to Homo erectus, which was a primitive anthropoid hominid, our own lineal ancestor in the fossil record, circa 500,000 to 1.5 million years ago. And the time frames, if our dating is anywhere near accurate in terms of the solstice business, fits. One overlaps the other. Is this conclusive? No. But it certainly impels one, I would think, to ask some more questions. Let's go the other way here. Okay, next object was this. Now, if we go back, all right, here, 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 now we're down here. The map says, because now we've discovered this, that this angle is about 81 degrees, and that leads us along that razor-sharp top edge on the cliff down to this structure, which we found really provocative because as we have moved through its analysis, we have found that it has both intrinsic interest both on Mars and also for what it portends for similar objects that we have just recently recognized on Earth. When I say recently recognized, I'll explain that in a moment. There is a model over here which we have brought that was done for us for the project by Mr. Tom Newberg, who works at the Richard Rush Studio in Chicago. The Rush Studio does exhibit level models for a variety of science institutions and planetaria and museums all over the country. I got a letter from Mr. Newberg about a year ago, and he said, I'm intrigued with your book. Is there any way that I can help your project? And I said, yes, Tom, you can build us some models. Well, nothing happened for a year. And then a few days ago, in the mail, UPS, came this. This is a three-dimensional recreation of this. And if we can, zoom in and look at it under a little different lighting, if we can change the lighting so it isn't uniform flat lighting. I see that you've got the lamp positioned right on top. We can position the lamp down to one side, if that's not too much of a hassle. Can someone do that? Thank you. Just move the lamp, that's it, off to one side, and you'll see there, very nice, very nice. Okay, excellent, okay. That in fact this object has very interesting multiple levels, and it looks slightly familiar. It turns out that it is a very good analog to objects that we have seen in ancient Britain. One in particular, Silbury Hill. Another one, the Old Sarum Earthworks. The proportions and the scale, this thing is about 2 miles across, all right? But the one in Britain is the largest man-made earth-filled structure anywhere in the world. You'll find out that there's another interesting coincidence that I'll get into later, which I will come back to. But I just wanted to demonstrate that not only has this work been proceeding in various lines, but it has been proceeding with a lot of dedicated volunteer effort of people who have been entrained in the search all over the country. In fact, even overseas. Moving on. This is the enhancement of the object. There's 2 little mounds to the north of it that are separated from the top object that we've discerned now on the apex by 60 degree angles. What's important is that if you go from the cliff to the Tholus and then over to this object, that angle is exactly 90 degrees, and that leads us, of course, to consider what this object might be. This was the pyramid discovered by DiPietro and Molinar, and it is really important in that as you begin to look at various contrast enhancements, you discover that, in fact, it is a 5-sided object on a planet where 5-sided objects cannot form. Errol Torin of Defense Mapping, who was supposed to be here this afternoon and present this part of this discussion, and unfortunately had some problems arise in Washington and was unable to join us, has done some very stunning work in the discovery that not only is this structure 5-sided, but that geomorphologically, as you go up through the various possible formation mechanisms, things like mass wasting and wind faceting and sedimentation and all that, he has been able to systematically eliminate every plausible natural mechanism to create a bilaterally symmetric 5-sided object of the proportions and height of this object. There is nothing like this anywhere, not only on Mars, but also on Earth. On any other object or planet that we have looked at in terms of solid lithospheres, things like Triton or the moons of Jupiter or the moons of Saturn, it has 2 long sides and 3 short sides. And what Torin discovered was that this front angle connecting the short sides was precisely 120 degrees. That led him off into a series of calculations and measurements, which resulted into in his own words, the stunning discovery that this object is in fact a coded mathematical Rosetta Stone. It appears to contain, in terms of its internal symmetries and angles, a set of proportions such that if you divide the angles into each other, you get a set of fundamental constants, square root of 2, square root of 3, pi, and e. If you look at the trig functions, you also get the same sets of constants, and if you look at the radian measure, you also get the same sets of constants. It was at this point that we realized that we now had what Arthur Eddington called the beginnings of a science. Arthur Eddington, who was the confirmer, I should say, of Einstein's general theory, said at one point to a Victorian audience, gentlemen, it was a Victorian audience after all, gentlemen, he says, you do not have a science unless you can express it in numbers. Well, with Torin's discovery and decoding of the interior geometry of the D&M pyramid, the hypothesis of an intelligent civilization on Mars went from a nice idea to a serious scientific, numerical, quantitative science of numbers. And it has led us in some very important directions. Because immediately after Errol did this work, which of course we've coded now in the form of several different representations, you can see that we've coded the angles. If you relate to the angles in terms of this table, you can find how we derive the constants, and you can see how we measure them. We're measuring here to about 2/10 of a degree in terms of accuracy, plus or minus. We're dealing with, we think, about 3 significant figures, and I'll tell you in a minute how we got to that level of precision. Most important, we're dealing with overwhelming redundancy, because we're finding the numbers and the constants not once, not twice, but up to half a dozen times. And I'll show you how we do that in a minute. What we have done for the benefit of those who would like to have time to peruse this new data quietly, we prepared an abstract with some of the photos and diagrams, and we're going to present to, 200 first come first servers, those abstracts that we've been able to Xerox up this afternoon, and we will add your name to a longer list, and Joyce Bergstrom will be making additional copies, and we'll give them to anyone who's interested, so you can actually see how we've arrived at this important new level of information and knowledge in the ongoing inquiry. And underestimate the importance of Errol Torin's achievement in solving what I think is a major breakthrough point in the whole 14 years of this controversy. Because from that, we were able to discover that, I was able to discover, that if you then measure the angles connecting the key objects we've just gone through, the city square, the eyes and chin of the face, the top and bottom of the cliff, the apex of the tholus, and the apex of the D&M, you find, if you just follow the color codes, you find the same angles repeated again and again and again, the same relationships, the same trig functions, the same radian measure, the same redundancy, and we think the same message. Messages are defined as signals in the noise. How do you differentiate a signal from a noise? I mean, you guys now are getting into communications, I understand, and signals are easy. Signals are redundant. Signals add and noise cancels. What we seem to have found is a signal in the noise lying at a place that one never would have expected, namely a northern desert of the planet Mars. We think the signal has a purpose. We think this geometric set of relationships, redundantly encoded, were not done because they had nothing better to do, but were done because they may have been trying to tell us something. I now say they, and you'll probably detect that I say they rather confidently. The reason I do that is because nothing we find from Mars Observer can take back this geometry. We can't unlearn what we have found. Something has placed these objects in a configuration which is overwhelmingly redundant and confirmable by anybody who measures the photographs or goes back to the data tapes. And we believe that if anybody does that, they will retrace our steps and will find what we have found. The question before the House now is not, is it there? But in our level of understanding is, what does it mean? What we think it means, and again, this is due in large part to Errol's insight, what we think it means is that they were trying to tell us about tetrahedral geometry. Now, what do I mean by that? If you go back and you look at some of the constants which are found in the D&M, and you can read some of them here, e divided by the square root of 5, square root of 5 divided by pi, e divided by pi, which is the most interesting one, frankly, you find a couple of other intriguing coincidences. You find that the actual geodetic latitude of the Cydonia site, if you go to Mert Davies at RAND, who does the control points for all of the space imagery over the last 30 years, if you go to him and you ask, like I did, find me the coordinates of Cydonia in the best inertial frame that we currently have, you will discover that the geodetic latitude that runs through the apex of this five-sided pyramid is equal to 40.87 degrees, and the tangent of that is equal to e divided by pi. E divided by pi as a ratio is also expressed several times within this structure and within the relationships between this structure and all the others in the complex. So we focused on e divided by pi. What could that, if it was intentional, what could that be trying to tell us? And we discovered a very interesting coincidence. E, of course, is 2.718282 carried out to a few places. And it is the base of natural logarithms. Pi, everyone's familiar with what pi is, circumference of a circle to its diameter in terms of a ratio. But why would anyone want to memorialize that relationship? Well, there is an equation. discovered by Euler, I think, in the 1700s that embodies this, but it's the only one that I know of, and it may be significant and it may not. I'm not a mathematician, so I can't say. But what we did discover was that there's another relationship which is eerily interesting. And that is that if you take a tetrahedron, you know, the first platonic solid, and you put it in a circumsphere, namely a sphere that will neatly englobe it so that all the points touch, and you measure the surface area of the tetrahedron, and you compare it to the surface area of the sphere, you arrive at a ratio of 2.72. You arrive at E. Now that is 2.7269, I believe, or something, or no, it's 2.72169, something like that. Really is 2.7182. If you then divide each of these two numbers by pi, you get a ratio 0.865 and 0.866 that differs by 1 part in 1,000. We have discovered both of these ratios memorialized in the Cydonia complex. And one of the things that we discovered was that the ratio, let me go back once, all right? Here we are. No, I have it out of sequence. Okay, we'll do this and then we'll do the other one. We looked at the latitude of the two main features of the DNM. The apex, can we focus this just a tad? The apex of the DNM, which lies at the latitude of 40.87, and then a latitude that runs through that little bright knob on the front wedge, all right, and touches this left-hand buttress of the 5, which are, there's been some damage over here, so we're looking at 1 here, 2, 3, 4, 5. That latitude line, all right? And what we found is that these two latitudes, if you look at the tangent of this, it's equal to E divided by pi, and if you look at the latitude of this, it's equal to synthetic E, or the tetrahedral ratio E divided by pi. In other words, this object memorializes these two separate ratios in their good time. Let's let them get into the flight here for those of you the mathematical pattern. Particular flow at all, except for years, which I don't think is going to happen. I think we will get more. But if you're right in the face and to take another walk. Thank you.
Hey.
Oh, heck, man, you're still here, hey?
Yeah, I am. I am not a night owl.
Scientists now speculate was created by some unknown race of intelligent beings. And if it is what it appears to be,
Sorry, I will pause that.
Yeah.
Oh, there we go. Here we go. Boom. Sorry. So that's some pretty interesting stuff there for you guys. Guessing everybody's going to bed. We will do another stream here in the next couple days. Also probably on Project Moon Gold, but I will finish things off with the Zachariah Stitchin Hoagland 10-minute video clip that I meant to do that gives a lot better info on this too. But I'll let you guys
get off the live stream before then, and I'll just probably leave your YouTube channel playing and unmute that. But yeah, last thing I'll say is, you know, everybody's talking about the Graviflyer right now as far as APEC goes, and you know that is what you posted on the show. So those who just skip right to the end might, you know, see this last part and think about this: trapped charges in the disks of the Graviflyer, when they are rotating, have physical motion through space, so they have an effect on that space, as we talked about much earlier. And we can refer these as analogous to Birkeland ring currents. And when we rotate charges in opposite directions and they are trapped in position on the top disk, they're protons, on the bottom disk, they're excess electrons. Those trapped charges physically moving through space in a unbalance will polarize that space and pull charges into their axes or eject them out their axes, and you'll have an interaction at the equator between those two counter-rotating disks. So consider the physical rotation of the electromagnetic fields and how they will trap external charges and also influence a physical force on each other, stressing the space around them. Not so much thinking about the matter and what it does to charges in motion, but what those charges in motion do to the space around them. That's the most important part, is considering the physical geometry of that space and how any interaction of electromagnetic waves might influence that interaction. So that's the last thing I have to say. And with that, guys, I've got to head out for the night. I will finish up watching whatever you're going to broadcast here until you end it. Thanks.
Thanks, JP.
Awesome, brother. And sorry, keep catching you at the very end there, Austin. We'll actually do one in the afternoon or something. I've got the events already created, so I'll just reschedule it because we were supposed to do that second one tonight. But we'll probably make it for a couple days from now, get more channels involved in it, and take some of the actual good clips out of this massive shitstorm of a 9.5 hour video and counting, and be able to use it in that. And yeah, much love, everyone, and enjoy this.
Much love, Martians.
Yeah, I will share the link in the description, and then it's freaking wrong stream. This one went too long. I have got all your other description info and whatnot in the video that will come. And
nice. Well, hey, I love coming here and hanging out. I appreciate it. I love all the work that you do. You really pull together some cool shit. So kudos, bro.
Much love. And yeah, just the beginning of so much to come.
Mm-hmm.
Lots of great people, lots of good community all coming together, and just advancing the positive building of humanity and not the idiotic polarization and division and destruction that so many choose to give into.
Agreed. This is decentralized. This is Web3. This is everything that we're doing.
Right? It's see, and that's what we'll do a couple of full episodes explaining this that we can then edit and make into shorts, like 10-20 minute videos that go in depth, and then we can multi-premiere it where it'll go off of Josh's stream, off of like your stream, my channel, and then all of the other partners and whatnot, and actually explain really what these things are and how people can utilize it yourselves, like we are, instead of being afraid of it and be like, oh, it's crypto, it must be like cryptic murder of the elites and blah. It's like, it's whatever you want to make it. It's the metaverse, man.
Yeah, it's whatever you want it to be. It's pretty incredible. It's centralizing very fast, though.
And that's the good thing. That's the essential part of it. And that it's encrypted decentralization that will then provide decensorship prevention for the average person.
Mm-hmm.
Okay, Brett. So here I will load this last little news Zacharias Stitchin and Hoagland video here, and we'll play her off, and then we'll talk to you soon, Austin.
All right. Much love, Martians. Thank you, man. Thank you, everybody, for being here hanging out.
Definitely Martian at heart and old soul.
All right, guys.
Surely no intelligent life could survive there. The surface of Mars, we now know, is covered with meteor craters, gigantic mountains, and deserts that reach around the entire planet. And one thing more, a giant sculpture that many scientists now speculate was created by some unknown race of intelligent beings. And if it is what it appears to be, what does that have to do with Earth? Mars is our nearest and most reachable galactic neighbor, but for some as yet unexplained reason, trying to study this planet has met with failure after failure. Beginning with 2 attempts by the Soviets in 1960, both missions mysteriously failed.
After the problems the Russians had getting their probes to Mars, American scientists started to joke among themselves about some great galactic ghoul that was preventing our missions from getting there too. In November 1964, the Americans launched the Mariner missions to Mars. But as it approached Mars, Mariner 3's camera shroud failed to open, making the camera useless.
It does indeed seem that missions to Mars have met with an unusually high failure rate. But in July of 1965, the American probe Mariner 4 finally brought success and completed the first flyby of Mars. So had Earth scientists at last outwitted the galactic ghoul? Apparently not. When the Soviets then attempted to actually land a probe on Mars, something astonishing happened.
Everything on the Mars probe seemed to be working perfectly, and then it just shut off.
Could it be that there's something out there that's interfering with Earth's efforts to conquer space? Or is it all just an incredible string of coincidences? Whatever the reason, it was 5 years before the United States made another attempt to reach Mars. But in 1976, the Viking probe began sending volumes of images back to Earth from their orbits above Mars, including these.
Encouraged by the success of the Viking probe, the Soviet Union, with international cooperation, launched a set of satellites in 1988. Phobos 1 never even made it to the planet. At some point, it just disappeared.
Phobos 2, the probe that was sent up to look at one of the moons of Mars, apparently encountered something very strange, of which the Soviets had a picture that did surface in the United States.
Of a very massive elliptical-shaped object.
The NASA individuals here that may know about it, of course, would never make a comment on it.
And then it too disappeared.
And 5 years later, the American space probe Mars Orbiter seems to have met the same fate. But what exactly did happen to them? Many researchers now believe the loss of so many Mars probes cannot be an accident, but a deliberate attack on spacecraft from Earth by something or someone near Mars that does not wish to be photographed. Could this be true? Has this bizarre string of space disasters occurred because we caught a glimpse of something we were not supposed to see? Has the Viking space probe presented us with a mystery that is unsolvable? The mystery first began to unfold in 1976, when the unmanned Viking space probe was going about its highly successful mapping mission of our neighbor planet. When the images that were transmitted back to Earth began to be analyzed, this surface feature in the region designated as Cydonia caught the attention of people all over the Earth.
The initial official reaction from NASA about this photograph is that it was just a trick of chance sunlighting. Certainly no one believed that there was a huge carved face on the surface of Mars. Besides, who could have made such a thing? No one believes in the science fiction version of men on Mars. And we know that Mars is not capable of supporting intelligent life as we know it. So the idea of this being a creation of intelligence was not even considered by NASA. Despite all of this, when the image was first recorded, it was labeled head.
But fortunately, the story doesn't end there. The picture caught the eye of image analysis experts Vince DiPietro and Greg Molinar. DiPietro and Molinar undertook the colossal task of discovering what the strange picture really showed.
At first, they just enlarged the photo and considered there was nothing there at all. So Vincent DiPietro and I designed a computer program to enhance the image in much more detail than NASA had done.
And even though their new process resulted in images as convincing as these, NASA apparently continued to insist that the image was nothing more than a trick of the light. And to prove it, they said that Viking had photographed the same area from a different angle and that there was no face visible in the second photograph.
Then we went through the archives to see if there was any other satellite passes over that same area. NASA said there wasn't at first, and we looked through their archives and found one. And there, just as before, there was a face with a higher sun angle showing more detail than before. And images of the eyes showed pupils, and of the mouth area showed teeth. We were very impressed.
Now there were two photographs of the head. Was this proof the image was built by intelligent beings? Did this second photograph solve the mystery, or was it only the beginning of an even greater puzzle? A puzzle with one of the most important pieces found on Earth. The startling answer. UFO Diaries returns. These two separate frames, identified by their NASA frame numbers 35A72 and 70A13, also contain considerable detail about the surrounding area, revealing several other images that DiPietro and Molinar found as exciting as the mysterious face.
About 10 miles away from the face is a couple of pyramids. And the strange thing about those pyramids is they're very regular triangular shape. In the corner of each corner, there appears to be a buttress, and on close examination, the buttress itself is pyramid shaped.
Was this undeniable proof that an intelligent race had once lived on the planet Mars?
This would be really, really remarkable for this to be a natural formation.
Since the time of that discovery, science writer and consultant Richard Hoagland has worked tirelessly to discover the whole truth about the mysterious Cydonia region of Mars.
A member of our team, Dr. Mark Carlotto, decided to use a state-of-the-art 3D computer modeling technique, which now strongly indicates that the face could, in fact, be a real three-dimensional human-looking sculpture, a sculpture 1,500 feet high and over a mile long.
But is it not still possible that these intriguing shapes are really nothing more than accidents of nature? That the researchers who study them are simply letting their imaginations run wild? Many intriguing questions are raised by the apparent connections between this image from the planet Mars and ancient structures here on Earth. Perhaps the most intriguing being, does this image on the surface of another planet give us important clues to the origins of ancient structures on our world? Richard Hoagland's study team may have uncovered proof that one of our oldest relics was not built by human hands.
And as I began looking at some references and books and talking with colleagues, this was a sketch done by Shannon, one of our early artists on the team, we both realized that this image was somehow trying to tell us something profound. It was trying to say this.
Could the resemblance between the face at Cydonia and the Sphinx at Giza be more than a mere coincidence? If not, does all this prove once and for all that these great monuments were all designed and built by an intelligent race from another world?
Did the Egyptians, in fact, as we know them, do this remarkable structure?
Recent archaeological and geological discoveries demonstrate that the Sphinx is at least 10,000 years old and maybe even older.
That is, the Sphinx appears to be much, much more heavily weathered than we have any right to expect from only, quote, 5,000 years of desert weathering. The kind of weathering we see on the Sphinx is best explained by the action of running water. You need rain to get that degree of erosion, 12 feet of it in some places. And that amount of rain has not fallen in Egypt for at least 10, maybe 15 or 20,000 years. Now that raises a wonderful problem. It means that we're now looking at a monumental work of art created at a time when nobody else on planet Earth is supposedly able to do anything of that magnitude or scale. There's no other contemporary civilization to pin it on. So who did it?
Could these both be ancient sculptures made by the same race of beings? If so, who or what is this face intended to represent? The key to understanding the face on Mars may lie in the fact that the Sphinx of Egypt is a combination of hominid and feline, half man, half lion.
It was at this point that we began to worry less about the ultimate reality of the so-called face on Mars and more about the meaning of the message of Cydonia.
An astonishing discovery when UFO Diaries returns. Hoagland's researchers, in comparing the two images, made an amazing discovery.
Maybe there's a connection. Maybe the face of Cydonia is half man, half something else.
First, they copied the left half of the Cydonia head, made a mirror image of it, and pasted it onto the other side.
That's the Cydian half.
The results were interesting, but inconclusive. However, when they tried the same thing with the right half,
this is the bit, isn't it? That confuses me. It's like, did we choose to come here to get this sorted out, or is this just seems a little unfair, doesn't it? That you know, we seem to be here and there's this parasite messing up our experience.
And you know, I know in my own life, the times that I've made major changes, it was like it became more painful not to change than to change. That was when I made big changes.
You know, it's this whole ridiculous narrative of it's an unsafe world. There's not enough for you. It's scary. Everyone's out to get you, and clearly the old civilization was completely the opposite to that. It was all about empowerment, like literally.
Cosmic resonance, I think they called that one. Or
Cosmic resonance, that's a better name.
Real science, you can actually produce free electricity, and this is part of what Tesla was doing, is the differential between the top of the spire to the ground actually creates an electrical differential that you then connect to another wire that goes into the ground, your grounding. Put that into the third phase in your circuit, and then you have a bell ringing circuit, and that actually produces plasma electricity out of the air. It's real technology. These things actually function producing electricity. It's crazy.
The movies are the truth and the news is the lies. They've completely flipped it.
You know, when you look at everything with new eyes and you come across information like she was born into a very wealthy family with elite connections, you know, it means something very different now to me than it would have even a few years ago. And it's our free will that they've really also messed with, because we've been lied to and we react based on lies. And just getting their independence and end up in civil wars for 20, 30 years happens a lot.
Because we keep choosing to pick up the gun and use it on ourselves instead of building and uniting and accepting that we are one people, one spirit, one harmony on one plane that together, united, can achieve anything we dream of.
So do you want to, wake up, or do you want to just keep going along because to change is too difficult?
And then give them pieces of information that they will then pursue themselves and look into, and then they'll wake themselves up.
I was going to mention it's the whole red pill, blue pill of the Matrix. I mean, that of the movie. And you can consider that movie as a documentary because they're telling us something about what's happening here. So do you want to, wake up, or do you want to just keep going along because to change is too difficult? Wake up.